will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Alright, so in the last video we created our first project and created our first Java class called Hello. Let's now add a method to this new class to print out our Hello World message. Alright, so firstly, what is a method? Well, it's a collection of statements, one or more, that perform an operation. We'll be using here a special method called the main method that Java looks for when running a program. It's the entry point for any Java code. So in other words, Java looks for that specific method and is able to start and run the program when we use it. And you'll see how to do that. Now you can create your own methods as you'll see later as well as this one, but for now, let's create this special main method. So the way to do that is going to come up into our class on line 2. And I'm going to tab over. I'm just going to press enter there. Notice that, well, you'll see when I start typing, that IntelliJ is going to start giving you some hints there. So I'm going to start by typing public static. Now notice I typed ST in the word static and IntelliJ is suggesting the word static. I'm just going to press enter there. So anytime you see something that you want IntelliJ to fill in for you, just press enter. All right, continuing on, I'm going to type, now I typed the V there because I need the word void, and notice that IntelliJ has automatically suggested that as well. I'm going to press enter there. Next I'm going to type main. And I'm going to put a left to right parentheses. In fact, I typed the left parentheses and IntelliJ, being ever helpful, added the right parentheses for us. I'm going to type in there string with a capital S. Case is very important when you're programming. Left to right square braces and the word args. Then I'm going to come over and add a left curly brace and a right curly brace as you saw me do there. Alright, so what have we done there? Well, firstly, looking at this statement, public was the access modifier we discussed when defining the class in the last video. It's the same principle here. Static is a Java keyword that needs an understanding of other concepts to really be explained adequately. So for now, just know that we need to have static for Java to find this special method to run the code that we're going to be adding. Now void is yet another Java keyword used to indicate that the method won't return any information, but we'll be talking again more about that later. And just a tip here that you might be perhaps thinking, well, why can't I learn all these things now? But there is a specific order to learning Java, and it pays to learn things in the right order so that things don't get too overwhelming. Rest assured that we'll be going into all these things in a lot of detail at the relevant point in the course. Right, so moving on, we've got the left and right parentheses that I talked about, and that is needed for a method declaration, and that's what we're doing here. By typing in this code, we're defining a method. So the left and right parentheses are mandatory, but they can optionally include one or more parameters, and parameters are a way to pass information to a method. Now more on that again later, and I've said that a few times now, but bear with me. Alright, so here you can see there's been one parameter has been defined, and we'll talk more about what that means a little bit later. For now though, to enable Java to define the main method, it has to be typed exactly like it's typed here. So if you typed something different, like for example if you used a capital P, note straight away when we do that, we suddenly get it highlighted in red, and that's IntelliJ telling us that, okay, I don't understand the word public with a capital P, but if I change that back to what it was, which was a lower one, lowercase p, it's then quite happy and the error disappears. So keep that in mind that often you'll find errors can be purely relating to you typing something in uppercase or lowercase when it should have been the opposite. Alright, so at the moment now we've got our method, so let's try running it. Now we can run it a few ways in IntelliJ. At the moment we haven't got an option up here to run it. In the top right hand corner to the right of where it says add configuration, that run button's disabled for now. But you'll find once we run it for the first time, that or when we run it for the first time, that'll be enabled. But over here we can click on these little buttons here to run it. We can also right click in there and select run as well. You can see there's even a keyboard shortcut to do the same thing. I'm just going to click over here to run our program. Go and run hello main. And you can see down the bottom something's happening. So what's actually happening is that IntelliJ via the Java Development Kit is compiling the Java program, and you can see we've got a little bit of output down the bottom of the screen. Now when I say there's a bit of output, the first line there is the command that IntelliJ sent to Java to execute our program. Then below that we've got this process finished with exit code 0, And what that essentially means is everything's completed successfully. 0 is often used to indicate that there wasn't a problem. And the reason we haven't got any other output, our hello world message for argument's sake, we haven't got that because of course we haven't typed the code in yet. If you have a look at the main method declaration again, there on line 3, notice that the left and right curly braces, I didn't talk about what they were. They're actually a code block. Now the code block is defined or is used to define the start and end of a method effectively, and we can put our code in between those in the form of statements. So at the start, just to recap on that, we got our class. Our class has got the body block of code, which is the left curly brace and the right curly brace of the entire class, and our method is effectively within that class, and it's got its own code block, which is a group of code statements, if you will, that we'll be defining and that are unique to that specific method. Alright, so let's continue on now. The next thing we want to do is we want to print out our message. And to do that, we need to come back to this class, and I'm just pressing tab. And I'm going to tab so it's indented like that. And I'm going to type system with a capital S and a period, out, period, println. And noting that IntelliJ is helpfully helping us along the way. I'm putting in and typing in the left parentheses, a double quote character. And I'm going to type hello world. And notice that when I've done that, I've got the right parentheses and the double quotes were added automatically by IntelliJ for us. Then I'm just going to go over to the right hand side and put a semicolon, and a semicolon closes off the line to make it valid. And notice that if I get rid of that again, we immediately get an error to the right hand side. We've got that little indication to say there's an error, and I put a semicolon again and the error disappears. Alright, so what we've done there is we've added a statement. So what is a statement? Well, that's a complete command to be executed and can include one or more expressions. And we'll be talking about expressions and a related topic, operators, later in the course. For now though, what we've typed in is a command to basically call a method that comes as part of Java called println, and we send it the information of, in this case, the text hello world, and it should print that out on the screen for us. So let's actually try running that. See that it works. And notice now that up here the green arrow is now enabled because we've run our code for the first time. So I can click up there, or I can come over here, either way, to run our program, or I can right click in the main method. When I say in the main method, making sure my cursor's within there, and select run. Either of those ways will do the same thing. And looking at the output pane down the bottom, you can see now that we've got hello world showing on the screen. Alright, so at this point we've actually managed to do something. We've actually printed out the words hello world. Let's end the video here, and in the next one I've got a challenge for you to get you to try making a little bit of a change to this program to print something out. So let's talk about that in the next video. Alright, so moving on now, we saw in the last video that we're able to output the text hello world, and you can see that down the bottom left hand corner. I've got a little bit of a challenge for you here. And the challenge is to see whether you can modify this program so that instead of printing hello world, it prints hello Tim or hello whatever your first name is. So in other words, you just change the output slightly. So looking at the code on the screen, how do you think you'd go about that? Let's see if you can figure that out and get that to run. So basically make the change and then click on the green arrow, the green run icon, to start the program and test it out to see whether it works. So click pause on the video now, so you can actually go away and try that. And when you're ready to come back and check on the solution, come back and restart the video or replay it from where you left off, and we'll go through it together. So pause the video now. Alright, so welcome back. Hopefully you managed to make that first change. So to make the change, all we need to do, come back here, delete the word world, and I'm going to press a backspace there, and I'm going to put in the word, or the text rather, Tim. So hello Tim. And to be correct, maybe correct English might be hello, comma, Tim. Anything like that should be fine. Then of course to run it, we just need to click on the run icon. And there it is, there's the output, hello, Tim. Alright, so that's it. Our first program is now complete. Congratulations if you managed to make that work. And look, even if you didn't, if you got an error, we'll start talking more about errors in videos coming up. But if you've got something like this, we got rid of that semicolon as you saw there. If we actually click on that to run, so you might have saw something like that. Handy thing with IntelliJ is if you see an error like this, and it actually tells you, often it'll actually tell you something that makes sense. It says that it's expecting a semicolon. You can double click that to go to the line. So if I was on line 3, and I double click this error up here, that takes me to the right line. And I can put in the semicolon again to get rid of the error. And if I run that again now, we should find the output now appears without an error. And the other thing is, if you miss like anything like say a right parentheses there, Noting that straight away IntelliJ is telling you there's a problem. You can also hover over that and it's actually giving the game away and telling you there that it's looking for a right parentheses. So it's pretty good at picking up when there's errors. Let's delete a double quote there. Now it's underlined the whole thing in red. Illegal line end in string literal. Now that doesn't probably make a lot of sense to you, but this text in double quotes is called a literal string. So what it's saying is IntelliJ is saying there that illegal line end in string literal. So it's saying that we've got to start here a double quote because that's how we defined the string literal. We didn't add a trailing one, so I'm adding that there now. So there's some of the common errors you'll get, noting that you'll see the error right away, and if you don't happen to notice that and you go to run it, then IntelliJ will helpfully tell you there's an error down the bottom. And again, if you're on a different line number, you can double click on an error like this, and it takes you to the spot where it's found the error. In this case, we need to go to the end of that, and add a double quote again, and then away we go. Run it, and that's our error sorted. Alright, so that's our first program completed. Well done. Let's now move on to the next video. In the last few videos, we saw how to create our first program in Java. It was pretty basic to say the least, printing out some text on the screen, but it was a good place to start. But if we want to start getting the computer to do something useful, we need to start using variables. So what are variables? Well, variables are a way to store information in our computer. Variables that we define in a program can be accessed by a name we give them, and the computer does the hard work of figuring out where they get stored in the computer's random access memory, or RAM. Now a variable, as the name suggests, can be changed. In other words, its contents are variable. So what we have to do is tell the computer what type of information we want to store in the variable, and then give the variable a name. There are lots of different types of data that we can define for our variables. Collectively, these are known as data types. As you may have guessed, data types are keywords in Java. So let's start out by defining a variable of type int, int being an abbreviation for integer, which is a whole number, that is a number without any decimal points. To define a variable, we need to specify the data type, then give our variable a name, and optionally add an expression to initialize the variable with a value. And we'll talk more about expressions shortly. For now though, let's swing back to the code to see how to define our first variable. So I'm going to start below the println line, press enter there, and just put a bit of a gap there so we can see what we're typing. And I'm going to type int, my first number, noting that I'm capitalizing the word first and the word number, equals 5. I'm putting a semicolon on the end of that line to complete the statement. So here we've defined our first variable. We've specified a data type of int. Again, that was an integer, a whole number. And we used the equals operator and the literal value 5 to set the variable to have the value of 5. And finally, we added that semicolon to end the line and form a statement. So the semicolon ends the line and tells Java just that the line's complete. So this entire line as we've typed is a statement, or to be more specific, it's a declaration statement. So a declaration statement is used to define a variable by indicating the data type and the name, then optionally to set the variable to a certain value. So here the type, and type is a shortcut for the word data type, is an int. The name is my first number, and the value we're assigning or initializing our variable with is 5. So we're declaring a variable of type int with the name my first number and assigning the value of 5 to it. The initialization is optional. In other words, we could have omitted the equals 5. With Java in general, variables have to be initialized before being used, but we'll talk more about that in an upcoming video. If you are initializing a number, what you type to the right of the equal sign is assigned as a value to the variable. And this is known, this part after the equal sign, as an expression in Java. And we will be using expressions a lot as we go through the course. So what is an expression? Well, it's a construct that evaluates to a single value. And we won't go into a deep discussion of that now because we've got upcoming videos where we'll talk about that in a lot more detail. Now Java has, or will when we compile and run the program, read this statement we've created and allocate a place in memory to store a single whole number, and will assign the my first name to that area of memory, or more specifically assign that name that we've typed, my first name, to that area of memory. So that's how we'll access it. So in other words, you don't need to know anything about where in memory this is taking place or where Java is storing the contents. To get access to it, you don't refer to a memory location, you refer to a variable name, my first number in this case. So we're leaving Java to do all the dirty work there. Alright, so now that we've declared the variable, let's see if we can print out the value. So looking at the declaration statement, I think we've got a good idea what the value should be output. So the challenge is to look at creating a new system.out.println below the declaration for my first number, that variable, and see if you can figure out how to print out the value my first number. So pause the video and have a think about it and try to get it to print out the value that we assigned to our variable. Resume the video when you're ready to see how to do it. Pause the video now and I'll see you when you get back. Welcome back. So you may have thought when you first started that this would be how to do it. I'm going to give you a typical example. Now what I'm going to do is type S out. This is an abbreviation in IntelliJ, and if I press tab there, note that it handily types in that entire line, system.out.println, and that's a very common thing that we'll be typing in this course. It's good to get used to using those shortcuts. So it's S-O-U-T in tab. Right, so when you first tried this, you might have tried putting double quotes in the parentheses, similar to what we did on line 4 and type my first number. You might have done that, and then when you ran the program thinking you'd get the value in our my first number variable, but when you ran it, you saw we in fact got the output, my first number, and not the contents of our variable that we declared on line 6, which of course the value should be 5. I'll just close that window down. Now the reason that we've got my first, or had my first number printed, and I'll just run that again actually, I probably shouldn't have closed the window. So the reason we've got my first number printing out and not the contents of our variable is because we put the text in double quotes, my first number. And when we put something in double quotes, it's called a string literal. Now a literal, unlike a variable, cannot be changed. It's an expression and not a variable. So here what we're saying is literally, no pun intended, print out the text, my first number. And unsurprisingly, perhaps then after that, we can see my first number showing. So in essence, that's why we're getting that value. But if we actually remove the double quotes, which I'll do now, we remove both the ones at the start, noting we've now got an error on the end, so we need to remove them both to remove any errors. And we run this again. This time we should see the right value, and we can see the value 5 now showing on the screen. So I made sure that I typed the name identically to the declaration line on line number 6, and you can see we got the value 5 showing. So just to confirm that, if we change the 5 to a 10 and run this, we've now got the output showing us number 10. Now the expression to the right of the equal sign can be a lot more complex. At the moment we've just used a literal integer value of number 5, and then you saw we changed that to number 10, but we can get a bit more complex there. So let's add an expression that is the sum of two numbers. So we're going to change 10, I'm going to add a plus and a number 5 there. So I've added an operator and then a number 5, so it's 10 plus 5. So run the program now. And we've now got the value 15 output on the screen. So Java has looked at the expression to the right of the equal sign and figured that that is a mathematical expression, and it's basically calculated that to be 10 plus 5 equals 15, and sure enough we get that value assigned to our my first number variable. Then line 7 prints that out to the screen. Now we can get a lot more complex. Let's do that just before we finish the video. So we can change this to something like, say, let's put parentheses around the 10 plus 5, and then we'll add a plus and another set of parentheses, and now I'm going to put 2 multiplied by 10. That should give us 35. 10 plus 5, that's 15 plus 2 times 10. The 2 times 10 is 20, so that's 15 plus 20 is 35. Let's run that. And sure enough, we get the value 35 showing. So you saw that I introduced an operator there. I called it an operator. In fact, we've got a number of operators there. We've got the plus operator and the multiplication operator showing. So Java operators, or just operators, perform an operation, hence the word, on a variable or value. Plus, minus, divide, and multiplication are 4 common ones that I feel sure you're familiar with, but there are lots more operators, and you'll be seeing those as we go through the course. By the way, if you want to get a downloadable list of all these slides, navigate to the last section of the course and look for a lecture called Downloading Slides. Alright, so let's end the video here, and in the next one, we'll figure out how to use other variables in expressions. See you in the next video. In this video, we'll extend what we've done to using other variables in expressions. To date, we've used literal values in our expressions and used operators, such as in the example we ended up with on line 6, which was 10 plus 5 in parentheses plus 2 times 10 in parentheses. We need to declare 2 more variables, and I think it's time for a challenge to get you to do just that. So the challenge is to create additional variables, 2 in fact. So we want to declare the following variables and add them to our program. We want a variable called mySecondNumber, which is an int, and you want to assign a value of 12 to that variable. And the second variable to create is called myThirdNumber, also of type int, and assign a value of 6 to that. So put the declaration statements above the system.out.println, and you'll see why later on in the video. So for now, pause the video, add the declarations for our 2 variables to the program, and come back and resume when you're ready to move forward. Pause the video now. Alright, so welcome back. Let's go ahead and add our 2 additional variables. We'll declare 2 lines there, and we'll do it immediately under our first line and above our system.out.println. We'll do the first one will be int mySecondNumber is equal to, and we wanted the value for 12 for that, semicolon to end the line, then int myThirdNumber equals 6, semicolon. Alright, I'll just put a return there just to space out the code. Alright, so that's our 2 additional variables. Is there a way that we can sum the values of mySecondNumber and myThirdNumber into another variable? Why yes, there is. So instead of using a literal number, which is all we've really seen so far in the course for assigning a value to our variables, let's use a variable name directly in the expression. And we can do that by typing int myTotal is equal to, and let's actually start by typing myFirstNumber, noting that IntelliJ is helping us here, plus mySecondNumber. And the good thing about this is we're not limited to 2 parts in this expression. We can continue. So let's add another one, plus myThirdNumber. I'm going to add a semicolon to complete the line. Now, if you had the variables or expressions that you wanted to add, you could keep going and make this an extremely complicated expression. Java will quite happily read that and convert it and be able to process that. Right, so the expression now, according to me, should be myFirstNumber. And we know that my first number was 35 because we can still see in the output. My second number is 12 and my third number is 6. So 35 plus 12 is 47 plus 6 is 53. Let's try printing that out. But just a note here first, note that we're printing out my first number and not my total. And I just wanted to point out there that if we hover over this one here, this variable myTotal, IntelliJ helpfully tells us that it's not in use. This is a great way to know of any variables that you've created or declared and haven't actually used in your program. So here it's just telling us that it's never been used, and notice that it's also in a light grey to indicate that. So what we need to do is change this myFirstNumber, and I've just double clicked that. We want to double click any part of that name. IntelliJ helpfully highlights the whole thing so that I can just type, and since I start typing it gets deleted. And we've got the variable down the bottom there, total. You can use up or down arrow keys if I want to select it, and there's the output, which in this case is myTotal. So now if I run this program, we should see the value of 53, and there it is, 53 showing on the screen. And just to show you another example, let's change myThirdNumber. Currently that's defined to be the value 6. Let's change that to be, instead of 6, to be myFirstNumber multiplied by 2. So now what we've done is we've assigned myFirstNumber, we know the value is 35, times 2 is 70, so my third number has now got a value of 70. So myTotal equals 35 plus 12 is 47 plus 70 should be 117. So let's run this and confirm that we've got that value. And there's the result, 117. Okay. Right, so let's end the video now with a challenge. So your challenge is to create a new variable and call it myLastOne. We want the value to be 1000 less the current value of myTotal. And the data type should also be an int. And then you want to print out the value of myLastOne on the line after you declare it. Now, as a hint here, we need to use another operator that we haven't actually used in the code before, but if you think about this, it should be easy to figure out which operator you need to use for this. Right, so pause the video, see if you can complete the challenge, and when you're ready, come back and resume the video. Go ahead, I'll wait here, pause the video now. Alright, so welcome back. So hopefully you managed to complete the challenge. Let's see what we can do here. What I'm going to do is start after the system.out.println, and I'm going to type in there int. My last one is equal to, and we need to figure out 1,000 less the current value of my total. We can just type 1,000 and use the new operator we haven't specifically used, which is the minus or subtraction my total. So we wanted the value of 1,000 minus my total, which is what we've done here. Semicolon to end the line, and let's use the sout template, and then we'll type in my last one to print out the value. Let's run this, and we should see 1,000 take 187. If my calculations are correct, it should be 883. And there we go, that's the value of 883. Alright, I just want to end by saying if you ever get stuck here and you're finding weird errors, one of the first things to look at is its spelling of a variable name and the case you use, whether it's up or lowercase. You'll see later on that there is a need for things to be in uppercase, but most of the time the keywords will be in lowercase, and variables need to be defined exactly how you've specified it. So in other words, with my last one, I couldn't put a capital M here. When I tried to print it out, I'm getting an error there because my last one was defined on line 11 as my last one with a lowercase m, and it's using an uppercase M on line 12. And as a hint there, again, we saw this before, but we're getting a note here from IntelliJ that that variable is not being used. That can often be a good hint that you made a typo and to go back and actually fix it. Like so. We'll just run it again to make sure we're good to go. Alright, so that's variables. Now later on in the course we'll be looking at best practices for naming variables, because there is specific rules we should follow, but we'll tackle that later on in the course. For now though, we've looked at one data type so far, which is of type int. In the next video, we'll be looking at some more. So I'll see you in that next video. We've been working with the int or integer data type so far in the course. Now technically that's known as a primitive type in Java. So in Java, primitive types are the most basic data types, and int is one of 8 different primitive types. The 8 primitive data types in Java are boolean, byte, char, short, int, long, float, and double. So consider these types as the building blocks of data manipulation. So let's explore the 8 primitive types in Java over the next few videos. Right, so what we're going to do is close down our project that we were working on in the last video. File, close project, and I'm going to create a new one. So let's do that. I'll click on Create New Project as we've done previously. I'm going to leave Java selected and the project SDK as it was. This time I'm going to check Create Project from Template because I want to show you that we can automate some of this code and get IntelliJ to do some of the things for us that we had to do manually when we created our last project. Click on Next. Now here for the project name, I'm going to call it byte, short, int, long. And these are 4 primitive types which we'll be going through in this course. Now notice this time when I did that, under the project location, we've got our current project location, but it's automatically created the subfolder. I mentioned that it will do that, and it is actually doing that. Now the other thing I want to point out here is this base package. Now at the moment I'm using academy.learnprogramming. So what actually is a package? Well, a package is a way to organize your Java projects. For now, consider packages as folders, with Learn Programming in our example being a subfolder of the Academy folder. Now companies use their domain names reversed as a package, so learnprogramming.academy, which is our website, becomes academy.learnprogramming as a package. Now we will go into a lot more detail about packages when we need to later on in the course. This time we're going to get IntelliJ to create the class for us as I mentioned, and that's why we checked the checkbox on the previous screen. So we'll leave that checked, and I'm going to click on Finish. Now notice that this time by doing that, 2 things have happened. Firstly, we've got a class there created, main.java. We've got the package statement on line 1, but also we've got this public static void main method that we've talked about created for us as well. And there's a helpful little line there on line 6 saying write your code here. So it's telling us where we can start coding. And if we expand over the project here, click on the source folder, Notice the packages, we've got Academy and Learn Programming. I'm clicking those and there's our file. You can see that our main class is in the Learn Programming part of the Academy.Learn Programming package. But again, more on packages later on in the course. For now, I'm just going to move this over a little bit because we don't really need to refer too much to the project. Alright, so if you remember in the previous video, we created some code that did something like this. I'm going to come over here and I'm going to delete that bit of text there, which was actually a comment. I'll talk about comments a little bit later. So in the last few videos, we did something like int my value equals 10,000 semicolon. So what that was doing, if you recall, was creating a variable called my value of type integer, and we were initializing it with a value of 10,000 in this case. So the computer has allocated enough space to store an integer, and it's assigned a name for that variable of my value. But what actually is an integer? Now we know that it's a whole number, but what can we store in an integer? Is the range infinite? Well, it turns out there is a range, which is usually the case for most data types. There's a minimum and maximum number that can be expressed or stored in an int. So let's type in some code. I'm going to show you how you can determine the range of a primitive type. So we can type in this code int my min int value. We're using this for the minimum value. We're going to type equals integer with a capital I, period, min. And notice that min underscore values. I'm selecting that by pressing enter, semicolon. Then we're going to do the same for max, so int my max int value this time is equal to integer, period, and this time we're going to use max underscore value. And let's now print those out. So I'm going to type SOUT for a shortcut for system.out.println. Now I'm going to use double quotes. Here's that option now I'm going to show you to display both text and some data on the same line. So we can put our header or comment that we want to show, integer, minimum value, equals, then we've got the closing double quote there. Then I'm going to add a plus operator, my min int value. So I'm using the minimum value there. And what I'm going to do is take a copy of this line. I'm going to paste it. You could type it if you prefer. And I'm going to change minimum to maximum value. I'm going to change min over here to max. So you can see what we're doing there is we're printing out both the minimum and maximum values. But the point here in terms of the double quotes and the value is we've entered the text that we want to display on the screen, then we've added a plus. And what happens is when you start out using a literal string like we're using here, then we use the plus operator. Whatever follows the plus operator is converted to a string and gets outputted. So it's a handy way to combine text and in this case numeric output. It's not the best way to do things, but at this point in the course, it's perfectly acceptable. Now we're using integer instead of int. That's because int is a primitive type that really only gives us the option to set the variable's value. Integer, on the other hand, is what's called a wrapper class. So Java uses the concept of a wrapper class for all 8 primitive types. Now in the case of an int, we can use integer, and by doing that it gives us ways to perform different operations on an int number. So in this case, we're using the min underscore value and max underscore value to get Java to tell us what are the minimum and maximum numbers that can be stored in an int data type. Right, so if we run this program now, so you can see a minimum range here is minus 2,147,483,648, and the maximum value can be 2,147,483,647. So min underscore value there is the smallest value that we can set an int to, and max underscore value is the biggest. So just to confirm that, let's try adding +1 to one of these values, use it for the max value, and see what happens. So to do that, I'm going to type some code under here. We're going to do another sysout or sout, double quotes. We're going to put busted max value is equal to, then we're going to put double quote there, then we're going to do a plus, then we're going to add parentheses here just to make it clear what we're doing here. We're going to get the my max int value and add 1 to it, which technically shouldn't be possible because we've already established that line 10 contains the maximum value of an integer. We're in fact trying to add 1 to it. So note that we haven't got an error here, but if we run this, look what's happened to the maximum value. So we've assigned the maximum value plus 1. And what's happened is that the number, busted max value down the bottom there, has turned into a minus number, to a negative number. Now this is called an overflow. We tried to put too large a number into the space allocated by the computer for an integer. Now it didn't fit, so the computer tried to fit it anyway, and by doing that it overflowed. Now the reverse is also true here. So if I change that, or actually add a new line, when that's out, we'll put busted min value is equal to, now double quote plus, and then parentheses again, we'll put my min value plus 1. Now if I run that, actually what we'll do is we need to do a minus 1 there, and the reason we need to do a minus 1 is we're trying to get a number that's less than the current minimum number. So we put a minus there. Let's run that. And you can see what's happened there. In the case of our busted number, I've made a typo there, so let me fix that up and run it again. So I've established that the minimum value is a minus 2,147,000,000, but by trying to deduct 1 off that minimum number, we've sort of cycled around to the maximum value. And this is a concept called underflow this time, and not overflow. So if you try and put a value larger than the maximum value in Java, or a value smaller than the minimum value in Java, and we've done both in this video, then you'll get an overflow in the case of the maximum value, or an underflow in the case of the minimum. So what's happening is the computer just skips back to the minimum number or the maximum number, which is usually not what you want. So it's an important concept to be aware of. So clearly here, overflow and underflow is a bad thing. We don't want that happening with our code, and as we'll see in the next video, there's a data type to hold much bigger numbers if we need them. But ultimately, as a programmer, it's our responsibility to use the appropriate data type and ensure the range of numbers we're trying to store in that data type is within the range, in this case the min value and max value. Now note that if you just type a number bigger or smaller than the max or minimum value, Java will flag that as an error. So in other words, if we use it as a literal. So to see what I mean, I'm going to grab the largest maximum value from our output. So I'm just going to double click that and do a Control C, Command C on a Mac. And if I type in now int my max int test is equal to, I'm going to paste that value in. Could have just typed it in. Clearly we haven't got an error there. And just to confirm, we run the program, we won't see any different output because we haven't printed out a message. But if I try and increase that manually by 1 now, we've suddenly got an error. And you can see there the error is telling us the integer number is too large. And what's happening here is because we've typed a literal value for an integer, and IntelliJ can then figure out and know that, okay, that number is clearly outside of the range of the maximum number that can be stored, and we can flag it immediately, unlike what happened with the code on line 13 and 14, which didn't really tell us anything until we ran it. And in fact, even then didn't give us an error. So any literal number typed without any other character at the end is assumed to be of type int, but more on that in the next video. And just one last point I want to make is you might find that that's a little bit unreadable. We'll change that back to a 7 so it's no longer got an error. You can also use underscores, so we can put 2,147,483,647. So you can enter it in that format if that's easier for you to understand and to read at a glance. Either way is acceptable, either entering it like a number on line 16 or as we've done on line 7, both of those ways are perfectly acceptable. I will say with that said that I don't see a lot of code out there using the underscore approach, but it's valid from Java 7 and higher, so any version of the Java development kit from version 7 or higher, it'll work. Alright, so let's end the video now. We know a bit more about the int, and in the next video we'll get introduced to 3 more primitive types, namely the byte, the short, and the long. See you in the next video. Alright, so let's introduce 2 other data types, or more correctly primitive types in Java, the byte and the short. Then we'll introduce a third one later on. So we're going to start by closing down the run window and click on this little option down there to do that. And I'm going to start typing after line 16, byte this time, B-Y-T-E, and we'll call it my min byte value. We're going to do the same thing we've done for integer, but for byte. We're going to make that equal to, this time instead of integer, we're going to use the word byte with a capital B, and a period, min underscore value, semicolon. We'll do the same for the maximum value. My max byte value is equal to byte with a capital B, period, this time max underscore value. Let's then print them out as we've done above, and we'll put byte minimum value is equal to, closing double quote, plus, then our my byte min value. And we'll take a copy of that line again, paste, and we'll just change this to maximum. Then we need to change the variable on line 21 to be max as well. Alright, so let's run this and we can see what the minimum and maximum ranges are for a byte. Now you can see that in that case, for a byte, the range is quite small. The minimum value you can go down to is minus 128 and the maximum value is 127. So the range is quite small, and frankly you probably won't be using the byte data type a lot. Now maybe if you had a requirement to store a lot of numbers that are within that range and you want to save memory, but also it could be a good idea if you were doing that to use the byte instead of say an int if you wanted the fact that there were a small range documented. So using a small data type is actually code documentation in the sense that someone would read the code and then note that you're using a data type, in this case that is quite small, and that there was a specific reason for it. But with that said, today's modern computers mean that you perhaps can be a little bit lazy with memory and not worry too much about space and how much is being used. But keep in mind there can also be performance reasons that come into account. A smaller data type takes up less space and can be quicker to access. But in general, another thing that probably won't affect you much due to the speed of today's computers, but certainly was a factor when Java was first created. Right, so that's the byte data type. So let's create another one now. The next one we're going to look at, the next primitive type, is our short value. So let's do the same thing with that. We're going to select that. I'm taking a copy of the 4 lines there, and I'm going to paste the code into there. Alright, now we've got an error there, and that's because we're reusing the same variable names. So let's actually use the search and replace functionality built into IntelliJ to make these changes for us automatically. I'm going to go to find, replace. Alright, so first things first, I'm going to change byte with a capital B. I'm going to change that to short with a capital S. So I'm going to make sure that to match case is checked there, so we're only updating the ones that match precisely with case. Replace all. Then what I'm going to do is come back here and replace byte with a lowercase b with short with a lowercase b, and do a replace all for that as well. And that should be our code change. So basically we've just swapped out the word byte for the word short. We should be able to now print out those values. So let's do that and see what range a short can contain. We can see the short minimum value is minus 32,768. The maximum value for a short is 32,767. So both the byte and the short have the same overflow and underflow issue, but obviously with their own range of numbers. So let's have a brief talk about how much space each of the data types we've talked to take up in memory. Right, so I want to talk about the size of primitive types and what width means. So a byte occupies 8 bits. Now a bit is not directly represented in a primitive type. We have a Boolean, which is not really the same thing that we'll discuss in a future video. But we can just assume that a byte occupies 8 bits. Now we can say therefore that a byte has a width of 8. Now a short, on the other hand, we saw that it can store a larger range of numbers, and for that reason it occupies 16 bits and has a width of therefore 16. Now an integer has a much larger range, as we saw again compared to the byte and the short. Well, that occupies 32 bits and has a width of 32. So the point here is that each primitive type occupies a different amount of memory. We can see that an int now needs 4 times the amount of space that a byte does, as an example. Now it's not particularly relevant for you to know these numbers, but it's something that could come up as an interview question, and it's useful to know in general that certain data types take up more space than others. Alright, so there's one more data type, and that's of use where you've got a number that you want to process that's larger than the amount for an int. So we call that one the long. So let's go ahead and add some code for that. So we're going to type long, my long value is equal to 100. Now technically what I've done there is wrong, because when you're assigning a long value, you need to put the letter L on the end of it, and that tells the computer that it's a long value. So we can go ahead and do something like this. We can put an L there, and you can see that if we hover over it, long literal ends with lowercase l, and it actually tells us that could be confusing as lowercase l looks very similar to a 1. So for that reason, When you're doing it, I suggest you always use the uppercase L to make it clearly stand out as we've done here. So the long has got a width of 64, which is obviously double the size of an int, which we established had a width of 32. So it means it's double the width of an integer. So the actual number we can store is huge though in a long primitive type. It's actually 2 to the power of 63. So let's grab the code we've done for short and do a similar thing that we've done previously. We're going to copy it. I'm going to paste it under our long definition, our declaration for my long value on line 28. And we'll do a copy, let's search and replace there. Now it's Control R, we saw last time with the shortcut. So firstly I'm going to do short and replace that with long with a capital L, making sure match case is selected, replace all. I'm going to do the same for short as well, so short to long, same thing there, replace all. Alright, so now that we've done that, let's just close down that search and replace, and we'll right click and run this. And let's see how big the range of numbers can be. Now if I just scroll this up a little bit, contrast that to the size of an integer, and it's significantly larger. As you can see, it's a pretty big range of numbers there. Now yes, it has got the same type of overflow and underflow problem we've discussed for the other primitive types. Now I'll just minimize this again, we'll go down and we'll close it off. So by default, Java considers a number you type as an integer unless you add a letter on the end, as we did on line 28. This forces Java to treat that number as a long. But you might be wondering though why the long declaration worked without an L. After all, when we first started, we didn't put an L there. And you can see clearly we haven't got an error on line 28 by removing the L. Well, the reason is that an int fits fully into a long, because obviously a long is twice the width. So Java is smart enough to know that and just converts the int to a long for us instead of giving us an error. However, if we try and type in a literal value for a long without the L, we will get an error. So we know previously we've used the maximum range there. So if I copy this maximum int test number there, which we know was the maximum number. So if I come down here and create a new variable, we'll call it long, big long literal value, equals, firstly if we do that, put a semicolon there, that works. We know that that's the maximum integer number, and so IntelliJ is quite happy to accept that. But if we change that and put an underscore 234, suddenly we've got an error there. And we can see there, that's the hint, integer number is too large. So clearly Java is telling us that it's still treating that number as an integer. And you can see that's why the default whole number is an integer in Java. So we put an L on the end there to treat it as a long, and you can see suddenly that number has been accepted. And just to confirm that, we can then print that out. Let's go ahead and do that. Do an S out, big long literal value. If we run that code, see down the bottom, our largest number clearly is correct. It's got the 234 on the end. And I'm not going to attempt to read that number out. Now just before we finish the video, Java's also smart when it comes to converting numbers from int to say a short. So it knows if the literal value we're going to use is not going to fit into a short. So to see what I mean there, if I add this code, if I type in short, big short, literal value is equal to 32768, and we established that 32767 was the maximum number, and we can have a look at our code there. Maximum value, short maximum value is 32767, so clearly we've got an error there, and it's saying incompatible types required a short, but found an int. But if we change that to a 7, which we know is valid, the error's just disappeared, and Java is quite happy with that because it knows even though the number is an int, which potentially is larger than the maximum that can fit in a short, in this particular case the literal number we've entered doesn't exceed that, and it can actually fit directly into a short. Right, so let's finish the video here, and in the next one we'll start talking about a bit of arithmetic using these data types, and then we'll talk about another important concept called casting. So see you in the next video. So let's have a discussion now about arithmetic with these different data types. In previous videos we did some basic arithmetic using integers. Now we can do something similar with these other data types as I've mentioned, and just as a recap, let's start by going back here and typing int my total is equal to, and in parentheses, my min int value divided by 2 using the slash operator. So that's just a simple bit of arithmetic that takes the value of my min int value, which of course is the minus 2.147 billion number divided by 2. No problems with that. Let's try the same thing with the byte data type. So byte, my new byte value is equal to, then parentheses, my min byte value divided by 2. Now suddenly we've got an error. So why have we got an error? We know that if we use a literal value and the number fits, then there's no problem. And clearly here now we know that we're using the minimum byte value divided by 2, which clearly would fit normally in a byte data type. But here we've got an expression that uses a variable and it's been divided by 2. That's the difference compared to what we've done previously when we've used a literal value. Well, the problem comes about because the default whole number used by Java is an int, and that's why we've got an error here. And to see that, if we hover over it, that really gives it away. It says required byte, so it's looking for a byte to store the value into our byte variable, but it's found an int. So basically what's in parentheses is treated as an int by the computer, and that's why we're getting this error. But we know the expression will result in a number that fits. So how do we tell Java that? Well, we do that by using a concept called casting. So casting means to treat or convert a number from one type to another. So we put the type we want the number to be in parentheses, like you can see on screen. So we've got byte in parentheses in front of our expression, which in this case was parentheses my min byte value divided by 2. And a note there that other programming languages have casting. This is not just a Java thing. So to do that, then we'd look at line 40, we'd come in here and we'd put left parentheses, byte, right parentheses and a space. And you can see the error has now disappeared. And because we've used this cast, we've told Java, treat this value following the parentheses byte parentheses as a byte, and the error then disappears. And we're really being specific here in telling Java that this is a byte, so treat it as a byte instead of the default, which was an integer. Now we can do this exactly the same thing for short. So we can come down here, and I'll just scroll up a bit, so we can type short. My new short value is equal to, we can start by putting my min short value divided by 2. That gives us the same type of error, but this time it's required a short and found an int again. Using a cast, we can do left parentheses short, right parentheses and space, and the error then disappears. So generally speaking, an integer is the whole number you probably want to use, and you can probably guess that now because Java is using an int by default, and that's more or less telling us that that's what it's expecting to use most of the time. So if you don't specify a type that you actually want to convert to, then the integer is assumed automatically by Java, and you saw that in these cases we got an error because of that. And in the case of the code on line 38, we are using an int variable, and that's why I didn't have any problem with the result also being an int. So in general, my advice is to always use an integer unless you've got a really good reason to not do that. Alright, so let's end the video here, and in the next one, it's time for a challenge to solidify some of the information you've learned in the last few videos. So I'll see you in the next video. Alright, so it's time for a challenge. So your challenge is to create some variables. The first one is a variable of type byte, which you can set to any valid byte number. Doesn't matter. Also then do the same for a short variable, setting it to any valid short number, and then create an int variable, setting it to any valid int number. Lastly, then create a variable of type long and make that equal to 50,000 plus 10 times the sum of the byte plus the short plus the integer values. So that's your challenge. See how you go. Pause the video, go away and do that, and when you get back I'll go through and show you how to do that. Pause now. See you when you get back. Alright, so how did it go? Did you manage to figure it out? Well, let's make a start on that. So what we're going to do, firstly, is I'm going to create a new project. So we're not going to use the existing one. The code's available if you need to get access to that. I'm going to create a new project. I'm just going to call this one. I'm clicking on Create Project. We're going to call this one Primitive Type or Primitive Types Challenge. We're going to put the code in there just so it's separate from the code we've been working on. Right. Alright, so we're going to start off by creating our variables. If you remember, there was 3 that we needed to create. We've got a byte. We'll call that one byte value. We'll set that equal to 10. Again, it could be any value. Short value equals 20, and int value, set that equal to 50. Then our long variable, long total is equal to 50,000. I'm going to put an L there to signify that it's long, but bearing in mind that we don't have to do that because Java will assume an integer type and automatically convert that to a long. But I'm going to put it anyway, plus 10L multiplied by, then we need to multiply the sum of byte value plus short value plus int value. So byte value in parentheses plus short value plus int value. Closing parentheses and a semicolon to make the line valid. So that's actually the solution. And just to confirm this, let's actually just print out the value long total. Okay, we'll run the program. And you can see we've got the result 50,800. Now there we didn't need to do any casting, and again we've talked about the reasoning for that is an integer value which these results are assumed. To the right hand side this is assumed to be an int value, but we've established that longs work quite nicely with ints, so we don't need to do any casting. But if we wanted to do something similar with say a short, and I know this is not part of the challenge but we're just going through it anyway, then we'd do something like short total is equal to parentheses 1000 plus 10 multiplied by, and then parentheses byte value plus short value plus int value. Now clearly we've got an error doing that, and the reason we've got an error is we now do have to cast, and if we hover over it, required a short and found an int. So we need to be specific here and put a short at the front of the expression there, which specifically, and I'll just press enter there. This is something else you can do with Java, by the way. You can actually go over multiple lines, and Java is smart enough to determine that this statement is over 2 lines. We've got a semicolon on the end of the second line, and it quite happily accepts that. So the point of all this after solving the challenge was just to suggest that integer is the best primitive data type for whole numbers to use generally. But even if you're using type long, you saw that Java handles a lot of the complexity for you, and you don't have to do this casting with a long. And the reason for that was because the long will happily accept an integer, because of course a maximum integer value will always fit within a long value. So that's bytes, shorts, integers and longs, 4 primitive types. So we've still got 4 to go, and in the next video we're going to start talking about decimal numbers, because of course to date we've only been dealing with whole numbers, but it can be a very common requirement for you to want to use decimal points. For example, you might want to convert pounds to kilograms or something of that nature, and in that scenario having the ability to use decimal points in a number would be really useful. So let's start working on that in the next video. So far we've only dealt with whole numbers in this course. It's now time to start looking at floating point numbers. Now what I've done here is I've created a new project called Float and Double. So let's go through now talking about floating point numbers. So unlike whole numbers, floating point numbers have fractional parts that we express with a decimal point. 3.14159 is an example. So floating point numbers are also known as real numbers. We use a floating point number when we need more precision in calculations. So there's 2 primitive types in Java for expressing floating point numbers, and that's the float and the double primitive types. The float is a single precision number, and the double is a double precision number. So precision here refers to the format and amount of space occupied by the relevant type. So single precision, and that's the float primitive type, occupies 32 bits or 4 bytes, and as per our discussion previously of width, that means it's got a width of 32. And a double precision, and that's the double primitive type, is double that. So it occupies 64 bits or 8 bytes, and thus has a width of 64. And you can see on the screen there the float and the double ranges there, and that should confirm to you that the double is basically has a much larger range and more precision than the float. Alright, so now that we're back at the code, let's confirm what we saw on the slide, what those ranges were, and do something similar to what we've been doing for other primitive types by using their min and max values. So what I'm going to do now, I'm going to double click up here, and if you do that, that puts the code on full screen, and I'll try and do that for all future videos just to make it clear, because we don't usually need the project pane open, and if we do, we can just open it for that purpose. Alright, so I'm going to start by typing float. My min float value is equal to float.min_value. And we'll do the same for max. My max float value is equal to float period max value. Let's print both out. We'll go float minimum value is equal to plus my min float value. And you probably notice as we're going through the course now, as we've gone through a concept a number of times, I'm not going to repeat and say all the code. So in that case, I didn't talk about the double quotes. Because we've done this a few times, that should be hopefully coming second nature to you. And likewise for the abbreviations for S out, I'm just typing those now, assuming you are familiar with those now. So we'll do the same for float maximum value equals, and then we want my max float value. All right, then the other thing we'll do is we'll just take a copy of that, paste the code in, and we'll just do a quick search and replace, and do the same for the double primitive type. So we'll replace float with double. You've seen me do this before now, making sure match case is checked, and the same for the uppercase version. Okay, replace all. All right, and we'll close down the replace window. Search and replace window. All right, so we've now got the capability to check those minimum max values for both the float and double primitive type. So let's do that. We'll run the code, make sure that it works. Okay, and there's our output. I'll just put that up a little bit more so we can see. Okay, and that confirms the ranges that you saw on the slides. So you really can see there that double can work with a much bigger range of numbers, and it's also a lot more precise than the float. But of course, on the other hand, it needs twice the amount of memory, 64 bits or 8 bytes, to store that number compared to the float, which requires 32 bits or 4 bytes to store its number. All right, so let's move on now. Let's actually start typing in a bit of code. What we're going to do now is start having a look at how to use some of these variables, and we're going to actually add an integer, and you'll see why later on in the video. My int value, we set that equal to 5. We'll do the same for float, so my float value is equal to 5, then double my double value equal 5. Now notice that I haven't put anything on the end there. We haven't put an F or a D or anything there, and it's been accepted. In general, the double data type is accepted as the default, much in the same way that the integer data type is accepted by default for whole numbers. So we can also put a D there or an F there to confirm that, and it's good practice to do that in general if you're typing in literal numbers to make it abundantly clear of the meaning. All right, so that's a way of declaring the three variables, the int, the float, and the double. Now that works fine for a whole number, but you'll find that if we add a number with .25 for 5.25 decimal, and if I remove the F there, we'll actually get an error. Now the reason is that the double is assumed to be the default floating point number, so we've got a similar problem that we saw with other data types in previous videos. And if I hover over that, you can see that it's requiring a float, in this case a literal value that we've typed in, and it found a double. So you can see there that by default a floating point number is assumed to be a double by Java. Right, so quick challenge there for you. Thinking back to our discussion on casting, which if you recall we used to convert an integer both back to a byte and then again to a short, how do you think you'd do the same for the float to remove this error? So have a think about that, pause the video and try it out and see if you can get it to work and to remove the error. When you're ready, come back and resume the video and we'll go through the solution. So pause the video now. Okay, so welcome back. Let's get this working, and we need to use a cast. If you remember, the format of the cast is left and right parentheses. So I'll start with the left one. The name of the data type you want to convert to, float, and I write parentheses, and I usually put a space there just to make it clear. So what's happened there is the error has disappeared, as you can see there now, and that's because we're telling Java, yes, this is a literal double that has been typed here, but we want you to treat it as a float, and for that reason, the error then disappeared. Generally not recommended to do that. Well, there's two reasons. Firstly, as I'll talk about in the next video, floats aren't usually recommended to use much these days. Double is the preferred floating point data type to use. But secondly, it's a lot clearer. I think you'd agree, comparing that to adding an F on the end there. It's just easier. There's less to actually look at, and the F straight at the end tells you, okay, that's a float. And that's generally the format that most programmers would use. They would use an F to indicate the type rather than trying to cast it, which is just a little bit more code to look at. All right, so let's finish the video here. In the next one, we'll start exploring more about these floating point types, and we'll start doing some division to see what happens and what those numbers look like. So I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
All right, so continuing on with our floating point discussion of the float and double primitive types, let's start out by deleting the 0.25 from both our float and our double variables. And let's actually print out these values. We'll do it to all three. So we'll print out the myInt value is equal to, then we'll add to myInt value. We'll do the same for the other two. My float value, make that equal to plus my float value, and we'll do the same for the double. The double value equals plus my double value. All right, so let's just run that to see what it looks like. And we can see there that the myInt value is showing 5, no surprises there, but the float and the double are showing the points, so 5.0 and 5.0 both for the float and for the double value. And obviously that's because, no surprises, it's a floating point number. All right, so let's now try doing some division to see what happens. So we're going to go back and we're going to put, for the first line, line 17, we're going to put divided by 2 there. And we're going to do the same for float. So we're going to put divided by, we're going to put 2f there because we want to divide by a floating point number. And the same for the double, divided by 2d in this case. So we're doing a simple division for all three. Let's actually run that and see what happens. So you can see what's happened there now. The int type has got a value of 2, but both float and the double have got the value of 2.5. So because the integer is a whole number, in effect, what's happened is it hasn't handled the remainder of the division, 5 divided by 2, and we're left with the number of times that 2 goes into 5, which is 2. But in the case of the float and the double, obviously we've got a much more precise answer because it can handle the decimal point. And obviously that's the reason why you want to use a floating point number, to be more precise with things like division. Right, so moving on, let's change this to, instead of 2 to 3. I'm dividing all three of them by 3 this time, and we'll run the code again. And as you can see, for the integer value, we've now got 1 because 3 goes into 5 only once. And again, there's no remainder because we're using an integer. But note the precision for the float and the double value there. Obviously, we haven't got an exact number because we're dividing, but the result is for the float value is 1.6666666. So you can see there that the precision is 7 for float. We can get up to 7 numbers after the decimal point, but the double has got up to 16. You can see there's actually 16 digits there. 1.6666, I won't read them all, but the last digit is a 7. So basically 16 digits. So you can see there, hopefully that's really clear now, that the double is a lot more precise and has more precision than the float. All right, and just a reminder again that in terms of the number that you're typing in there, if you're typing in a decimal number, 5.25, for argument's sake, we could do something like this. We've got 5.00 divided by 3.00. We can remove the d, remembering that Java will automatically look at a floating point number and assume it's a double. We can run that, and we get exactly the same output as a result. So you don't really need to specify d when you're using a literal there, but it's, again, as I mentioned in the last video, it's a good habit to get into to do just that. Now you might be thinking that given that the fact that double takes up double the amount of space, it's a double precision number compared to the float, which is a single precision number, that perhaps you should be using the float. What's interesting, but most definitely the double precision number, the double primitive type in this case, is recommended. And there's a number of reasons for it. Firstly, believe it or not, it's actually faster to process on many modern computers. And that's because computers have, at the chip level, their functionality for many computers to actually deal with these double numbers faster than the equivalent float. Secondly, the Java libraries that we'll get into later in the course, that the particular math functions are often returned or written to process doubles and not floats, and to return the result as a double. And you can see the reason that the makers of Java did that. Obviously, it's more precise and it can handle a larger range of numbers, so you can see why they would have done that. So consequently, you'll find that double is used a lot in the code that's out there in the wild and in the various libraries. And for you to take advantage of these libraries, you should be using the double. And the other thing I mentioned anyway is that Java treats double as the default floating point number if you don't specify the D or the F. So for all those reasons, it's highly recommended that you use the double. And for that reason, I'm not going to be using the float anymore in this course. Any floating point number code that we use, we'll be using the double moving forward. All right, so to end this video, it's time for a quick little challenge. So the challenge here is to convert a given number of pounds to kilograms. So here are the steps that you'll need to take. Firstly, you'll need to create a variable with the appropriate type to store the number of pounds that we want to convert into kilograms. Then you want to calculate the result of that, so i.e. the number of kilograms based on the contents of the variable above. And you want to store that result into a second variable with the appropriate type. And third, we want to print out the result of your calculation. And just to help you as a hint there, 1 pound is equal to 0.45359237 of a kilogram. So you should be able to take that and figure out how you would calculate and perform that operation and go through the 3 steps and see what you can come up with. So pause the video, type your code in, give it a test run and see if you can get the result. When you're done, come back and resume the video and I'll go over my solution with you. So pause the video now. Right, so welcome back. Hopefully you managed to solve that. So let's go through and come up with a solution. We're going to be using a double here for floating point numbers, and hopefully you've taken in my reasoning for using the double. So I'm going to start by typing double, number of pounds, equals, and I'm just going to type 200D. That's just an arbitrary number. You could have used any number for a calculation. And next, we're going to create another variable we'll call double converted kilograms. We'll set that equal to, our formula will be the number of pounds we want converted. All we need to do is multiply it by that number I gave you, which was 0.45359237D. And I'm putting a D there. We don't have to because we're dealing with a double data type anyway. It would be assumed, but we'll do that for consistency. Semicolon to end the line. And we'll print out the results. We'll put converted kilograms equals plus our converted kilograms. All right, so let's actually run this and make sure that it works. And you can see we've got a result there, 90.718474. Now, just to be sure that's going to work, let's just open a browser. We'll go into Google and we'll say 200 pounds to kilograms. You can see that's a common question. We've got the result there, 90.7185. Looking at our code, 70.71847, so obviously that would be 7185. Google has just rounded up. So clearly our calculation has worked well. Okay, that's good. So hopefully you managed to solve that challenge. Right, the other quick thing I wanted to show you was we're aware now that we can type in a double, for example, double pi equals 3.1415927D, semicolon. But you can also express a number like this using the underscores. Double another number is equal to, we could 3 underscore 000 underscore 000 period 4 underscore 567 underscore 890D. So you can format it in that way if you want. I personally don't like that. I don't like using underscores, but I'm just showing you that because you may see that out in the wild when you're coding and wonder what it is. And just to confirm though, even though we type it in that format, if we actually print both of these variables out, this is purely a thing just for us humans to read, because when we output it, you can see the results are still stored exactly the same way. 3.1415927, and I printed out the wrong number. I was wondering why that number was coming up. That's the one I was trying to print out there. Another number, we'll try it again. And there's the number. You can see it's still 3,000,0456789, and the 0 at the end was ignored because it's not needed. Right, so I just want to finish off by talking about another important point about floating point numbers. So keep in mind that in general, float and decimal are great primitive types for general floating point operations, but both are not great to use where precise calculations are required. Now this is due to a limitation with how floating point numbers in general are stored and not a Java specific problem as such. But Java has a solution for this the class called Big Decimal that overcomes this problem with calculation of precise numbers. Now we will talk about that more later in the course. You really need to get an understanding of classes and so forth before we move into that. For now, just keep in the back of your mind that when precise calculations are necessary, such as when performing, say, currency calculations, then floating point types like we've used here should generally not be used. But for general calculations like you've seen here, converting kilograms and things of that nature, float and double are probably just fine. And again, double would be the recommendation. That would be the floating point type you generally use. So we'll discuss this in a lot more detail in a future video as we go through the course. Alright, so that's it now for the floating point data types. In the next video, we'll look at two more primitive types in Java, namely the char and the Boolean primitive types. So I'll see you in that next video. In the previous videos, we've dealt with whole numbers and also with single and double precision numbers. So most recently, of course, we were dealing with the floating point numbers. In this video, we're going to talk about two additional primitive types in Java, the char, but also the Boolean primitive types. Now, as you can see, I've already created a new project on screen and I've called it char and Boolean. And I also used the create template option so that we've got a class and a main method to use. So go ahead and do that now if you're following along. So I'm going to start by deleting this comment. And I'm going to tab over or press enter there, and you can see we've been indented by IntelliJ. And let's define our first char variable. So I'm going to type char, C-H-A-R, space, my char is equal to, then single quotes, and then a letter. I'm going to put the letter D there. That could be any character, letter or number, and other characters like an exclamation mark, a hash, an @ sign, and so on, and a semicolon to complete the line. Now, the char is different to a string. Now, if you recall in the previous videos, you've seen we've used literal strings, and that's where we've typed some text in double quotes. We haven't really used a string variable yet, but we'll be doing that in upcoming videos. So char is similar to the string in one sense, in that it can store characters, but in this case, it can only store a single character. So if we go back and try and add a second character here, like another D, you may not get an immediate error until you press enter, but you can see there now, too many characters in character literal. So it is literally only allowing us to actually save one character. So I'll just delete that to make it valid. So you might be wondering now, like how useful is that? Why would you want to use a variable that only allows you to store one character? Well, one example might be to store the last key pressed by a user in a game. And there could be other scenarios where you just wanted to keep the last key press or just the last single digit that's been used in a menu option or something along those lines. Now, chars were much more relevant when Java was released in the late 1990s compared to today, with much faster computers that have got lots more memory. So these days you don't need to focus so much on saving memory, because another good use for chars would be to store data in arrays. But again, we haven't talked about arrays yet in the course, so we'll talk more about that a bit later. For now though, keep in mind that if you're going to be using a char, you can literally only store a single character in a single char variable. Now you might be looking at that thinking that it can only save one character, so therefore it must only occupy a single byte in memory because it's again one letter or digit, one character if you will, that can be stored in it. Well, it turns out in terms of storage that's not the case. So a char primitive type in Java occupies 2 bytes of memory or 16 bits and thus has a width of 16, and I know we've been talking about width in other videos. The reason that it's not just a single byte is that it allows you to store Unicode characters. So Unicode is an international encoding standard for use with different languages and scripts, by which each letter, digit or symbol is assigned a unique numeric value that applies across different platforms and programs. Now in the English alphabet, we've got the letters A through Z, meaning only 26 characters are needed in total to represent the entire English alphabet, but other languages need more characters and often a lot more. Now Unicode was developed to allow us to represent these languages in a common way on computers. So the way that this works and equates back to the char variable in Java is that it uses a combination of the 2 bytes that it's taking up in memory, and as a result it can represent any one of 65,535 different types of characters, so it's quite flexible with those 2 bytes. So to see that in operation, let's swing back to a browser. Alright, so I'm going to go to a website called Unicode, table.com. All right, now you can see there that we've got a lot of symbols on the screen there. And if I scroll down, lots of ads there as well, but unfortunately, you can scroll down, you can see there's lots of different symbols, and these are all Unicode characters. And you can see there's a staggering amount of them. I'll just give it time to load. Pages and pages, and as I'm scrolling down, it's actually generating more. So I'll go back up to the top again, just to the first letters there. Now notice that the letter D is on the screen there, and notice that that's on the 4th row, and it's actually starting on the 4th column. So to the left of that row containing the @ sign and ABCD, notice that it's got 0040, and in the column above the letter D, it's got the number 4. So a Unicode character is comprised of a code that we key into IntelliJ. So to do that now, in this case, we're going to type in 004, and if we were using the @ character, we would leave it at 0, because that would be 0040, but because it's the D, we replace the 0, this is the ending 0 after 0040, with the letter in the column for D. So you can see that's at the top of the screen, it's 4. So therefore the code we need is 0044. So if we go back into IntelliJ, and we can actually type that Unicode character in. So we can type char, my Unicode is equal to, now put that single quotes as we did before, but this time, because we're putting in a Unicode character, we need to put a \U in those 4 digits. In this case, it was 0044. All right, so then I go to the end of the line and press enter there. Now we're going to print out the values. So let's do that. We'll do an S out for my char. Then we'll do an S out again for my Unicode. And let's actually run this program just to make sure that it's actually working okay. Now you can see that we've got D printing out twice in our output window. So clearly the first representation on line 7 is for a letter D, and we type that in, but the Unicode character, if we were using a Unicode convention to assign to our character, is \U, which tells the Java compiler that it's a Unicode character, and then the code that you saw me come up with. So we got to the same result by doing that. So let's just find one other character to make sure that it's working. And we'll go back to our Unicode table, and we'll come down here to this one here, and you can see the row there with the copyright symbol. So let's grab the code for that one. So that's going to be 00A, and there's the 9, which is above the copyright, so it's going to be 00A9. So let's go back to our code again. We'll define another one. We'll do a char, my copyright. Char is equal to, then we now single quotes, semicolon to the end of the line. I'm going to do a \U 00A9 at the end of the line, and then we'll do an S out again. My copyright char, and let's see whether that works. And there you can see on the screen there the copyright character. So that's how to use Unicode if you're wanting to put that into a char, like as we've done here. And that's literally it for the char. We'll talk more about this later when we get to arrays, but for now, if you're needing to use a char, that's how you use one, and you now know also how to use Unicode. All right, now that's the second variable we want to talk about is the Boolean. So a Boolean value allows for 2 choices, true or false, yes or no, 1 or 0. In Java terms, we've got a Boolean primitive type, and it can be set to 2 values only, either true or false. Now, Booleans are pretty useful in Java and most programming languages, and you will use them a lot when you're programming. So let's go back to the code. So what we want to do now is create a couple of Boolean variables. Let's go ahead and do that. So I'm going to type Boolean. We'll call the first one my true Boolean value. And we'll assign that to be true. And we just type true in lowercase with a lowercase t and enter there. And we'll do the same on the next line. My false Boolean value is equal to false. So it can have 1 or 2 values, either be true or either be false. So what would be a practical example of using a Boolean in a program? Well, let's just say you wanted to know whether a particular customer was over the age of 21 or not. So you might create a Boolean like this. You type Boolean, and you would type the variable name to be a question. So you type Boolean is customer over 18. Actually, I said 21, so let's go back and do that. 21. So is customer over 21. We can assign that equal to true. So you can see there what we've done is the variable name is a question, is the customer over 21? And we've assigned the value of true to that, meaning that of course in this particular case, the customer is over 21. And again, you'll see that fairly often with Booleans, they will use the word is and then a question to make it very intuitive as to what that variable is actually tracking. And just a reminder that in general with variable names, we'll be talking about those and the right and best practices for naming variables, classes, and methods as well. But more on that when we get to that stage in the course. And in terms of the Boolean, you'll see practical applications for that primitive type once we start tackling conditional logic. All right, so that's the 8 primitive types we've now covered. And in the next video, we're going to have a bit of a recap of those 8 data types. So you know already now that they're called primitive types. So we're going to go over them again in the next video and then start discussing after that a special data type in Java that's called a string. Now you've seen a literal value of a string, and that's showing up whenever you've typed something or seen me type something in double quotes. That's a literal string. But we're going to start also working with this data type string in more detail as well. So actually creating variables of type string. So let's move on now to the next video. In the previous video, we looked at the char and also the Boolean data type, which was the 7th and 8th primitive data types that we've covered so far in the course. And in fact, they are the last 2. There's only 8 primitive data types in Java. It's now time to have a bit of a recap briefly of where we are with those data types, but then to discuss a very important data type that you'll be using a lot in this course and in fact, anytime you're programming in Java. So I've got a new project open called strings for the code we'll be working on. So if you're following along, create a new project. All right, so the 8 primitive types that we worked on previously, of course, were byte. And so I'll just tab this over. So we had the byte, we had the short, the int. I'm putting 2 backslashes there, sorry, 2 forward slashes to indicate that it's a comment. The comment is ignored by the Java compiler and basically just enables us to put some comments or information that we can actually refer to later. So they're just ignored. All right, so those are the 8 data types that we've talked about before. Each of these primitive types, as you found out, if you've looked at the previous videos, has got its own style and is used for different purposes. So the byte, as we found out, can only hold a number in the range -128 to +127. So it's entirely possible that you'll go years as a Java developer and not even need to use the byte ever. The most common primitive types you'll use will be an int, a double and a Boolean, and you'll probably from time to time need to use a long and a char, but not as often. And short and float, as well as byte that I've mentioned, well, these will be types you'll use rarely, if at all. Now, as you get more experienced in Java, you'll learn to use the right primitive type for a given computing problem, and that's actually all part of becoming a programmer. So just to reinforce, those 8 data types we've looked at are primitive types built into the Java programming language. Now, as we go through the course further, you'll find that there's a way to create your own data types, which in Java are called classes. Now, there's an entire section in this course on classes, so I'm not going to go into more detail about classes here, but what's interesting about them is that you can combine data types like perhaps one or more ints, doubles, booleans, etc., and sort of create sort of like a super data type, which again are called classes in Java. But more on that when we get to the classes section. For now though, let's talk about another data type, and that's the string. So the string is a data type in Java which is not a primitive type. It's actually a class, but it enjoys a bit of favoritism in Java to make it easier to use than a regular class. In other words, it's treated a little bit differently, and you can treat it differently than you would normally treat a class. So what is a string? Well, a string is a sequence of characters. Now, if you recall in the case of the char primitive type, which you can see above, and we discussed that in the previous video, that could contain only a single character, either a regular character or a Unicode character. A string, on the other hand, that can contain a sequence of characters. In fact, a large number of characters. It's technically only limited by the amount of memory space, heap space in your computer, or the max underscore value of an int. And if you recall, when we're looking at ints and their maximum sizes was around 2.14 billion. So that's a heck of a lot of characters that could potentially fit in a string. Right, so to define one, let's go ahead and do that. And we do that by typing string, capital S, and a variable name, my string, equals, in double quotes, the value we want to set this as a string. So you can see that it's very much like a primitive type in terms of how we use it. And let's just print this out. I'm going to put a message first to say my string is equal to closing double quote plus, and then my string, the variable. And if we run this, we can see the output is my string is equal to, and then what we assign my string to, which is this is a string. Now we can also append to that string automatically by using the plus operator. In fact, we sort of did something similar on line 15. So to do that to this my string variable, we can type my string is equal to my string plus, then double quotes, comma, and this is more, and semicolon, and then let's output it. So what we'll do is we'll just copy the entire line, the output line from line 15, I'll paste onto line 17, and we'll run that again. So what that's doing there, that's appending the text in the double quotes on line 16 to the existing contents of my string, and we can see looking at the output that my string is now equal to, this is a string, comma, and this is more with a period on the end. So what we're saying is make my string equal to whatever it currently is when the program gets to that point, and this is the code I'm talking about is on line 16. So as of the time it's looking at the code on to the right of the equal sign, my string is set to this is a string, and we're saying add by the use of the plus operator the text comma and this is more, and that's why we're seeing the output in the output window with the extra output. Right, another thing you can do is you can use Unicode characters. So we could continue this example by typing my string equal my string plus. This time we'll put a double quotes and we'll put the \U 00A9, which is the code for the copyright symbol. Let's put the year 2019. And let's copy line 17 to check the output out. So let's see what happens when we've done that. And you can see the output to the right hand side has now got copyright 2019. So you can do that as well. You can see that it's got some versatility. We can use Unicode characters, regular characters, and also unlike the char, we can actually add a significant amount of characters if we like. Right, so let's try something different now. So let's type in a new string. So I'm going to start on line 20, and I'm going to type string, number string is equal to, in double quotes I'm going to type 250.55, and closing double quotes and then semicolon. Then I'm going to type number string equals number string plus, in double quotes, 49.95, and the semicolon to end the line. I'm going to add the line to output it. But before I run this, what do you think the answer will be? Will the two numbers be added together, the 250.55 and 49.95? So in other words, if my math is correct, that should be 300. Will we see 300 outputted? Well, let's actually try running that to see what we get. And you can see that in fact here we haven't got the number 300, we've got the 250.55, then after that we've got 49.95. So the 49.95 has been appended to the end of the 250.55. Now the reason for that is that we're not using a numeric type, such as an int or a long, etc., or even a double for that matter. We're using a text data type, string in this case, and a string treats the text or digits that you type as text only, so there's no numerical calculations done and available. So we need to convert that to another type or save it in another type in order to be able to perform mathematical calculations to it. So here clearly we can see that it hasn't done any calculations for us. So again, a string is dealing with textual data only, and it doesn't treat even numeric numbers that we've keyed there as numbers. They are also treated as the textual representations. Now later in the course I'll show you how you can convert what you think is a number from a string to a number, but for now anything you type into a string is a string, and you can see it's treated differently to a numeric data type that we saw previously. Alright, so another thing I want to show you that might surprise you, we're going to type string, last string is equal to 10 in double quotes. On the next line I'm going to type an int, or create an int variable, int my int, assign that to the value of 50. Then on this line, this could be the confusing line, last string equals last string plus my int. And I'm going to output that by typing in double quotes last string is equal to plus last string. So firstly, notice that on line 25, we're actually adding a numeric data type of int to a string, and yet we haven't been flagged as any errors. So as far as IntelliJ is concerned, there isn't an error with doing that. So what do you think is going to happen when line 26 is executed? What output are we going to see? Well, let's run it and see what we get. Now you can see there that last string is equal to 1050. So even though we've used an integer data type as the second part, in other words, we've appended the integer to the string, the entire thing, last string, is still configured and set up as a string. The reason for that is Java is smart enough here to say, okay, I note that the integer you've defined, my int, on line 24 is an integer, but I also know that you're trying to add it to a string. And of course, last string was defined on line 23 as a string. So what Java does then is it actually converts, or effectively looks at the contents of my int, the value of it, and converts the value, 50 in this case, to a string, then appends that to the 10, and that's why we're seeing 1050 as the value of our last string. So it isn't a number in the true sense, it's treated purely as text by the computer here because it knows it's adding that to the last string. So my int itself is still an integer variable, but it's the addition, the appending of the value to the last string that's treated as a string. And we can continue on in that example and do something like double number equals 120.47d, and we can do last string is equal to last string plus double number. Then let's print it out. We'll just take the value here. We'll just take a copy of that line again and paste it, save a bit of time. Let's run it again. You can see here last string is now equal to 1050, but also the 120.47, which was the decimal version from our double data type, has been appended as well. So it's done exactly the same as the integer. It's treated the value as text and appended that as text to our string variable. So note what I'm doing here is only a very elementary way of dealing with strings and adding to strings. In later lessons, we're going to go through this and look at some of the more advanced features of a string because we can do all sorts of things with it. It's quite a useful thing. We can delete characters out of a string. We can append characters, which we've seen. We can insert characters at specific positions. There's lots of flexibility with strings, but we need to know a bit more about classes before we can get into too much detail. So strings in Java are immutable. So when I just said that you can delete characters out of a string, that's not strictly true because strings in Java are immutable. And what that means is that you can't change a string after it's created. Instead, what happens is that a new string gets created for us by Java. So in the case of this code, last string doesn't get appended the value 120.47. Instead, a new string is created automatically by Java, which consists of the previous value of last string plus a textual representation of the double value 120.47. So the net result is the same. Last string has the right values. However, a new string got created and the old one got discarded from memory automatically by Java. Now don't worry if that makes no sense, it will later in the course. For now I just wanted to point out that strings are immutable and that'll make more sense as you progress. And just to note that the code that I wrote there was quite inefficient. So as a result of a string being created for every operation, appending values like this is inefficient and generally not recommended. I'm going to show you a better way of doing this in a future video where we discuss something called a string buffer, which unlike the string can be changed. But you do need an understanding of classes before we tackle string buffers, so we're going to leave that until later in the course. But I've also shown you this method today because you will come across code written in this style I've used in this lecture using operators like plus to append values to it. So it's useful for you to know how to do things this way or even know that that's a way that you wouldn't generally do it. Alright, so from your point of view, you can treat the string as sort of like a ninth primitive type. However, to be completely clear, it's not a primitive type, it's a class. But the Java language has set the string to be used in an easy-to-use way compared to classes traditionally, which we haven't covered yet, and you will be using a lot of strings as we progress through the course and in general in your working life as a Java programmer. Alright, so time to discuss a few more things before we end this section. So we've got operators and operator precedents to cover in the next few videos. So let's get started on that in the next video. So it's now time to talk in more detail about operators. We've discussed very briefly what operators are and have a few of them in use or have used them, but let's go deeper into that now. So what are operators? Well, operators in Java are special symbols that perform specific operations on 1, 2 or 3 operands and then return a result. Now as an example, we've previously used the plus or addition operator to sum the value of 2 variables. But there are many other operators in Java. So what is an operand? Well, an operand is a term used to describe any object that is manipulated by an operator. So if we consider this statement int my var equals 15 plus 12, then plus here is the operator, and 15 and 12 are the operands, and variables used instead of literals are also operands. So it's another example, double my salary equals hours worked multiplied by hourly rate. So in that above line, hours worked and hourly rate are both operands, and the star, the multiplication, is the operator. What's an expression? An expression is formed by combining variables, literals, method return values, which we haven't covered yet, and operators. So they're a way of actually forming and combining those values to produce a result. So in the line below, 15 plus 12 is the expression which returns the value of 27. Now in the statement below, hours worked multiplied by hourly rate is the expression. So if hours worked was 10 and hourly rate was 20, then the expression would return 200 because 10 times 20 is 200. All right, so let's explore operators using some code, and we'll swing back to IntelliJ to do this. And I've created a project here called operators, so do that if you're following along and you haven't already created a new project. All right, so I'm going to start by typing, I'll delete that comment. And we'll start by typing int result is equal to 1 plus 2 semicolon. I'm going to add 2 slashes there and type 1 plus 2 equals 3. Now we've actually seen this in use before. We've done some arithmetic, some basic arithmetic using the plus or add operator. And in fact, we've used a number of operators already, but now I just really want to clarify and go through the major operators so that you can become familiar with them and then know how to use them. And you'll find that some operators tend to be used a lot more frequently than others. So here what I've done is I've added a comment at the end of the line with 2 forward slashes to type out what the expression should evaluate to before we print it out. More on comments in a moment. But note here that we've got 2 operators on this statement. We've got the equal operator and the plus operator. So the equal operator is an assignment operator. So it's used to assign a value. So in this case, it's assigning what's on the right-hand side of the equal operator to the variable we've called result. And the value will be 3 in this case, which is the sum of 1 plus 2. The plus or addition operator sums the operand to the left and operand to the right. So the expression is using 2 operands here. Now we can also use a single operand by commenting out the 1 plus 2 and replacing it with a 3. So we could obviously come back here and change that to a 3. But the expression is now just a single literal number, which in this case is 3. So we've got a single operator, the equals to operator, and a literal value, and that's it. All right, so comments are ignored by the computer and they're added to a program to help describe something. Now comments are there for humans. We use 2 forward slashes in front of any code or on a blank line. Now anything after the 2 slashes, the 2 forward slashes, right through to the end of the line you add it to is ignored by the computer. So aside from describing something about a program, comments can be used to temporarily disable code, and that's another useful thing when you're testing, which we'll look at and we'll do a little bit later on in the course. All right, so let's go back and code some more. So I'm going to undo that change back to the original expression of 1 plus 2. So let's actually print this out to make sure it does work. And we'll type in 1 plus 2 equals, and then we'll print out the value result, which contains the expression 1 plus 2. We'll run this. No surprises, 1 plus 2 equals 3. Right, so let's introduce another variable, int previous result. We're going to assign that equal to the value of result. And we'll print it out. We'll put previous result is equal to plus previous result. Let's just run that to make sure it's working. Previous result equals 3. Let's now go ahead and change the value of result. So on the next line I'm going to type result equals result minus 1, semicolon, and I'm going to press tab and I'm going to put a comment there. And the expression is going to be, and we'll look at the left operand, the value is 3 at the moment for result, so it's going to be 3. Then the operator is minus. The right operand is 1, so 3 minus 1, obviously the answer is 2. Let's confirm that. We'll print it out. 3 minus 1 equals plus result. We'll run that. 3 minus 1 is 2. So notice how previous result and result are independent of each other. So even though we assigned result to previous result doesn't get updated when result gets a new value. So to confirm that, I'm just going to take a copy of line 10. I'm going to paste that on line 13. If we run this again, we can see that even though that result was changed to a value of 2 on line 11, and we confirmed that once we printed out result on line 12, in the case of previous result, it's still set to 3, and that's because the assignment for previous result was done on line 9, and we didn't update previous result. All right, so let's try something else. So let's try another operator. So we'll come down here and we'll do another one. We're going to type result equals result multiplied by 10 using the asterisk or multiplication operator. And what should be happening there is we know the value of result is 2, so it's going to be 2 multiplied, and the right operand is 10, so 2 times 10 equals 20. And if we print this out, it should be 2 times 10 equals plus result. Let's run that. 2 times 10 equals 20. And we won't bother using previous result moving forward because I've already determined that. All right, so next let's try division. So result equals result. Division is a forward slash. So here it's going to be, we know the result currently is set to 20, so 20 divided by 5 should equal 4. And we'll print out the value. It's going to be 20 divided by 5 equals, and print out the value of result. $20 divided by 5, unsurprisingly, is 4. Alright, so moving on, let's now look at the remainder or modulus operator. And what that does, it retains the remainder of 2 operands. So to see that working, we're going to type the code. On line 21, I'm going to type result. Similar to what we've done before, so result equals result, but this time I'm going to use the modulus or remainder operator, which is the % 3. And in terms of what we're doing here, this should be giving us the remainder of, and I'll put it in parentheses so it's clear, and we know result has the left operand, the current value of result is 4, so the modulus operator and the right side, the right operand rather, is 3. So how many times does 3 go into 4? 1, with 1 left over. So the answer there should therefore be 1. Let's print that out. So it's basically 4 modulus or remainder operator 3 should equal 1. Let's run it and confirm that that's the case. Alright, we can see 4 remainder 3 gives us 1, because of course 3 goes into 4 with 1 times with 1 remainder. Alright, so let's end the video here. In the next video we'll continue on with operators, and we'll start looking at some shortcuts you can use when using operators. See you in the next video. Alright, so moving on with our discussion on operators, there is a way to abbreviate when we're actually using many operators. So let's have a look at one. Now, we've used the example before, and I'm just going to introduce a comment here. We've done this before. We've done result plus 1. So we saw what happened when we did that statement. But we can abbreviate that statement by typing result plus plus. So 2 plus operators and a semicolon to end the line. Let's add a comment there. We know that the value from the last operation gave us the result of 1. So this is going to be 1 plus 1. No surprises, that's going to give us the value 2. Let's just confirm it. So we'll put 1 plus 1 equals plus result. So that's an abbreviation for doing the result equals result plus 1 using result plus plus. 1 plus 1 equals 2. All right, so far so good. And we can do the same for the other major operators as well. So let's do the same for the subtraction. So we do result minus minus. And that's going to give us, and the last operation was 2, so 2 minus 1 equals 1. Let's print that out. 2 minus 1 equals plus result. And again, just a shorthand way of writing result equals result, take 1. 2 minus 1 equals 1. Now we can actually even reduce assigning a value by a different value. If we want to add 2, for example, to result, we would normally have to do something like this. Result equals result plus 2. We can abbreviate that by typing result plus equals 2, semicolon. And what that should give us, We know that the result is currently 1, so that's going to be 1 plus 2 equals 3. Let's print it out. 1 plus 2 equals plus result should give us 3. Let's run that. So again, that's just an abbreviation to result equals result plus 2. There's 1 plus 2 equals 3. And we can do the same for multiplication. Let's do a couple of them just to show you that that will still work. So we can type equivalent to result equals result multiplied by 10. We can do result star equals or asterisk equals 10. And we know that should give us, we know the last answer was 3. So that should give us 3 multiplied by 10 equals 30. Let's print that out. 3 times 10 equals, and it should be 30. And there it is, 3 times 10 equals 30. All right, and I'll do one more. We'll do the division. And obviously subtraction will work the same way as well. So result equals result divided by 3 can be abbreviated to result divided by equals, so / equals 3. And that should give us, well, we know we've got 30 on the left hand side, divided by 3 should give us 10. So print that out, 30 divided by 3 equals, the answer should be 10. All right, let's do one. We'll actually finish off and do the other one just to be consistent before we end the video. Result equals result minus 2 for argument's sake. Let's do that. Result minus equals 2. We know the value for that is the last value of result was 10. So 10 minus 2 should give us the answer 8. So I'll print that out. 10 minus 2 equals plus result, which should give us the value of 8. 10 minus 2 is 8. And you can see that it's done that. All right, so let's finish the video here. In the next one, we're going to continue exploring yet more operators. But to do that, we need to first talk about the if-then statement. So we'll work on that in the next video. All right, so we're going to continue exploring some more operators. But to do that, I need to talk firstly about the if-then statement. So the if-then statement is the most basic of all the control flow statements available in Java, and it tells your program to execute a certain section of code only if a particular test, which is an expression, evaluates to true. Now this is known as conditional logic. So conditional logic uses specific statements in Java to allow us to check a condition and to execute certain code based on whether that condition, the expression, is true. So let's see how this works in practice. Right, so I'm going to start by continuing on down here on line 47. I'm going to type boolean is alien equals false. Then the next time I'm going to type if, then parentheses is alien equals equals, note the 2 equals signs there. Press enter then after the right parentheses, noting that IntelliJ indents the code, and we'll print out a message, it is not an alien. And put an exclamation mark there as well. So notice a few things here. Firstly, the if statement does not have a semicolon on the line where you'd normally expect it to. We're normally on each line so far in the course we've been putting a semicolon. The semicolon doesn't get added until the following line, which in this case is a system.out.println. So you don't put a semicolon after the parentheses. So what's happening here is the statement's actually spanning 2 lines, which is perfectly valid to do in Java, and we'll talk more about whitespace, which is the concept of using multiple lines and any number of spaces later in the course. But check out the operators that we've used in these 3 lines of code. So you can see that the one line is a single equals, and that's on line 47, and on the second line it's using 2 equals put together. So the first one, the equals, on line 47, well, that's an assignment operator, and we've seen that quite a few times. It assigns the value of an expression to the variable on the left of the equals operator. So is alien is that variable. In this case, it's been set to false, which is the value of our expression on the right-hand side of the equal sign. But the second line's a bit more interesting. It's got 2 equal signs, so it does something completely different. What it's doing, it's testing to see whether the particular value is false. So in this line here, we're saying if the contents of the variable is alien is false. So the 2 equals operator, it asks if the operands are identical or equal to each other. So here the operands, as you can see, the left-hand operand is alien, the right-hand one is false. So are they the same? In other words, does is alien equal or have the value false? So in this case, yes it does, because we know that is alien was defined as false on line 47. So therefore the expression is alien is false is true. Now that can be a bit confusing to grasp, but again we're checking if two operands equal each other, and if that is the case, a true is returned, the expression returns the value true, otherwise it returns false to say that they aren't equal. So the if keyword, getting back to our if-then statement, well that takes what's in parentheses, and if, and only if the result of that expression is true, will the next line be executed. So a better way of reading this is, do the contents of what's in the parentheses evaluate to true? So let's try it. So if we run this, we should see this will come back and say it's not an alien on the screen. So let's run it. You can see it is not an alien. And if we scroll down to see our code again, I'm going to just hover over there. Note also that IntelliJ is telling us there's a way to abbreviate is alien equals false by using the exclamation is alien. But we'll talk more about that later in the course. For now, what we're doing is still valid as well. But IntelliJ is always there trying to give you ways to do things in a more efficient manner. All right, so the other thing I want to show you though is what happens if I add a semicolon on the if line after the right parentheses. Notice when I do that, everything's still valid. We have got a little potential warning over here, but there's no errors. And if we run this, all right, so you can see what's happened there. We've still got the same output. So at first glance, you would assume that nothing's changed and the program's still working as it should. However, if I change this, so if we, instead of testing for is alien equals false, let's change this to test for true. We know that's obviously not going to be true. That's going to be false because we know is alien is set to false and we're comparing true. So that should give us a false. So what that should mean is that this line won't be executed. If I run this, we still get the output. So that's the confusing part about putting a semicolon where there shouldn't be one after the if or to the right of the parentheses. By putting the semicolon there, you're closing off that line of code and completing it, and that means that this line 49 then is basically a line that's going to be executed no matter what. So it's in other words, it's no longer using any conditional logic, it's just going to be executed no matter what. So that's just the syntax of Java to allow you to get away with that, but basically we've created an if-then statement which doesn't do anything there, and that's what's confusing about adding the semicolon. And that's the reason why you don't want to put a semicolon there. So we'll put that back, and again we'll still get the same output, but we know that now we're not seeing anything with it set to true, which is correct now because it's now correctly evaluating this and only outputting line 49 in the case of is alien being set to true, and we know that's not the case because of line 47. So I put this back to false again, run it again, and now we're getting the output because of course is alien is set to false. Now I wanted to show you this particular method of having an if-then statement, as you can see there, without using a code block. But you can see that you can run into difficulties with that because it's not always immediately clear looking at the code as to what's going on. And this is one of the disadvantages of using an if without using a code block. And what I will show you here is if I actually add a second line here, let's just say we wanted to display two lines in the case of an is alien being set to false, we're going to do system.out.println, as we normally do. I'm going to put, and I am scared of aliens. Let's just assume we wanted to do that. At first glance, we'll think that it'll work. We'll run it. We're still getting the two lines, but let's change this back to true again. Run the code. Confusingly, we only get and I am scared of aliens showing and not the other line. Now we know that the first line, it is not an alien, shouldn't be printed because we're comparing is alien, which has been set to false on line 47, with the literal Boolean value true on line 48, so that shouldn't work. But why has this extra line worked? Why have we got the output for that? Well, the reason is we haven't used a code block in our if-then statement. If we don't use a code block, then only one line of code can be added for this if-then statement. So what we can do, and what you should do 100% of the time, is actually add a code block. So instead of using the if statement, as you can see here, we should be using instead a code block. So a code block allows more than one statement to be executed, a block of code. That's why it's called a code block. So the format here is to add the left and right parentheses, as you can see in the example, and we can put the statements that we want executed if that expression is true in between the left and right curly braces. So let's swing back to the code and introduce a code block before we end the video. So I'm going to come back here and do that. I'm going to add a left curly brace there, and on the end of the line I'm going to add a right curly brace to close it off. And you can see that IntelliJ is showing you that in blue now to indicate that that's a block. So now that I've done that, firstly we'll try running it with isAlien set to true. We should technically get no output at all. That's now correct. We're not getting any output because isAlien is set to true. And if I change this back to false, we should now see both lines of output. And there it is, we can see both lines of output. So using code blocks makes the code easy to understand, but also enables us to have more than one statement execute if, in this case, isAlien was set to false and we're checking it for false. And you can see we've got the two lines of output. So in general, I would always suggest using an if, when you're using an if-then statement, to always use a code block, even if you are only executing one line, because if you come back to this code in the future and decide to add another line, you may not realize you've introduced a bug, as you saw what happened to me when I didn't use a code block. So bottom line, always use a code block. All right, so let's move on now. In the next video, we're going to switch to another primitive type to continue our exploration of the if-then statement. So I'll see you in the next video. All right, so let's switch now to another primitive type to continue our exploration of the if-then statement. So I'm going to continue on outside of the code block we introduced in the last video. And I'm going to type int top score is equal to 100. Then on the next line, I'm going to type if parentheses top score is equal to 100. We can see we're using the two equal signs there because it's not an assignment. We're checking to see whether they're the same, they equal the same. Then we're going to add our code block as I talked about. And I'm going to print our message, you got the high score. So you can see that that equal to operator, which is the correct name for the operator on line 54, that's comparing top score to the literal value 100. So it should show our output that we've defined in our code block on line 55 because we've defined top score as 100. So if we run this, we should see the output. All right, so we can see you've got the high score, so that's working correctly. But we can also do something like this. We can use the not equal to operator, which is one that we haven't looked at yet, and that's the exclamation mark and the equal. So I'm going to come back there and change that to exclamation mark, which is not, and the equal. So we're asking the question with our operator, is top score not equal to 100? So that's the expression. So in that case, clearly, if we previously had top score equal 100 work, top score not equal to 100 shouldn't work. So let's run that. And this time we shouldn't see you've got the high score. And no, that wasn't displayed. So that would be correct. And the reason is top score does equal 100. So therefore the expression top score not equal to 100 was false. And therefore the line on 55 wasn't executed. Now we can also use another operator, the greater than operator. So let's replace that with greater than. So that's now checking to see, or it's asking the question, does top score, or is top score greater than the value 100? Now we know the answer is no to that, but let's run it anyway to confirm. Then we haven't got the you've got the high score message, which is correct because we've used the greater than operator. And obviously top score is equal to 100. So is top score greater than 100 is false because of course top score is 100. But we can define that further. Instead of using greater than, we can use greater than or equal to. And we can do that with the greater than and the equal sign together. Now we're testing whether top score is greater than or equal to 100. So it's one operator to cover both those scenarios. And if we run that, this time we should see the output. And we're seeing the output because of course top score is equal to 100 and the greater than equal operator checks to see whether the value is 100 or greater in this case, or whatever is on the right hand side or the right operand. We can contrast that and do a similar thing. We've also got a less than operator. We'll just run through these pretty quickly. Less than operator won't come out because top score isn't less than 100. It is equal to 100, but we can use less than equal. Similar thing to greater than equal. This time we're testing to see whether top score is 100 or less. We run that, and we should see the output. And again, we're seeing that because top score is equal to 100. Now just to confirm that this is working, So if this top score less than 100, we come back and change that again. Let's make the top score value to be 80. Just want to show you that it does actually work. So now we're testing to see whether the top score is less than 100. Now that we've defined it as 80 on line 53, of course that should be true, the expression on line 54. So when we run this time we have got you got the high score message because top score is less than 100 because we define it to be 80 on line 53. Right, so let's introduce another variable, and I want to show you a slightly more complex example. So I'm going to type int second top score is equal to 60. Now you can get a bit more complex. We can type something like if, then our parentheses, and we can put top score, if that's greater than second top score, 2 ampersand characters, and which stands for and, top score less than 100. Then I'm going to add a code block there. I'm going to print out a message greater than second top score and less than 100. So looking at this code, this is actually performing 2 tests now. So it's saying if the top score is greater than the second top score, and we're also saying, but also we want to check whether the top score is less than 100. So the 2 ampersands put together like that is what's called a logical AND operator. So it makes sure, it ensures that both operands are true, or tests to see whether both operands to the left of the double ampersand and to the right, both of those have to be set to true, or have a value of true. And there's also a single ampersand you can use, which is called a bitwise AND, which works in a similar way, but you shouldn't really use that here. You need to use the both ampersands. We'll talk about bitwise operators later, which are something that you use far less regularly than you would use the logical AND operator that we're using here. So in this case, we should find the message will be printed. And the reason is top score, firstly, is greater than second top score, and second top score is 60, but we've assigned the test the 2 ampersands if the top score is less than 100, and of course top score is set to 80. So if we run that, greater than second top score and less than 100 is correctly output. So just to confirm that this is working, let's make the second top score, we'll make that value 81, which now changes the scenario because now suddenly second top score is greater than top score. So let's run that. And you can see we haven't got the message showing. It only needs one side, the left operand or right operand, to be false, and then the entire condition, or in this case the code in the code block, won't be executed. Alright, so that's a more advanced if-then statement. Let's finish the video here, and then in the next one we'll continue our exploration of operators still further, and we'll also be looking at something called operator precedence. So see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
In the previous video we talked about operators. Let's continue that discussion further, and we'll also get into operator precedence. So where we finished off was talking about and using the AND operator on line 59, and how it required both the left condition, the left operand condition, and the right condition, the right operand, they both had to be true in order for the code that we've defined, in this case in a code block, with the statement line 60 to be executed. So without the left and the right hand side conditions being true, that code isn't executed. We can confirm that again by running our code. And we can see the output greater than second top score and less than 100 isn't showing, and that's because we defined second top score to have the value of 81, and that means that the left condition, top score greater than second top score, is false, and consequently we're not seeing the output. Alright, so a useful thing to do with these expressions or conditions is to use extra parentheses to clarify your meaning. Now this can also have an effect on your code due to operator precedence, but we're seeing that in a future video, what I mean by that and what effect it has. For now though, we're talking about enhancing meaning. So what we can do is come up here to the left condition and put parentheses around that. And we'll do the same for the right operand or the right condition, like so. So this makes the code easier to read because it's now clearer what the condition or expression is for the left and right hand operands of the AND operator. Now at this stage We've run the code again. Nothing's changed. We've got exactly the same results, but it just in general is making it a bit easy to read and understand. And the idea is to help remove confusion and to clarify your meaning. And as a result of that, it makes it quicker to understand when you look at the code at a glance to know what's going on. And this may be relevant in the future if someone else is reviewing your code or you're looking at your code in the future where you've forgotten the reasoning for putting that code as it was in the first place. So adding these parentheses just can make it a little bit easier to understand. All right, so that's the AND operator. Let's now move on and talk about the OR operator. So the OR operator works in a similar way to the AND operator, but the difference is that it only requires one of the conditions to the left and right hand side to be true. Remembering that the AND operator requires both the left and right operands conditions to be true. The OR operator requires only one of the left and right operand conditions to be true. So let's start some code here. So I'm going to come down here. So I'm going to type if. I'm going to add two parentheses because we're going to do a similar thing by wrapping our conditions in parentheses. So I'm going to type if top score greater than 90, and I've put one right parentheses there, then I'm going to put the OR operator, which is these two pipe characters. Now just a note here that you need to use two pipe characters, not one. If you use only a single pipe per character like so, well that's actually a bitwise OR operator and it will return different results. So here we want to use a logical OR which needs two. And if you recall, you can see on line 59 when we're using the AND operator that we also used two ampersands there. Well, so just some clarification on the logical AND and logical OR. So the AND operator comes in two flavors in Java, as does the OR operator. So the two ampersands, that's the logical AND operator, and that operates on Boolean operands, in other words, checking if a given condition is true or false. Now you will almost always want to do this. The single ampersand is a bitwise operator working at the bit level. This is the AND bitwise operator, and that's an advanced concept that we won't get into here. And likewise, the two pipes is the logical OR, which again operates on Boolean operands, again checking if a given condition is true or false. And again, you'll almost always be wanting to do this. The single OR, the single pipe, that's a bitwise OR operator working at the bit level, and again, not something you generally would be needing to do. All right, so let's swing back to the code. All right, so back to the code, then I can change this, and I can add another parentheses, and we'll put second top score less than equal to 90, and we've got our two closing parentheses now, and now we're going to add a code block, and then in the code we're going to put the println message either or both of the conditions are true. Right, so looking at the code, we scroll up and look at line 53, we've defined top score to be 80, so looking down at our code on line 63, if top score greater than 90, that's going to return false because obviously top score is 80, not 90, because of the test that we're testing there, top score greater than 90. Now the second score, you can see that on line 58, we define that to have the value 81, and the test, if it's less than or equal to 90, which is the right-hand operand condition, well that's going to return true, which means we've got one false operand, the left operand's condition is false, but the right operand's condition is true, so therefore we should still get the output because one of them is true. And you can see either or both of the conditions are true. And just to confirm that, if we change second top score, let's change that to 95 to see what happens. Some arbitrary number that's greater than 90. Run it again. This time we're not seeing either or both of the conditions are true output, and that's because now both these values, both the left and right hand conditions for the OR operator are false, and we're not seeing the output. Alright, so let's finish the video here. In the next video, I've got a mini challenge for you. I want to talk about the differences between the assignment and equal to operators and how to ensure you don't get into difficulty with those. So I'll see you in the next video. Alright, so let's continue. Now I've got a little bit of a challenge for you here, and it relates to a common bug that people who are starting out programming may encounter. So we'll start by typing the code int new value equals 50, and the next line I'm going to type if left parentheses new value equals 50 right parentheses, and we'll add a code block like we normally do, and we'll print out a message, this is an error. Right, so my question to you is, what is wrong with this code? So note that IntelliJ is flagging that line 68, with an error. So if we hover over that, we can see it says incompatible types required Boolean found int. So aren't we testing new value, which we know is an int, against the whole number 50, which we know from our primitive types discussion is treated as an int by default? So why are we getting this error? So have a think about why it's doing that. Pause the video if you like and see if you can figure it out. Alright, so welcome back. Well, the problem is the equal sign. Let's talk about the difference between the assignment and the equals to operators. So as you can see in the code we typed, we've declared the new value int using the assignment operator, which is one equal sign, and we assigned the value 50 to it. What we need to do in the code to check whether it's equal to is to not use the assignment operator, which is a single equal sign, but rather we need to use the equals to operator, which has two equal sign. So this is what the code should look like, noting that it's got if in parentheses new value equals 50, and not as we've typed it, new value equals 50. So we're not assigning a value here, we want to test if the values are equal to each other. Right, so back in the code, what we need to do to fix this is we need to come down here and put the second equal sign in, which is now an equals to operator, and we're now correctly comparing the value of new value to the value 50. The error's disappeared, and if we run this code, we're getting the output, which now doesn't make sense because we fixed the error, so we should probably change the output, and we'll put this is true, which would probably make more sense if we were reading the text. Alright, so this is true. Alright, so that's a common problem you'll come across using a single equal sign, which is the assignment operator, instead of two equal signs, which of course is the equals to operator. But let's continue on with that. I want to show you another problem. This time we're going to use a Boolean. We're going to type Boolean is car is equal to false. Now on the next line I'm going to type a similar thing, if, then in parentheses, is car equals true, noting that I'm using the assignment operator and not the equals to operator. And then I'm going to just print out a message in our code block which simply says this is not supposed to happen. So what do you think is going to happen in this scenario? Noting that there's no error here. So pause the video if you like and come back and we'll go through it. Alright, so firstly let's run the code now. And look what's happened there. We've got the output. This is not supposed to happen. We can clearly see that on line 72, we've defined the value of isCar to be false, and it appears at first glance that we're comparing isCar to the value true, and for some reason, the code on line 74 is being executed. And what's more, unlike the int example we used above, when we use the assignment operator instead of the equals to operator, we haven't got an error here. So why isn't IntelliJ flagging this as an error? So in the case of where we had the new value equals 20, in other words, we used the assignment instead of the equals to value, and I'll change that back again. This is why we're getting incompatible types here. So if we hover over that again, so on line 68, new value equals 50, well, that actually returns the value 50, and that's why the error is showing found an int, when in fact what it requires is a Boolean. And that's because the assignment operator returns the value that has been assigned to the variable, and the equals to operator that returns a true or false on whether the two values are the same. Now in the case of the code on line 73, isCar equals true, even though that's an equals operator, that is returning true because the isCar variable is a Boolean and it's been assigned to the value true. So that's why we're not getting an error on line 73 when we in fact did get an error on line 68. So I'll just undo that change again to go back to where we were before. So the bottom line is to make sure that you're using the equals to operator where you're testing to see whether things are equal, and you're not using an assignment operator like we're using here. So I'm going to go back and fix this. We're now using the equals to operator. We run the code now. We no longer get the message, and that's because we're using the proper equals to operator. Now just a note about Booleans as well, we can simplify the expression we've got on line 73 by removing the equals true altogether and simply having it like so, if is car. Now that's a shortcut and tests to see whether car is set to true, which we were doing previously with the equals to operator. Now we can also do a test for not here. So if we wanted to specifically check that car wasn't equal to true, we could obviously put if is car not equal to true. In this case, it would be testing for false. We could also put if is car is equal to false to specifically check whether it's false. But we can also come up here and put not. So the exclamation mark is the not operator. And what that does is basically tests to make sure that is car is not equal to true. Alright, so the exclamation mark, or what's the not operator, it's also known as the logical complement operator. Now it's for use with Booleans and it tests the alternate value. So we saw is car in parentheses tests for true. By adding the not operator before the value, we're checking the opposite, false in this case. So Boolean is car equals false. We can do a test there. You saw me do this in the code before. If parentheses is car is equal false, because we're using the equals to operator, that's just testing for false. But we can also put if and in parentheses not is car to check also if the Boolean value is car is false. Now I generally recommend using the abbreviated form of both for two reasons. The abbreviated form here I'm just talking about if parentheses is car or if parentheses not is car, depending whether you're wanting to test for true or false. So the reason I recommend using those is to avoid the potential for error by accidentally using an assignment operator, as we did earlier in the code, but secondly, the code's more concise. Alright, so let's end the video here. In the next video, I want to talk about something called the ternary operator. See you in the next video. Alright, so it's now time to talk about something called the ternary operator. So what I'm going to do is come back here and undo the latest change that I had for is car, so that we are testing to see whether it's true. But now what I want to do is below that code, I'm going to type Boolean was car equals, I'm going to type is car space question mark space true colon false. So this is a case where we've got three operands. Now incidentally, the ternary operator refers to the fact that the operator takes three operands. So the first operand is the condition we're testing, which should evaluate as all conditions to true or false. So the second operand is the value to assign to was car if the first condition was true. And the third operand is the what to assign to was car if the first operand condition was false. Now the first condition could be a lot more complex than what we currently have, but if we add some code now and type if parentheses was car and a code block, and we'll put some output in the code block was car is true. If we run this, we can see we've got the output this is true, but we haven't got the output for was car equals true. And that's what's happened there is we're testing here, was car, basically we're saying is car equal to true? If it is, we want to set our was car variable to true, otherwise set it to false. So because on line 72 we've defined is car as false, therefore was car was assigned as false and we didn't see the output. If we come back and instead below that, I'm going to type is car equals true. And now if we run the code again, this time we've got no difference of the code, and that's because I put that in the wrong place. Obviously that should have been before the Boolean, because at that point in the code it tests the value, and obviously by assigning is car after the fact we didn't see any result. But now if we do this, we should see the was car output, and there it is, was car equals true. Alright, so the ternary operator. So confirming the ternary operator is a shortcut to assigning one of two values to a variable depending on a given condition. So think about it as a shortcut of the if then else statement, and of course we haven't discussed else at this point in the course, but we will be discussing that later. So consider this example, int age of client equals 20, Boolean is 18 or over equals age of client equals 20, question mark true, colon false. So operand 1, age of client is equal to 20. We're using the equals to operator. So that's the condition we're checking for. And that condition, remember, needs to return true or false. Operand 2, true here is the value to assign to the variable is 18 or over if the condition in operand 1 is true. And operand 3, which is assigned to false, that's the value that's going to be assigned to the variable is 18 or over if the condition in operand 1 was false. Now in this particular case, is 18 or over is assigned the value true, and that's because the age of the client has the value 20, and our condition for operand 1, age of client is equal to 20, returns true. Now it can be a good idea to use parentheses like this example below to make the code more readable, particularly in a ternary operator. So Boolean is 18 or over equals, and we just put in the condition for operand 1 equal to 20 in parentheses to make it clear. Alright, so let's end the video here. I want to talk a little bit more about operators and a bit of a summary, and then we're going to get into a challenge and talk a bit about operator precedence, and all of that's coming up in the next video. Alright, so let's have a look at a useful page on Oracle's website to give you a summary of the operators as we've discussed in this section of the course. So I'm going to go to a web browser, and I'm just going to do a search for Summary of Operators, Java. So the link is in the resources section of this video. And the one we want down here is this second one, Summary of Operators, and it's the docs.oracle.com link we want. So I'm going to click on that. And this will give us a handy list of the operators that are available in Java. And you can see we've pretty well talked about all of those operators now. One that we haven't talked about at this stage, scroll down and have a look, is the type comparison, the instance of. And there's a reason for that, and that's because that really needs you to understand the concept of classes. So we'll be talking more about instance of when we get to the stage of working on classes in the course. And the other ones are the bitwise and bit shift operators. These are ones that you'll very rarely use in Java. The important ones are the conditional operators, conditional and conditional or, which we've talked about at length in this course. So it's a handy list. I suggest you access that if you want to find out more information, but you can see that we've pretty well come through and dealt with most of these as we've gone through the course. Alright, next I want to go back and I'm going to open a new tab here, and I'm going to do a search for Java operator precedence table. And this first link here, this cs.billkent.edu.tr, we click on that. That gives us a handy list of the precedence table in Java. So what that means is it shows you how Java decides the priority of evaluating things in an expression. So note, for example, that the highest precedence, 15, has parentheses, and therefore that's a way to ensure that your condition overrides standard precedence rules for things like you see in, say, precedence 12, which is multiplication, division, and modulus, and precedence 11, which is addition and subtraction. So a bit of a hint there to keep that in mind when you get to the stage of solving the challenge, which I'm going to talk about. So you can see that multiplication, division, and the modulus, the remainder operator, have a higher precedence than do addition and subtraction, and that means that you may not get the results you expect using those operators depending on the precedence and the order that you're doing things. Now, for now, keep in mind that you can use parentheses to override other things like multiplication and sort of to force the condition to be evaluated in the order that you think it would be. So this is one reason why it's often a good idea to put parentheses around conditions. But if you get stuck, come back and refer to this table when you're going through the challenge, and I'll actually, in my solution to the challenge, I'll be talking more about operator precedence. Alright, so let's test what you've learnt about operators with this operator challenge. Now there's 7 steps to go through this challenge, so you might want to have this video paused on this section while you're going through and refer back to this as you're completing the challenge. Step number 1 is to create a double variable with a value of 20.00. Step 2, create a second variable of type double with a value 80.00. Step 3 is to add both numbers together, then multiply by 100.00. Step 4, use the remainder operator to figure out what the remainder from the result of the operation in step 3 and 40.00 is. Now we have used the modulus or remainder operator on ints in this course, but I'm confirming here you can also do the same for a double, a variable of type double. Step 5, create a Boolean variable that assigns the value true if the remainder in step 4 is 0.00 or false if it's not 0. Step 6, output the Boolean variable just to see what the result is. And step 7, write an if-then statement that displays the message got some remainder if the Boolean in step 5 is not true. Now don't be surprised if you see output for this step or you may expect it not to show. I'll explain that in my solution. So pause the video and try it out and come back and I'll go through my solution, and I'm going to show you the potential issue you may come across with operator precedence in my solution as well. So I'm sort of giving the game away a little bit there, but see how you go. Pause the video now and I'll see you when you get back. Alright, so welcome back. Hopefully you managed to finish the challenge or get a lot of it done. So let's tab back over to our code again and start solving the challenge. Alright, so firstly I'm going to type double my first value, which is my first variable, and let's time that to 20.00, and we'll put a D on there just to be specific. And for the second variable, it was my second value, will be what I'm calling it, but of course this can be anything you like. We'll assign that to the value of 80.00. So step 3 called for us to add both numbers together and multiply them by 100. So let's do that. So I'm going to type double. I'll call this one my values total is equal to my first value plus my second value multiplied by 100.00. Alright, so step 4, we need to calculate the remainder. That's going to be double the remainder is equal to my values total. We use the remainder or modulus operator, so it's the percent sign, and was 40. So 40.00D. And actually what I'll do there on the line after the my values total definition, let's just print out the value. So we'll say my values total is equal to plus my values total. Right, so the remainder, let's also print that out. I'm not sure whether I told you to do that. I don't think I told you to do that, but it doesn't hurt to print these things out. Whether you did or not doesn't matter. So the remainder is equal to plus the remainder. Right, so moving on. Next, we need to create our Boolean variable that is true if the remainder was 0 or false otherwise. We're using the ternary operator. Now, you didn't have to use a ternary operator, but hopefully the hint there was to use it because we just talked about it in the last video. So Boolean is no remainder is equal to, then in parentheses, which were optional, the remainder is equal to 0. We're using the equals to operator, not the assignment operator. Then we put a question mark in our true answer, the value we want signed. In other words, if the expression the remainder is equal to 0 is true, and a colon, false if it's not equal to 0. And then we're going to print that out. Is no remainder equals plus is no remainder. Alright, I'll move that code up a bit so I can see it. And the last thing I'm going to do is do an if-then statement. If parentheses, so I wanted to test if the Boolean we've defined on line 89 is. So you could do that a number of ways. I'm just going to use the not operator, bearing in mind we can do it a few other ways. Any of those ways is valid, so long as it's actually successfully testing for false. So if it's not, is no remainder, so we're testing to see whether it's false. We're going to print out a message, if it's false, got some remainder. Alright, so that's our challenge, or that's my challenge solution. Alright, so looking at the code, we've got our assignment of 20 on line 83 and 80 on line 84. So line 85, we've got first value plus my second value, so it's 20 plus 80 is 100.00 multiplied by 100.00. That should give us the answer 10,000, right? So therefore the remainder, 10,000 divided by 40, which we're testing on line 87, should give us no remainder because 40 goes into 10,000 exactly 250 times. So technically, if we run this code, we should see my values total set to 10,000. We should see the remainder set to 0. We should see is no remainder set to true. And then the if-then statement on line 91 shouldn't be executed because there isn't any remainder, and we're returning or assigning the value true to our variable if there isn't any remainder. All right, so let's run this and see what happens. I'll just put this roll window up a bit so we can see a bit more. So what's actually happened there? Why is my values total printing 8020 and we got 20 as a remainder, and therefore our is no remainder was set to false? So pretty well looking at the code, what we thought wouldn't happen has actually happened. So why is that doing what it's doing? Well, this is operator precedence in action, and this is the reason that I've coded it this way to give you an example of it. So firstly, we go back to our operator precedence table again. Let's have a quick look at that again. So I did hint at this a bit. Note that multiplication has a higher precedence than addition. So what is actually happening, if we go back to the code, so the code on line 85, what's happening there is that my second values, which is value 80, is being multiplied by 100 first. So Java has evaluated that and looked at the multiplication operator and decided that, okay, I need to calculate that first. So it's defined my second value times 100 to be 8,000. After it's finished the multiplication, it's added 20 to that, which is the value for my first value. And 8,000 plus 20 is 8,020. So that's the reason why we didn't get the results that we thought we might get. What we wanted to do was get 20 plus 80 is 100 times 100 equals 10,000. And by doing that, we should find we get no remainder and the message won't be output down the bottom. And this is where we can use parentheses here to clarify the meaning. Parentheses around my first value plus my second value. And we know that parentheses have got a higher precedence than multiplication, so that's going to be evaluated first now. The result of that will be then multiplied by 100.00. So if we run this again, you can see now we've correctly got my values total equals 10,000. The remainder set or has the value of 0 because 40 goes into 10,000 exactly 250 times, leaving no remainder. The is no remainder variable was set to true because there isn't a remainder, and consequently we now no longer get the output got some remainder. Right, so now it's working as it should. Right, so that's the challenge completed. Hopefully you managed to complete that. And if you had or did run into difficulties because of the operator precedence, hopefully you now understand why it's important to use parentheses or to code expressions in a specific order, knowing that they're going to be evaluated with the precedence table that I've shown you. All right, so that's this video and the challenge completed. And in fact, that's the entire section now done and dusted. What we'll do is we'll have a quick summary of what we've actually achieved in the next video. And just a reminder that you can grab the slides for all the videos with a handy PDF format that you can review by checking out the lecture at the end of this course. So I'll see you in the next video. Alrighty, so this is the end of the section. Now as a summary, we went through quite a bit of this section of the course. We looked at Java keywords, we looked at code blocks, we looked at variables, primitive types, we looked at expressions, we looked at operators and operands, the ternary operator, the if-then statement, and a whole lot more. So we really covered quite a bit of ground. And this is the fundamental sort of building block section of the course. From here we'll take the basic knowledge that we've gathered in this section and move on to more complex stuff. Now if you're stuck in any video in this section of the course, don't be afraid to go back and rewatch the video again. I would suggest that anytime anything's unclear, there's no shame in going back and watching a video the second time. Look, use the analogy of watching a video. If you're like me and you watch a movie for the second time, you generally will pick up things that you missed at the first time you watched the video. The same is true with training. That if something's not quite clear, just rewatching the video again, retyping the code will make things clear. So don't rush. Again, this is not a competition to get to the end of the course as quickly as possible. The goal is for you to learn Java so that hopefully you can become a productive Java programmer and earn some good money in the meantime. So keep at it. It's now time to move on to the next section. We'll get into the next level of Java code and build on the concepts that we've been through in this section of the course. So see you in the next section. Alrighty, so you've reached the end of the newly created remastered content for this course. Now if you're not sure what I'm talking about, refer to a video in section 1 of this course Remaster in Progress, where I give you the details of what's actually happening. Long story short is that I'm remastering the entire course each and every video, I'm going through and looking at the content and looking at any questions and answers, any confusion that was made or came up as a result of that video from students, incorporating answers to those questions and just basically improving the course, adding more slides and making this a better experience. Now obviously with a 77-hour course, it's going to take me some time to complete it all. So what I'm doing is completing a section of the course at a time. And that's why you've actually now just finished the last section. This was the last section. I completely remastered that section. So I'm doing it one section at a time. So I'm now working on the next section of the course, the one immediately after the one you've just finished. Now if you want to see a work in progress, check out the end of this course. There's a section there on the work in progress. Once I've finished that section, I'll then slot it into place and you're able to then use that new content. But look, the old style content is still 100% relevant. So don't think you need to wait for this new content. The old style content is completely relevant. It's there for you and you'll be able to use it. It'll just look a little bit different. It's just that I'm making basically the new style content better based on the feedback I've got over the years. But look, tens of thousands of people have been through this content and absolutely loved it. So whatever you do, don't stop your Java progress journey now. Don't wait for new content. Keep going through the course and watch the announcements, because on a regular basis I'll post an announcement to let you know the progress and when a new section's done. And then if you want to, you can then go back at that point in time and check that section if you want, or you can just continue to move on. All right, so for now though, you can move on to the next section. I'll see you in that section.
Welcome to section 5 and congratulations on making it so far. Tim Pachalka here again, and this section is dealing with 4 really important concepts of Java. We're talking about expressions, statements, code blocks and methods. 4 really key components of Java that you really need to get a good understanding of, and that's the goal of this section, is to give you that understanding. So let's make a start.
In this video, we're going to talk more about keywords and also just elaborate a little bit on expressions, which we've already covered to a degree previously. Firstly, with the keywords, now Java has actually got 50 reserved words that are used for keywords in your applications. And you have seen some of those in operation already. For example, on the screen, you can see some of the keywords that are showing in blue. And IntelliJ will actually highlight keywords in blue to show you that they actually are a keyword. So what I'm going to do is just go to a browser and I'm going to paste in this link, and the link will be in the resources section of this video. And here's a list of Java keywords, and you can see that in the Java programming language, a keyword is one of 53 reserved words that have a predefined meaning in the language. And as we scroll down the list, you'll see some of these we've already used. Boolean is one, double was another, and also float. But don't worry, you don't need to memorize any of these, because we're going to be going through each and every one of these in the course. But the thing is that they are reserved, and let's swing back to IntelliJ, and I'm going to talk further about that. And incidentally, for this video, I've created a new project called Keywords and Expressions. So anything in blue that's showing in the IntelliJ editor is confirming to you that this is a reserved word. So for example, we can't go in here and create a variable called, say, int. So if we type int equals 5, unexpected token, and that's because as far as IntelliJ is concerned, int is a reserved word, it's actually data type. We could use int2, that would be quite valid because that's only using part of the word, but you can't use an exact word. So anytime you get into weird errors, just make sure that you're not using a reserved keyword, and you can refer back to that list. Now, some of the other keywords that you've already seen that you can't use are false. We saw false before. We've used that in a previous video. True and null. But we'll be talking about those as we progress through the course. So as I mentioned, by the time you've finished with this course, you will have gone through all 50 of those keywords and will have a good understanding of what they actually are. Okay, so let's talk now about expressions. We have talked a little bit in the past about those, and you've seen some of those in operation, but let's just expand that a little bit more, just so we've got a specific understanding of what expressions are. So I'm just going to delete this, and I'm going to make a bit more space. Expressions are essentially building blocks of all Java programs. You'll be using expressions a lot, and expressions are built with values, variables, and operators, which you've seen previously, but also with method calls, which we'll be discussing in a future set of videos later in the course. For example, if we wanted to create an expression to convert miles into kilometers, we'd need to know firstly that a mile was equal to 1.609344 kilometers. So if we wanted to figure out what 100 miles were converted to kilometers, double kilometers equals 100 times 1.609344. So that would be a valid statement. So for that line, the actual expression is this component of the entire line. So the data type does not form part of an expression, but everything else on the line typically forms or is part of the expression. So the expression component is variables, values, and operators. All of those used in this case. We've got a variable kilometers, we've got values like 100 and 1.609344, and of course operators, equals, and multiplication. So that's an expression, this component of the line. By adding the data type, we're creating a valid Java statement, the combination of that and also the semicolon on the end of the line as well. Some more examples of expressions. We could have something like if high score equals 50, as we've done before. And we're getting an error because I haven't defined that variable. So I'll just define that. So this component is the expression within the brackets, as you can see there. So the keyword for if and the brackets and the braces as well do not form part of the expression. It's this component in here. And incidentally, there's another expression. The expression is quite valid as well, with a literal value as it's got there with the number 50. And finally, another valid expression is this component here. So the component within the brackets is also an expression, and that's actually calling a method. And we'll be talking about methods in a future section of the course as well. The main idea is just to get your head around what components of the entire statement or the entire line is an expression and what an expression actually is. Again, just a confirmation, we're defining a variable. The entire line minus the semicolon at the end and the data type is the expression. So that's that component there. Or if with a literal value, that's the component there minus the data type at the start and also the semicolon. If you've got you've got a control statement, control flow statement, and we'll be talking more about those also in future videos. The component in brackets is the expression. And if you're using a method, and again, methods we're going to be covering later, but anything in the brackets essentially, that is also an expression as well. So now that you know that, I'm going to clear this off. Now that it's off the screen, and my challenge for you is as follows. Have a look at the code that you can see on the screen. Write down what components of the lines that I've entered there are expressions, and come back and check your results after you've had a go at it. So how did you get on? Did you figure it out? Let's go through and talk this through. So the components that are expressions, firstly, in the first line, the score equals 100 component is the expression, remembering that a data type and also the semicolon to end the line are not part of the expression. In the second example, the if score greater than 99, well, the part in brackets is also an expression. So the if, the braces, and the brackets do not form part of an expression. In the next case, where we're printing out to the console, the component that's in between the brackets, in the double quotes, is the expression. The final example here, score equals 0, that is also a valid expression as well. So did you figure all of those out? Congratulations if you got them all. So that's expressions, and you'll be seeing expressions and keywords in use a lot more in future videos. But speaking of future videos, in the next videos, we're going to be discussing statements, which we touched on briefly here. Also, what white space is and the use of indenting. So I'll see you in that video. In the previous video, we went through what keywords and expressions were. In this video, we're going to talk about statements, white space, and indenting, what they are and why they're important within Java applications. So I've created a new project called Statements, White Space, and Indenting. So let's start off and just enter a expression. We're going to type the whole line, int, like so. So int, I'll just make a bit more space by double clicking. And if you recall from the previous video when we discussed expressions, we know that the my variable equals 50 is the expression. So what is a statement? Well, a statement is the entire line. So the entire line that reads int space my variable equals 50 semicolon, that is a statement within Java. So that actually is the complete line, if you will. So in this case, by adding the data type at the start to our expression and then finishing off with a semicolon, we've made a valid Java statement. So Java statements can be assignment expressions like the one above, where we're assigning the value 50 to the variable my variable. We could also do something like this. Another statement would be my variable plus plus, which you've seen that before in the operator videos, my variable minus minus, etc. So those types of things that are making a complete statement. But also method calls, which we haven't talked about, but will be much more in the future. That's also a statement. And you've seen this used before when we've used the system.out.println. That is a complete Java statement because it's got, in this case, a method call and it's got a semicolon on the end with the parameters passed. So semicolon is needed to complete a Java line to make it a statement in most cases, but there are exceptions to that. And as we go through this video, I'll talk more about those. The other thing to keep in mind with statements is they don't have to be on the one line. So in the case above with the system.out.println, I could have done like so, and Java is actually smart enough to know that, okay, there's nothing here finishing the line, there's no semicolon, so therefore I'm going to continue on the next line. So what it does, it collectively adds all this together and effectively creates the line just as if we had have done something like this. So as far as Java is concerned, that is exactly the same as what we typed in that case below. So with the pluses and so forth, but if we go back and put down what it was before, put back to what it was before, that is still valid as well. So you'll see that in Java code, and often it's a good idea to do that, to break up your code so it makes more sense, so it's more readable. From Java's perspective, it doesn't care if it's on one line or on many lines, provided you're not trying to end the line. So for example, if we tried to put a semicolon there, Java's going to get into difficulty because it's now saying, well, there's no bracket here, and it's expecting a bracket because we put a terminator there. We put the semicolon, which is acting as a terminator to close off the line, so to speak. Get rid of that again, and it should be good to go. So we can just run that to make sure it's working. And we get an error. Why do we get the error? Well, I haven't put the plus there, have I? So I need to put plus, which makes it valid, and now we should be able to run it. And as you can see, we've got the answer over there, so it's working fine. The other thing is you can have multiple statements on the one line. So for example, we could put int another variable equals 5, and we can then put my variable minus minus, like so. So as far as Java is concerned, that is still valid because it's found the separator, and as far as it's concerned, that's exactly the same as if you had typed it like that. Now, often I would recommend not putting statements on the same line because it can get confusing, and it just does take a little bit more effort to figure out whether that's all part and parcel on the same line. But the bottom line is you can put many things on the same line if you want to do that. We could take that even further. We could put, that was IntelliJ adding this to going to the next line. That was something that I did. So we could go back there like so, and that is still completely valid as far as Java is concerned. We can run that, and it's quite happy, as you can see. So you can saw that when I started typing system.out.println, IntelliJ tried to put it on the next line because it figured it would be better on the next line. But the bottom line is you don't have to do that. You can put them on the same line if you want to. And it's Java looking at it, knowing, okay, that's a complete statement because we've got something ending in a semicolon, and then it's looked at this and found out that yes, there's a data type, and then there's an expression. That's a valid line. And looking at the code line by line with the semicolons, it's figuring it out. So of course you're going to get into difficulty if you try and not include a semicolon, because it's going to be going, well, hang on, semicolons expected. Well, there you go, that makes it valid again. So that brings up the concept of white space. And the point about white space is, so white space is the space in between some of your expressions, your operators and so forth. In the example above, for example, I put int, there's a space between the word int and the variable name, which we've discussed before, is to make sure that Java is aware that they are separate things. But whether you had one space or whether you have 10 spaces, Java won't mind. You can even go like something like that if you really wanted to. You can see then that obviously that's probably certainly not the way that I'd recommend you code. But if we run that, Java is quite happy with that syntax, because what it's doing is it's looking at these spaces and effectively it's going to delete out the spaces internally. And as far as it's concerned, it's going to be exactly the same internally as that there. So it will figure it out. So generally speaking, it's a good idea to use spaces to clarify the meaning of particular things. Another common place to put spaces is in between variable names and operators, for example. You can see there I've got a space between the equal sign and the variable name, and likewise between the equal sign again and the literal value of 50 as well. So in general, white space, you can do whatever you like there, and Java will happily ignore the white space and work quite happily. Okay, next is the concept of indentation. So indentation is indenting your code so that it's more readable. So looking at a worst case scenario, if we went back and changed this code and removed all the extra spaces, so I think you'll agree, if you look at that scenario there, that is a lot harder to read to try and figure out where things are as opposed to this version, which is a lot more readable, and you can see that things just sort of stick out a little bit more, and it's just easy to read. So that's the concept of indenting, and generally the concept is you start typing, you normally indent the code from the method definition, and I know we haven't talked about methods yet, but we'll be talking about that. But you can see though, the code blocks, as we're typing in different code blocks, it's actually going into the next level, it's sort of indenting as we go through. So for example, if we had an if there, if my variable equals 50, you notice how IntelliJ, I've just typed the brace and pressed enter, and IntelliJ has automatically gone in 4 spaces. So it did that automatically, and that's indenting it so that when we print that out, it makes more sense. If it didn't do that, the code would look like this. And I'm sure you'd agree to be a lot harder to read. So the concept of indenting is to make it easy for you to see the logical flow. Oops, I deleted that. The logical flow of the code. So indenting is important to make sure that things are as they should be. And one of the cool things is you can't really go wrong anyway, because if you do mess up the indenting, and I'm just going to mess up a few things here just to show you, like so. If you do mess it up anyway, what you can do is you can just go up here to the code menu in IntelliJ, and you can click on reformat code. And by doing that, that's automatically reformatted it all anyway, and it's re-indented it for you. So when in doubt, go up to the code menu, select reformat code, or you can use the appropriate shortcut, which on a Mac you can see is Command Option L, but that'll be different obviously for a Windows or a Linux platform. So that's statements, white space, and indentation. In the next video, we're going to talk about code blocks, what they are, and why they're so useful when coding in Java. In the previous video, we went ahead and discussed statements, white space, and indenting. It's now time to move on to the if keyword and also discuss code blocks in more detail. So as you can see, I've created a new project. I've called it if keyword and code blocks. So what I want to do first is just go through the if keyword a little bit more so you're familiar with various ways that you can actually use it. So what we're going to do is create some code and then go through it. So I'm going to start with some code. I'm going to delete that comment and put boolean game over equals true, int score equals 5,000, int level completed equals 5, int bonus equals 100. So we can use the if keyword to create a statement something along the lines of if
score equals, double equals, because we're doing a test, equals 5,000. We can use the brace to create a code block, and we can put something like print your score was 5,000. Okay, so we can just run that. So as you can see, the if statement was pretty basic, and it printed out your score was 5,000. Just making more space here. So that's the first use of the if that you've seen, but we can actually also do this. We can get rid of these braces, in other words, get rid of the code block, if we've only got one line, one statement that we want to get executed after the test. So in this case, if score equals 5,000, if that's true, it's going to run that and execute that like you just saw me run. If that's not true, it's just going to ignore that and go on to the next line. So again, we can run it just to confirm that it's going to work. And we still get the same response. We still get the score was 5,000. What we can't do without the code block, without adding the braces, is we can't put another line here, because what happens as you'll see, if we run that again, this was executed as well, but if we change this if so that it's 4,000, and of course we've set the score to 5,000, so we shouldn't see your score was 5,000 on the screen now because the comparison will fail. But the output this was executed was still executed. So what's happening is that this is being executed no matter what, because it's not on the line after the if test. And that's because only one line without a code block, without adding these braces, we can literally only process one line at a time. If I add the braces, so in other words, if I create a code block and put that code in there, then that will quite happily work. We run that. Then we get no output because, of course, the score isn't 4,000, it's 5,000. And if we change the comparison so that it's 5,000, we get both because it's actually in the code block. So the use of code blocks are optional if you've only got one statement you want to process. What I generally recommend is, even if you've got only the one line, to probably use a code block anyway. And that's because I believe it actually makes the code clearer and easy to understand. So removing the code block, just sometimes at a glance, now if there's a space there which Java accepts, sometimes you might get a little bit confused at first glance and wonder whether this is all part and parcel of the same, if keyword statement, if you will. But the other thing you can do, I'm going to put the code block back now. Let's change this around a bit. I want to show you some of the other parts of the if, which I know we've talked about a little bit, but just to make it a little bit more clearer. So we can put something like if score is less than 5,000, your score was less than 5,000. What we can also do is put an else, and put a code block. So what will happen there, we can put something like got here, just to see what happens. And if we run that, we got here, and the reason that we got here, we didn't see any other output, is the first if test was checked. So is score less than 5,000? No, it wasn't. So this line, this code block was not executed as a result of that. So what happens then is the computer goes on to the next part here, which is an else statement. And because we've got no other condition there, it says, okay, in all other circumstances, I'm going to just print got here. And that's why it printed got here. If we then change this to put less than or equal to 5,000, we get the message your score was less than 5,000, and now the else wasn't executed, so this line didn't get executed because the first condition was fulfilled. So you can see that the if is useful from that scenario, but we can even expand it further. What we can do is we could put something like, so we'll do that test if it's less than 5,000. We can also do something like else if score is less than 1,000. Create another one, and I'll change that so it's less than 5,000. Then we use and greater than 1,000. And we can put this here, your score was less than 5,000, but greater than 1,000. Then we can put else if score is less than 1,000, we can put some output. Your score
your score was less than 1000. I need to put a variable name in there, score. So now what will happen is if the score is less than 5000, but it's greater than 1000, it's going to print that message. Else if the score is less than 1000, the score is going to show that message, your score is less than 1000, otherwise it's going to go to got here. So let's try and see what happens there. Got here was executed because of course these first two lines aren't processed, because in both cases the comparison tests there have failed. So score is 5000 and score is greater than 1000. What's in neither of those scenarios because score is currently set to 5000. We could change that to check that it's working by making that 4000. So if you run that, your score was less than 5000 but greater than 1000. So it's now executed its first component, and you can see that it's automatically jumping out of the section after it's executed something. So as soon as it's found something, it's going to ignore the else if and any other subsequent else's along the way. And just to confirm that, we can then make the score to be 800 and run that. We've now got your score was less than 1000, as you can see there. So that's only executed this section here. So this can be very useful to use the if keyword to build up statements to test a lot of scenarios and to proceed and execute certain code based on what the results of those comparisons were. So that's the if keyword. I hope that's given you a bit more clarification. So let's now just take it to the next level. What I'm going to do is highlight that code. I'm just going to comment that out. Now on a Mac, I can hold down Command and press /. You could also have gone up to the code menu and selected comment with line comment. And you can see to the right, there's the Command / is the keyboard shortcut on a Mac. So check that out on your operating system to see what the shortcut is. So what we want to do is we want to do a test here. We want to put if game over equals true, int final score equals score plus level completed times bonus. And we want to print out your final score was final score. So if you run that, we can see that the final score was 1300, and that's because the final score equals the score, which was 800, plus level completed, which is 5, times our bonus, which is 100. So therefore it's 800 plus 500, and the final score was 1300. So you can see that the code block, as we've done before, was executed because game over, of course, was set to true. But notice how we've created a variable in the code block. And the thing to remember about code blocks is, as you can see here, they're able to access variables that were created outside of the code block. So you can see that we've accessed score, as you can see score there, level completed and bonus. All these variables were created outside of the code block, but final score was created, the variable, inside the code block. But what we can't do is we can't put something like this, int saved final score equals final score. And IntelliJ comes up with an error and it says cannot resolve symbol final score. And that's because once this section of code has finished, in other words, the computer has processed it, it will automatically delete any variables that it creates in that code block. So the reverse isn't true. While you can access variables created outside of the code block, in the code block, what you can't do is access variables created in the code block outside of the code block, as you can see in this scenario there. And just as another abbreviation, you can also, where you see something like this game over equals true, that can be abbreviated to if game over. So that essentially is exactly the same as typing if game over equals true. So keep that in mind as a way to abbreviate your code. You'll see that commonly used in Java code. There's just a shortcut to just test to see whether game over has the value true. So this concept of variables inside a code block is called scope. And scope is something that requires videos in its own right. And we'll be talking more about scope in future videos. And scope really deals with accessibility of variables in certain situations or in certain places in the code, for example, a code block. The bottom line for now is in a code block, if you create a variable, you can't access that variable you've created outside of that code block. But of course you can, as you saw, still access variables that were created previously and prior to going into the code block whilst you're in the code block itself. Okay, so it's challenge time. Okay, so the challenge for you now is to create a second printout on the screen, this time with the score set to 10,000, with the level completed set to 8, and with the bonus set to 200. So you need to do something very similar to what we've done here in this first example, but you need to also make sure that this still displays, so that essentially you'll have this first one displaying. You'll then below that have a second line with the scenario here also displaying, and both of them should be displaying here in the right hand corner. Alright, so go to it, pause the video and go ahead and see if you can implement that, and when you're ready, start the video again and come back and see my solution. So how did you get on? Did you figure it out? Well, there's a couple of ways to go about this. What we could do, the first approach would be to create a complete new set of variables and to essentially do a copy and paste of that code, but use all the new variable names. So that would work. We could do something like copy, and we'll call this new game over, new score, new level completed, new bonus. And then we could do something like, and I could do something like new score equals new level completed times new bonus. And note how I can still use the int final score in this second code block, because if you remember, as soon as the code block is finished, Java will automatically delete that. So that's why we're able to recreate another variable with the same name again. Of course, we weren't able to do that with these variables because they're in the same scope, effectively in the same part of the code. And the other thing I need to do is change that game over to new game over. So we could do that. If we run that, you'll find we've got, whoops, new score was meant to be 10,000. I didn't change these, did I? The values 8 and 200. That was what we were looking for. So we run that again. Get the answer 11,600, which is 10,000 plus 8 times 200 is 1,600. 10,000 plus 1,600 equals 11,600. So that's certainly one solution to it, creating all new variables. The disadvantage with that approach is you're using excess memory, so you're creating new variables that you don't potentially need. So what you could do as an alternative, we could have just reused those variables again. So what we could have done is, I'm just going to comment that code out. I could have just copied these. This time I'll get rid of the definitions because we're not redefining them. We're just changing the values. So we can make that 10,000, level 8 and 200. And then we can literally just copy and paste this section of code again. Paste that in because it's exactly the same. We're using the same variable names. Everything else should be the same. So we should get the same output here. So we run that. So that's another way of doing it. That's just literally copying and pasting. The advantage with that approach is it was quicker. We didn't create new variables, so we used the memory more efficiently. But the disadvantages, firstly, we haven't got a permanent record of these variables. So if we wanted to keep the fact that this first score was 800 and the level completed was 5 and bonus was 100, well, we can't do that because we've now redefined the variables. Secondly, we've used game over equals true for both. And if you were tracking two players' scores, maybe game over was only the case for one of them. So in this case, you may not have actually printed this out at all because it was set to false. But the other disadvantage is we're copying and pasting code. And the disadvantage with copying and pasting code is we're duplicating code. And what that means is if we need to make a change, then what we need to do is change it in more than one place. And if you forget that your code has been duplicated, you may forget to change it in one place, which means your scores may not be calculated correctly. For example, let's just say we've decided to change the formula for defining our final score, and we're going to add a bonus of 1,000 to the final score that was calculated. So we come along here and we put plus. So just on the next line, we could put final score plus equals 1,000. So that was an overall final bonus. So if we run this, you can see the first score was correctly set to 2300, which was the 1300 plus the 1000 bonus, but down here we forgot to make the change in this particular code block, and as a result, that final score didn't have the final 1000 points added to it correctly. That's the disadvantage with duplication. You need to go back and remember all the places where the code is duplicated and to make your change. So you're really asking for errors in the long term because, let's face it, we're all human. We make mistakes, we forget things, and it is very common in programming, particularly as the code you work on gets more complicated, to forget, if you're duplicating a lot of code, where all that code is. So you definitely don't want to get into that scenario of duplicating your code. And there are lots of ways to help really reduce or eliminate the need pretty much for any duplicate code. So in the next video, I'm going to expand on from this example and show you how you can remove duplication by using the concept of methods. So methods is taking the concept of a code block to the next level, and it's going to effectively allow you to reuse that code. So type the code once and reuse it multiple times. So we'll do that in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
So let's recap what we've learned about the if-then-else statement. So the if statement identifies which statement or code block to run based on the value of an expression. In other words, based on a specific condition. Inside the code block defined by curly braces, we can have one or multiple statements. And we can use the else statement after the if. In that case, when the condition is false, the else block will be executed. We can also add else if to test multiple conditions. So in the following image, you can see the basic if-then-else statement structure. So we have a test there, in other words, the condition inside the parentheses. When the condition is true, the block inside the if statement will be executed. Now that block can be one statement or multiple statements. When the condition is false, the block inside the else statement will execute. In other words, both blocks will never execute at the same time, only one will, based on the condition being true or false. Now a block there is defined with curly braces. So be careful with the semicolon. There is no semicolon that should be added after the if statement. If you add a semicolon, it can cause unwanted behavior. It'll actually close off the if condition. So make sure you don't put a semicolon on the same line as the if. So let's just go through one more example here. So you can see the code on the screen there. And the first part of the code there, in parentheses, score greater than or equal to 5,000, we're testing that expression. In this case, because we've defined on the previous line the score being 5,000, the expression score greater than or equal to 5,000 is true. So in that scenario, what's going to happen is the code block following will be executed, and you can see the 2 there pointing out to that. In this case, the output will print your score was greater than or equal to 2,000. When it's finished, the code will then jump to the first line after the last curly brace and continue with the rest of the program. So you can see it will effectively ignore the else component, because in this case the expression score greater than or equal to 5,000 was evaluated as true. Okay, so for this slide, here the score is set to 800. So in step 1, the condition will be false. This is the expression score greater than or equal to 5,000, because of course the score here isn't greater than or equal to 5,000. So in that scenario, the next condition will be yet to be evaluated will be step 2, and that will be true since score is less than 1,000 and it's greater than or equal to 500. So remember the 2 ampersand operators, the AND operator, both conditions need to be true, and the end result here is true. So therefore the code block on the next line will be executed, and the message your score was less than 1,000 but greater than or equal to 500 will be displayed on the screen, and then it will jump down to the first line after the last curly brace and continue with the rest of the program. Alright, so in this last slide, the first test there, we're going to get a false, and that's because the score has been defined on the first line as score equal 200, and we're evaluating with the expression score greater than or equal to 5,000. So consequently, the code then goes to the second line, the else if, because it was false, and we're evaluating a test here for score being less than 1000 and score being greater than or equal to 500. And in that scenario, that expression is now false because score isn't greater than or equal to 500. So at this point, since we don't have any other conditions, the else block will be executed and the message your score was less than 500 will be printed. And obviously there's only one statement in that final else code block. Once that's finished, the code continues after that block, in other words, after the last brace. So that was a recap of the if statement. Let's move on now to the next video. In the previous video, we talked about the if keyword and then went into more detail about the code block, and we also talked about some of the issues with code blocks and duplication of code. So what we're going to do in this video is talk about methods, which is a better way of ensuring that your code isn't duplicated and also makes your code a lot easier to maintain. So I'm going to make a bit of space here. And what I'm going to do is I'm going to paste the code that we used in the previous video. And if you recall, it was this code, and then when we ran it, we got two final scores. So we got the score of 2300 and 11,600. And of course, the big issue was, if you recall, I changed the code in one place in the first code block, but not in the second code block, showing you how easy it was to have errors because you've got duplication of code that is essentially doing the same thing. And it's just not really convenient. And if nothing else, it's actually more effort for you to have to create this code multiple times. A lot easier if we can create code once, put it in an area and use it time and time again. And that's what a method gives us. So let's have an attempt at creating a method now. Firstly, you may not be aware of this, but we've been using a method all along. This entire thing here, this entire section of code, that is actually a method. And the method has the name of main, and all the code in the middle of it is the statements that form the method. So if we want to execute the method main, this is what's going to be executed, all that code that's in there. So what we're going to do is we're going to create our own method. We're going to call it calculate score. So I'm going to put it down here underneath the last brace, and you can see that brace matches up with the public static void main. This is IntelliJ's way of saying that these two things line up. So we have to start our code for a new method outside of another method. You can't put a method within another method. They need to be outside of it. And also when you're creating a method, you don't want to put it too far down. We don't want to put it outside this public class definition. And we'll be talking more about that in future videos. It has to be within that area there. So this is where we would actually type it. So we're going to call our method calculate score. So we type it. We type public static void. I'm putting spaces between all of them. Calculate score. Now don't worry about public and static. We'll be talking about those a lot in the future. For now, just keep note that you need to actually specify and use the terms public and static when you're defining a new method. And void. So for the three terms here, the public, the static, and the void, all in lowercase and all separated by a space. Don't worry what they mean at the moment. We don't need to know that. We'll come back to that shortly. But they are all keywords, as we discussed in a previous video. The ones highlighted in blue are keywords, so they're part of the Java language. So what we need to do is put our code in between the braces. And anything that's in between the braces is a statement that is part of this method that we've called calculate score. And when we execute this method, and I'll show you how to do that shortly, all the code we put in here will be executed. So to do that, I'm going to copy this first portion of the code and I'm going to paste it in. So I've pasted it into our calculate score method. And now what we can do is from within the main method, we can call this method. So how do we do that? Well, firstly, we'll delete this part out because we don't need this now because it's actually going to occur in here. So to execute this calculate score method, we just type calculate score. You can see as I started typing, IntelliJ came up and said, oh, do you mean calculate score? If that's the one we want, you just press enter and just put it in there for us. And you also may not have noticed, but this was a light grey before the actual name. But now we put that in to turn to a black. And what that's saying is IntelliJ is saying, I can see that this method is being used now. So just to confirm, if I delete that,
it goes to a light grey again and it says it's never been used. So that's a handy way to know if you've got any methods that aren't being used in your programs. Check to see whether they're light grey in IntelliJ. But I'm going to put that code back. So what we've done now is we've actually said, when we get to this portion of the code, I want you to jump ahead and then run all this code. And once you get to the end, come back where you left off and then continue on from down here. So what should happen is it'll define the variables, it'll run this through once, and then it'll come through and run the second part for us. So let's try it out. We should get the same result. And you can see that it's worked quite nicely. So how would we do the second component? Well, we would normally have to create a second method to do this second part of the code. But of course, doing that would mean that we are effectively duplicating our work again. So we haven't really fixed anything. All we've really done would have been just to convert our 2 code blocks to 2 methods. So there must be a better way of doing that. Well, there actually is with methods, because we've only started to use the very basic components of methods. So if you think about it, so what we'd really want to do, what would be ideal would be is if we could pass this information, whether it was game over, the score, the level completed, and also the bonus, to pass this to the method so it doesn't have to create the variables, so they're sent to it and then it can actually work with those variables. Well, as it turns out, we can do that. We can actually pass information to a method. So what we need to do is we need to look in this bracket area and we need to define the parameters that are part of this. I'm just going to close this so we've got a bit more space. So what we need to do is tell the method, define in the method, what parameters or what information we're sending through to it from our main method, from where we're actually calling the method. So to do that, we just type in the type of the variable and then the name we want to use it. So we can type Boolean, game over. And we separate each variable that we want to pass, the type of information, with a comma. So the second one, we're going to put a score, which of course is an int, so it's int score. You notice how I'm not putting the value there, I'm only putting the data type and the name of the variable. And you'll understand why shortly why we're not putting the value. The third one was the level completed, also an int, level completed. The last one was the bonus, we're going to call it int bonus. So what we've done is we've now said this method now has to be sent 4 parameters, and then they are a Boolean and 3 ints. So you notice by doing that, first we've got errors here now, but we've also got an error up here now. So it's actually it's expecting 4 parameters, and these are the 4 parameters we've defined here, but it's actually saying, well, the arguments that you've actually sent, you haven't sent me any at all. So there's none at all, and that's why it's actually complaining. So the parameters is what we define in this section when we're setting up a new method. They're the parameters, but arguments are the actual values, not the data type and not the variable name, but the actual values that we want to send to the method. Now, so we'll come back to that in a second. So what we want to do here is we want to actually send the data by placing the arguments to the calculate score function. So how do we do that? We can type the values that we want. So we can actually just type true, 800. And just to confirm, if we go back and have a look, we've only typed 2 parameters. IntelliJ is saying, okay, you've got 2 there. I can see game over. The actual argument is set to true and score is set to 800. So they're going to be the values that match up as we call the method, but there's still 2 we need to finish off. And they are level completed. Noticing I'm putting a comma between them both. Level completed and bonus. As soon as I enter the last one, we suddenly haven't got any errors anymore, because as far as IntelliJ is concerned, the actual arguments that we're passing match the parameters we've defined for the method. And this is really important. If you don't match those entirely, you will get an error. So in this case, because we've matched it properly, IntelliJ is happy with that error, but it's still complaining here. And the thing is, when you're creating a method and you're defining parameters of a certain type and a name, you then don't have to create them in the method at all. So we can actually delete that. Because what actually happens is if you define these parameters, Java will automatically create variables with the appropriate data type for us, which is really nice, and they'll be deleted when the process goes back to the line after the calculate score. So in this case, I deleted those variables. So there's now a variable called game over, score, level completed, and bonus that have been created automatically by Java for us because we've defined those as parameters for our method. And now we've got no errors. So what we should be able to do is actually just run this code, and we should get the same result as we had with our code blocks. And you can see we've got exactly the same answer. So far so good, and we've cleaned up some of the code, but it's still a little bit messy. And the reason it's messy is we've still got this extra line here, and we've also got these variables. Well, let's change the second one by doing this. Calculate score, true again, because that's the first parameter. You notice as I'm typing, IntelliJ is highlighting which parameter you're up to when you're typing, which is really nice. It does that automatically. So the second parameter was 10,000. Third level was 8. And the fourth one was 200. So they're the 4 parameters, and they match up to the score, the level completed, and the bonus, which was the second statement that we're actually going to execute. But notice this time I'm actually typing the values in directly. I'm not using variables or anything like that. So consequently, what I can now do is delete that. Then I can actually delete these because we don't need them anymore. And now when I run, the first value is the same, but notice the second value has been fixed. Why has it been fixed? Well, we're calling the calculate score method. It's got the fix. So of course the second value has now got a score plus 1000 because it's correctly got the fix in there. You've noticed that we've only actually programmed this code once now. So there's only one place that we can make changes to it, and we can make one change, like we could change that final score to 2000, execute it, and both scores automatically get updated. That's because they're both using the same method, which is pretty cool. Now the other thing we could do here is, instead of putting half values and half variable names, I could actually finish this off and actually put 5 there, because that was level completed 5 and the bonus was 100. And I can make this even more efficient by deleting these variables, because of course we don't need them anymore. And we've now got a far more efficient looking bit of code. We've literally only got 2 lines that actually send information through to the method. And we run it, and we get the same result, but of course we've added the final score of 2000, which is why the values are higher. So that's one of the great features of methods, is that it makes it a lot easier for you to maintain your code, because we've only got one place now where our code is modified, one method. And also you notice that we cleaned up a lot of code. There was a lot of extra code we had in our main method when we're down literally to 2 lines. Now incidentally, there's nothing stopping us actually using the variables that way, the way that we had them before. Like for example, we could paste this in, and then we could change our arguments to put game over, score, level completed, bonus, like so. And also down here we can do the second thing. We can put those new values there, delete this out, and put in that new call. So this is a good way of also creating code, because looking at this now you can say, okay, this is the calculate score method. Game over must be in some sort of indicator as to whether there's game over. That's obviously the score we're sending through, the level completed, and the bonus. So you can see how that would make more sense from reading that. You get an understanding of what this particular method does for us. So you're free to use hard-coded numbers, literal values that I just had there previously, or you can define variables if you like and use the variable name. And what happens is when the method is called, if you're using variable names as arguments, the case of game over, what happens is the calculate score method gets called, Boolean game over, it looks at the value of the game over, in this case it'll be set to true, and that's what the Boolean game over parameter gets set to, and of course that then matches with this in the method. So either way will actually work. Now that's pretty good in its own right, the fact that we can actually call a method and get it to do something and to make our code look a lot cleaner. But it does actually get even cooler than that, because what we can also do is we can get our method to do some calculations, much like it's doing now, but we can send back the result of that calculation or that processing, whatever we're doing, back to the code that it was executing that actually had called the method in the first place. So we can get the two of them to talk together. So we can calculate something and send the value back to the code that was actually calling the method in the first place. And it'd probably be easier if I show you rather than try and explain it anymore. So to do that, this makes use, returning a value it's called, makes use of this void keyword. So what void means is don't send any value back. So if you're creating a method and you don't want to return any information, you use the word void. Void means nothing, empty, don't return anything. But if we do want to return something, we need to change the word void to the type of data, the data type of the information that we want to send back. So in this case, let's actually return what the final score was, return that as a score that we can use back in this method here. So in other words, right here, when we call this calculate score method, we don't know what this calculation ends up being. We only see that it's displayed on the screen. But let's actually get that number that was calculated here returned back to us. So what we need to do is change this void first. We want to return some data that is of data type int. And immediately IntelliJ says you've got an error. And the error is that we've defined it as returning data, but we haven't actually told it to do that yet. So what we need to do is we need to add an additional line of code to tell it to return that information. So how do we do that? We come down here and we put return final score. What that actually does is it sends back the final score back to this part of the program. But the thing is, we've still got an error. So why have we got an error? Well, when you're sending some data back with a method, you've got to make sure, no matter what, that some value gets sent back. It's not okay to just, if game over is set to true, to return a value. We also have to send the value back even if game over isn't true. So in other words, all the program variations have to be accounted for, and we've got to return something every time if we specify that we are going to be returning data. So a quick challenge for you. How do you think we would change the code to return a -1 if game over was equal to false? Pause the video, see if you can figure that out, and come back and I'll show you how to do that. Okay, how did you go? There's two ways of doing that. We could actually put an else here, else, and we could just put return -1. That then removes the error. So you can see there's now no longer a problem as far as Java is concerned, because if game over set to true is going to return something, else, in other words, the else here is no matter what else happens, return a -1. So that's going to work. But we could also have done it this way. We could also have put a return -1 here. So what happens there is the same deal here. The return gets executed here. As soon as the return keyword is hit, as soon as it processes that line, it doesn't go any further. It immediately goes back to wherever the code was that actually called the method in the first place. So consequently, it will only get to this line here if this previous line hadn't been executed, and therefore Java is happy that we've covered our bases and we've returned something no matter what the program flow was.
Now, one final point, if you're wondering why we're returning -1 here, in programming terms, -1 is conventionally used to indicate an error. And in searching algorithms, -1 indicates an invalid value or a value not found. So that's the reason we're using -1 here.
Okay, this video is starting to drag on, so what I'm going to do now is pause this video and we'll continue on with methods in the next video. In the last video, we started work on defining what methods were, and we started work on creating the methods. So let's continue on with methods. Okay, so we've defined the type of information that's coming back, and we've also defined the actual value to be returned back. So next we need to do is I'm going to take out the print line there, and I'm going to put int high score equals, because the other thing you can do is you can assign a variable to a method result. So what we're doing is we're saying take the value that is returned to us from the method calculate score and put that into the variable called high score. We can then do our system output, but the final score will be actually the variable high score. And likewise for here, what we could do I'll delete that out. Same deal there, so we can run that just to confirm that it's working. We've still got the same scores, but now what's happened is, as you can see, there's no printout in this entire method. So the result of our calculations is being sent back automatically from the calculate score method, and because we put the int high score equals and then the name of the method and then the various arguments that we've sent to it, that value that we return, in this case final score, is being sent back and placed into the high score variable. Pretty cool, as you can see, because it really means that you can create methods to do calculations and just to send back the result of the calculations, making your code a lot easier to read rather than having to put all this calculation code, perhaps in an area that you didn't want it to be in. Okay, so it's time for a challenge. I'm going to make a bit more space. Okay, so here's the challenge. So that's it. You need to create a method called display high score position. So it should receive a player's name as a parameter, and a second parameter should be defined as a position in the high score table. So what you need to do in that method is display the player's name along with the message, words to the effect of, player name managed to get into position, and then display the number they received, the number they got, the position number, then a further message on the high score table. Then create a second method called calculate high score position. It should be sent one argument only, in other words, have one parameter, which is the player's score. It should return an int. Now the return data should be the number 1 if the score is greater than 1,000, number 2 if the score is greater than 500 and less than 1,000, number 3 if the score is greater than 100 and less than 500, and in all other circumstances return 4. So you need to call both methods and display the results. You can come up with any player name, but a score of 1,500, 900, 450. So in other words, you'd call the various methods 4 times to come up with this. And just to be clear, the display high score position is a void method, so it doesn't have to return any data. And incidentally, just while I remember, a void method can also be known as a procedure. And a method, generally speaking, can also be known as a function. So you might hear me using those terms interchangeably throughout the course. Procedure would generally mean a method returning type void. Okay, so see how you go with this challenge. Go away and try and see how you get on. And once you're ready, come back and I'll show you my solution. Okay, so let's have a go with the solution. So firstly, display high score position. Player's name as a parameter and a second parameter as the position in the high score table. So we'd create something like public, static, and there's no return type, so it's going to be void. So the method name is display high score position. The parameters are going to be, the first name is the player's name. We're going to use a string data type for that, and we'll just call that player name. Second parameter is a position in the high score table. Let's use an integer for that. It wouldn't really matter what you use, but probably integer would be the most efficient. And we'll call that high score position. Then what we need to do is display the message. So it would be displaying the player name firstly, plus managed to get into position, and I'm just going to do that to make it a bit more readable. Plus, we need to add and the high score position. And notice also with the variables, if they've been used, they're in dark black. If they haven't been used yet, they're in a light grey. It's a great way of figuring out whether you actually need to use, whether your variables are being used properly or not. So I'm going to type in plus the high score plus on the high score table. So that should be that one. So for the second method called calculate high score position, we need to do a public static. Now this one we needed to return some data, so the return should be returning an integer. Therefore it won't be void, but it'll be int, which is the data type. Calculate high score position. And it needs one parameter, which is an integer, the player's score. So we're going to call that int player score. And we need to have some calculations here to know what to return. So we're going to put if player score greater than 1000, code block, we're going to put return 1. Else if player score is greater than 500 and player score less than 1000, we need to just return 2. Else if player score is greater than 100 and player score is less than 500, return 3. Then in all other cases we need to return 4, so that will be just one final else without an if, return 4. So that should be that method. So we've now fulfilled I think all of that. What we need to do is we need to actually call these methods with various parameters. So what we're going to do is start off with int, we'll call it high score position equals calculate high score position. We're going to pass the first one, which was 1500. And then we want to actually execute the second method, which is display high score position. And we're going to pass the name Tim. And we're also, as the second argument, is going to be the high score position. Okay, then next, we're not going to redefine the data type, so I'm just going to copy that. And we're going to put the second one, we're going to pass, we needed to pass 900. And we'll put Bob for that one. The third one, we need to use 400. And we'll put Percy. And the fourth one, 50, Gilbert. So that should be our 4 arguments, 1500, 900, 450. So you can see what we're doing is on the first line, we're calling the calculate high score position method to return the number. And then we're executing the second method. And notice we haven't got a type because we're not setting it to a variable or anything like that because it's of type void. We're just physically calling the method like you can see there on the screen. So now if we run that, we should hopefully get 1, 2, 3, 4 showing because we've put these in the right order of 1500, 900, 450, which should be the 1, 2, 3, 4. So let's try that. Tim managed to get into position 1 on the high score table. Bob managed to get into position 2. Percy managed to get into position 3, and Gilbert managed to get into position 4 on the high score table. So it seems that our code worked. So what I want to do is just correct what was actually a flaw in the original code that I've developed for this lecture. I'll just tab over to a discussion that a student left. And you can see Julian Brown left a message to say that there's a logic hole in your challenge code. And he's actually quite correct. So, and what he goes on to say is after the first if statement, the second one does not need to test for less than 1000. By doing so, a score of 1000 would slip through and return a 4. So in other words, what I've done, and we go back to the code and have a look, well, I actually replied here and actually said, the challenge as I wrote it is in the lecture was as follows: to return 1 if the score was greater than 1000, return 2 if the score was greater than 500 and less than 1000, and return 3 if the score was greater than 100 and less than 500, and otherwise return 4. So my code actually works as per the challenge, but what is quite correct that Julian points out, and also Michael's pointed out a little bit further down as well, is that there is actually a logic hole, because if we pass a score of exactly 1000 to this routine, or a score of 500 or even a score of 100, we get the wrong results. So there's actually a bug in the code. So let's just go back to the code, and I'm just going to run it so you can actually see what the bug is, and then we'll actually fix it just so you know how to go about doing that. So these examples have all worked without any problems, and that's because they are working within the constraints of the if and the else ifs that are here. But what we haven't done is tried to actually pass a score that's exactly 1000, that's exactly 500, and that's exactly 100. So for example, let's do one that's exactly 1000. High score position equals calculate high score position 1000.
Then we display the high score position, and we'll say it's Louise, high score position. So what should happen in theory is that the way we've set it out, if the score is greater than 1,000, that should be really greater than or equal to 1,000. And likewise for this one, it should be greater than or equal to 500 and less than 1,000, it should be greater than or equal to. Because in reality, we don't really want the score of 1,000 to be number 4. We would want to say that, okay, they've scored 1,000 or more, they should really be in position 1. But if we run this code as it is now, we'll find that 1,000 will actually be returned into position 4. So Louise, even though she managed to score 1,000 points, has got to position 4. And just confirming the reason for that is, in the actual calculate high score position method, I've got if player score is greater than 1,000 to return 1. Then the next condition is if player score is greater than 500 and the player score is less than 1,000, return 2. So can you see the logic there? The first test is actually checking to see whether the score is greater than 1,000. The second test is checking to see whether it's greater than 500 and it's less than 1,000. So consequently, if the score is exactly 1,000, it actually bypasses all of these. It just goes down to the final else and returns 4. So what we should really have done there, or what I should have done, is put equal there. So if the player score is greater than or equal to 1,000, that's going to be position 1 in the high score table. So that's just that change. And likewise, if player 2, if the score is greater than or equal to 500 and it's less than 1,000, to return 2. And the last test would be if player score is greater than or equal to 100 and less than 500. So if we do that, that should actually fix all our logic problems. So if we just actually run that again, we find that Louise managed to get into position 1 on the high score table now, and that's because we're now correctly checking to see whether the score is greater than or equal to 1,000. And likewise, if I just do a couple more copies here, and the next one we'll do a test for 500. In the previous version of the test, we only were testing for greater than 500 and then less than 500 in the next one. So that would have slipped through to position 4. That should now work. So if we change that to 500, Carol. And the last test, that also had a similar problem. We're only checking to see whether the value is greater than 100. So we should really put greater than or equal 100, which we've done there. So that should now work okay. So we put Frank. So now if we run those, they should all be in their correct positions as well. So we've now got Louise managed to get into position 1 on the high score table, Carol managed to get into position 2, and Frank managed to get into position 3. And just as a recap, if I actually remove the equals on all of these to have the code as it was before I made the change, you'll find that they'll actually be in a different order. The last 3 all went into position 4 automatically, Louise, Carol and Frank, when really they shouldn't have because of the bug that I had in the code. Let's put that back again, put the equals back in and run that again. We've now got them correctly in the right positions. So thanks to Julian and Michael for pointing that out, and that's the correct code now. That's fixed that logic problem that they found, and hopefully your code's now a lot better as a result of that. So keep that in mind. That is actually a really important thing to make sure when you're testing your ranges that you include everything. Now that clearly there was a bug here that I actually didn't check to see whether the score, that all scores within that particular range were actually correctly being identified, and they weren't in this case. There was 3 scores that was slipping through the cracks. Alright, so far we've got a working solution, but I'm going to end the video here. In the next one, there's actually a bug fix that I want to fix. I want to talk to you about that and show you where the bug is, but also I want to show you an alternative way to write the calculate high score position method. And the reason I'm showing you that is just to confirm that there's almost always multiple ways to create a given solution in a programming language. So I want to show you an alternative way to create that method. So let's start working on that in the next video. Now, just before we move on to the next video, which is about method overloading, there is still another small logical problem in our conditions in the program that we've been currently working on. Now, if you carefully check the else statement, the if-else statement in the calculate high score position, just come down and have a look there, scroll that down. So down here, starting from line 65, So firstly, the first part of the condition is checking to see up here, this first one, if player score is greater than or equal to 1000. And if that's false, then obviously score isn't greater than 1000. So in other words, when the first condition is false, what that means is the score is less than 1000. So we get anywhere past that if that's true. These scores down here, we know for a fact that they aren't greater than 1000 because we've returned false there. But note in the second if, we're checking over here to see whether the score, player score, is less than 1000. But again, if we manage to get to this line, we know already that the player score is less than 1000, otherwise we wouldn't have got to that line. So the bottom line here is that we can remove that condition since it's always true. In other words, because the condition before, this one at the top, we've already established that the player score greater than or equal to 1000 was false. So if it gets to this code here, in other words. And if you've got the latest IntelliJ, if you hover over here, it will actually tell you, condition there, player score less than 1000 is always true when reached. So in other words, when we get to this line again, the condition's already true, so there's no reason to check that condition again. So what we should do is remove that. And the same goes for the second condition there. We've got the same problem there because we're checking to see whether the score is greater than or equal to 500 here. And we only get to this group of code if we know that the player score is less than 500. So that's telling us that's a redundant bit of code as well. So I'm going to remove both those parts up to and including the ampersand, the 2 ampersands for the and delete that as well. And if we actually run this app now, you can see we've still got the same results than what we got in the last video. The bottom line is that we don't have to check the extra condition again, since that condition will always be true when it reached that line of code. But keep in mind that this challenge can be written in many different ways. You don't have to match every single line with my solution, but it should work the same as per the challenge text, and you should get the same results, in other words. And you can also remove the else statement and have a return after the closing curly brace. The code will behave the same in that scenario. So let's do that just to be consistent there. So at the moment we've got this else code here. So what we could do, instead, we could actually remove that. We could just delete that code. The easiest way to do that would be just to delete the else there and delete this extra code brace and put that down there like so. So basically now we haven't got another else. So if those 3 conditions end up being false, it drops down to here, then we're just going to return 4 anyway. Just to make sure though, we'll run it to make sure we've got the same results. And you can see we've still got the same results showing. Alright, now before I end the video, I want to show you one more solution that actually eliminates multiple return statements. Multiple return statements can be confusing for people starting out in a programming language. So let's instead make our code easy to follow and use only one return statement. So what I'm going to do to achieve that is I'm going to start by commenting out the code here, all this code, up to and including the return 4, comment that out. And what we can do, instead of having these multiple return statements that were there, return 1, return 2, return 3, and return 4, we're going to assume it will return 4. So what we can do is by starting the code, I'm going to come down here and start typing. I'm going to do an int position equals 4 to start out with. And we're doing that because we're assuming position 4 will be returned. And then what we're going to do is we're going to come down to the next line, we're going to put if, parentheses, player score is greater than or equal to 1000. And we're going to type in code block position equals 1. And you can probably guess now, hopefully, what I'm going to do with the rest of the code. I'm going to put else if, parentheses, player score is greater than or equal to 500, and open a code block position equals 2, and we're going to put another else there, and the else is going to be else if, parentheses, player score is greater than or equal to 100, open a code block, put position equals 3. Then the last statement we now need to add is the return statement that actually returns the value. But instead of typing a fixed number, we're going to type return position, because we've already calculated the position to be either the values 1, 2, 3, or 4, depending on the player's score. So let's actually run this. And as you can see again, we've got the same results here, but with different code. And that's just confirming the fact that there's almost always multiple ways to solve a particular challenge and to code a particular method in Java or in any programming language. So what's actually happening here with this code that we've written is that we've got a variable that we've set based on the condition, and we're returning the value of the position variable. So therefore we've only got one return statement instead of having 4 return statements as we did in the now commented out code. So many developers find this easier to read and follow, and certainly I would say for beginners it is most likely easier because there's only one return statement to think about. So at the beginning of our method, calculate high score position, on line 76 we're setting position to 4, and that's because if none of the conditions are true in our testing with the codes on lines 78 through 84, then the 4 is going to be returned because we initially set it to 4 and the position variable wasn't changed in value. So based on the condition variable, we'll get a different value, and then that value will be returned with the code on line 86. So basically, in case the player score is greater than or equal to 1000, position set to 1. If the player score is greater than or equal to 500, it's going to be set to 2. Otherwise, if the player score is greater than or equal to 100, the position is 3. And of course, we determined on line 76 that position was 4 initially, so that will be the default. So if all 3 of these conditions end up being false, then position will stay with the value of 4, and then that will be returned. Alright, so that's like a bug fix and an alternative way to do things. And again, I just really want to make it very clear that there are multiple ways to solve problems in computing. So don't be too concerned if your code looks different to mine. The main thing is that when you run it, it performs the same, it gets the same results. That's really the key thing here. And as I've shown you that there are certainly many ways to solve a particular problem. Alright, so that's methods. I hope you got a lot out of it. I'll see you in the next video. So let's discuss what the diff merge tool is and how it can help you as a programmer. So diff merge is a program that will help you to visually compare and merge files on any operating system. It can be very helpful with programming as well. Some other tools like code repositories use similar merge operations, so this will actually help you in the future when you start working with code repositories. So what are we trying to do with the diff merge tool? Well, when you code along with the videos in this course, it's easy to make a typo and get stuck, and this is where the diff merge tool will ultimately help you. Now every lesson has the code attached to it that I typed in the video, and you can download that code in a zip file and unzip it on your computer. And I'm going to explain and show you later how to go ahead and do that. It is a pretty straightforward process. So by downloading and unzipping the code from the video and comparing it, in other words comparing my version with what you've typed, you'll be able to easily find any errors or typos or inconsistencies using the diff merge tools. It'll tell you what you've typed in correctly, in other words, which will be the problem in most cases. So in other words, it'll give you a way to figure out what's wrong with your code. Now with diff merge, you can compare a single file or even the whole folder and visually see the differences side by side. So in other words, it'll show you your code and show you my code, and you'll be able to see very easily what the differences between the two code bases are. So that's the diff merge tool. In the next video, we're going to go ahead and install the program, the diff merge program, and then after that I'm going to take you through a process and show you how to use it to get the maximum benefit from it in this course. See you in the next video. Alright, so let's see how to go ahead and install the diff merge tool. So here I'm in a browser, and I'm going to go to the website sourcegear.com/diffmerge. There's a link to this in the resources section of this video. And we need to then go to downloads, select diff merge. Now notice that there's various versions here, and I'm not going to create a separate video for each version because it's a very similar and straightforward process. What I will do is I'm going to install the Mac version with this in this video, but depending on your operating system, select the relevant version. 64-bit version of Windows, you'd select this first option. 32-bit version of Windows, that option. That's the installer, or if you want instead to download the zip file. And same for Ubuntu Linux or Fedora, you can choose the relevant version there. But I'm going to choose the DMG file for OS X. I click on download now. And if you do get this option here, just take off the checkbox there so you don't have to leave your email address. Give it a moment and it should start. I'm going to save that to my downloads folder. I'm going to open it. And obviously you do the same on your operating system to open the downloaded file and go ahead and install it. In this case, it's a pretty simple process on a Mac. You just select the diff merge and you just drag it into the applications folder. I can close that down and it's actually been installed, but the process will be slightly different depending on your operating system. But just go ahead and install that. And then in the next video, I'm going to show you how to use this diff merge tool, specifically how to compare code from a given lesson that I've created and uploaded to the course for you. So I'm going to show you how to download and compare that to code that perhaps you've typed and how to get the most out of the diff merge tool. So I'll see you in the next video. In this video, we're going to see how to use diff merge with source code from this course. So specifically, we're going to learn how to compare your code against other code using diff merge, and then as a result find common errors like typos and also go through the process of fixing those. So let's swing over to IntelliJ. Now I've opened the methods project, and this is the one we worked on fairly recently. In fact, we worked on this, we put the final changes, if you recall, the final changes to the methods challenge, and we fixed another bug, and I also showed you an alternate way to code the calculate high score position method. And so I've got that project open. So what you'll need to do is download that and have that version of the code available. And just to confirm, you're going to run this to make sure that it works. You can see that was the output that we saw previously, so that's working nicely. Now what we're going to do is introduce an error here so that we can then compare the code using the diff merge tool. So what I'm going to do is put in what is a relatively common error. So coming down here to this line here on line 82, I'm going to put a semicolon after the right parentheses. Now notice when I do that, the code is still valid, and this is something that someone new to programming may often do because an if statement doesn't have a semicolon. That's the bottom line there. So by doing that, what we've done is we've actually changed the code. And as you can see, there's no compilation errors, and we'll still be able to run this. And it's a small error. It's literally only one character, a semicolon, and it's hard to notice if you're not careful enough. So that means that the last else now is basically an empty statement. This is the one down here. So the code for that last else, position equals 3 on line 83. So that's going to always execute. So in other words, that one simple change, this method will now always return position 3. So just to confirm that, we'll run it. And you can see now clearly we've got a different result. We've got all the results coming back as position 3. So we've introduced a bug into the source code. So what we're going to do now is get another copy of that source code that hasn't got the error. And what I've done is I've attached the source code to this video, so you can use that and download this source code and open it up and make this change. But then we need a second copy of the source code so that we can use that for comparison. And obviously the second copy that we download shouldn't have the error, because what we're trying to do is compare the version of the code that works against the copy that doesn't work. Now, I've already done that. I'm not going to go through the process of unzipping it because I'm sure you're familiar enough with zips to do that now. Basically, you just want to unzip it into a folder. I'm going to show you what I've done. So what I've got now on my desktop, I've got a code that we've just made a change to in this folder, and the other one, there's a folder called original. So I've unzipped the files there, and that's the version that doesn't have any errors. And what we're going to do is we're going to compare the two projects, and I'm going to show you how you can find errors. All right, so back to IntelliJ. Now we need to start the program that we've installed previously called diff merge. So on a Mac, what I can do is I can just press Command Space and type in diff merge. So you'll start that up on your operating system with Windows or Linux, the way you'd normally start. But I'm starting up diff merge, and you can see that's now loaded up on the screen. Now with this tool, we can compare folders, and we can also compare individual files. Now some projects in this course, as we move forward, will contain multiple files, so it's easier to get into the habit of comparing folders. So what we're going to do now that we've loaded diff merge is click on this first icon here, and that's the icon to open a folder window. And this will look very, very similar irrespective of your operating system. So I'm going to click on that. Now what I've got here is I've already entered the details, but you'd normally click on Browse and you'd navigate to the folder that contains the downloaded copy of the source code from the course. So in other words, if you had a project that you were working on and you found that you weren't able to get it to work how I got it to work in the video, then you would download the version from the resources section of whichever video you want to check, and you'd unzip it and put it somewhere. In my case, I've actually put that in a folder called Original, just so that I know that that's the original code. So I've selected that with Browse. Then on the right-hand side, the right folder, that would be your code. In this case, that's the code that we've got in IntelliJ, and we're going to compare the two. So I could click on Browse and select that again, but we can see that we've actually got two different versions of the code showing now. Once I do that, I can click OK. And you can see what's happened when I've done that. We've now got two selected folders, and once we selected those folders, we can see on the left-hand side and the right-hand side, we're getting some information about the fact that things are different here. So the diff merge tool has compared the two folders, and what it will do by default, it will only show files that are different. So if you've done something identical to what I've done, then it won't come up in here at all. But in this case, the file that we're looking at, we want to look at is main.java, because that's the code that's got the file that's got the code that we want to check against. And we've also got the IntelliJ.idea folder, but I'll show you later in this video how to remove that. And we've also got these class files, which you wouldn't normally want to check, because if you tried to check those, and I can just do that by double clicking them, we actually get some weird messages because it's not actually the right file type to check. So we wouldn't normally want to check a class file. So I'm going to show you later how to remove those. But the one that we do want to check is the Java file. And again, once you get into more complex projects as you move through this course, you find that any other Java program files and other files will show up here as well. So all we want to do here is check our Java code. I'm going to double click. Now you can see once I've done that, I'm just going to open this up and make it a bit bigger. We can see now that we've got two versions of the main.java files showing on the screen here. And notice also that it's immediately moved down to the line on line 82. And it's actually saying here, or it's actually showing us the original code. And we'll know that this is the original because up here, it's got the folder location that says original. You can see that hasn't got a semicolon after the right parentheses on line 82. But this one here, notice that the semicolon is showing in red on the right-hand side. And again, clearly, that's a different folder as well. So that's telling us straight away that there's a difference between the two files. So this software has automatically figured out that there's a difference between those two lines. So again, on the left-hand side, we've got the code that was downloaded from the lesson, and on the right is the code from IntelliJ. So diff merge is showing all the differences between those two files. So notice these blue vertical lines, where a line's different. In this case, there's only the one line. So lines that have the same code, they don't have those blue vertical lines. And if I clicked on another line, notice that it's not showing me anything blue at all. But if I come back there and click on that line, it shows those blue lines again. And also it shows the semicolon that's different in red. So as you can see, diff merge can be very helpful when you make typing mistakes or if there's some logical error, as the if statement is at the moment. So let's move back to IntelliJ and change one more line. I want to show you what will happen when we do that. So I'm going to go back into IntelliJ. And what I'm going to do is we're going to go up to the display high score position method. And we're going to delete this part here, this player name. So I'm going to delete that. So it doesn't display the player name, and I'm just going to run it to confirm that we no longer see the player name. And you can see we haven't got a player name showing there. So we've made another change that's now going to be different to that other code. So let's go back to diff merge and see what's happened. So I'm selecting diff merge. Now notice what happened, that when I went back to diff merge, we got this little pop-up window, and I'll just center that and size it up so we can see it. So notice what it's saying there, files changed on disk. The following files have been changed by another application. Would you like to reload? So in other words, diff merge has noticed that there's been a change made, in this case to the file on the right-hand side, because we made that change within IntelliJ, and it's asking us, do we want to reload that file so that it can go through the process of checking again? Now sometimes it won't always get this right and automatically detect that. So if it doesn't detect it for you, you don't get this message, you can just close down diff merge and open it again, and it'll find the file the next time. But in my case, you can see it has come up. Would you like to reload? I'm going to click on yes. And notice what's happened now is we've also got an error now showing up here on line 61. And we can see that player name exists on the left-hand side, however, it doesn't exist on the right-hand side. So we've now got two lines that have differences, and they're generally known as diffs. They're called a diff, in other words. So we can easily navigate between diffs on the left-hand side. There's this white bar down here, and what we can actually do is click these red icons, and you'll have a red icon usually for each line that's different between the two files. So you can click on one of these lines, and notice that brings that up on screen. So you can select either one to go up and down to errors, and if we click on that line again, we'll see the blue bars indicating that there's a difference. And if you notice carefully, you can't really see that perhaps too good in the video, but the lines that are different have a slightly light red background, and the parts that are different have got this much heavier red background. So you can see that the diff merge tool is trying to make it obvious to you where the errors are. And again, as I showed you, if I click on the actual line, it brings those blue lines just to make it clear that that's a line that that's in needing that is different between the two files. Now you can also jump between different lines using the icons in the toolbar. And notice these three icons that are to the right hand side of the toolbar. So one icon with the arrow is pointing to the right, then the next one has the arrow pointing down, then the one after that has got the arrow pointing up. So I can choose either the up or down one to jump to the previous or to the next change. Instead of clicking on those red icons, I can come up there and choose and click down there to go to either of them. So it's an easy way for you to navigate. You don't have to scroll yourself manually. You would generally not want to do that. You'd want to specify and you'd want to click on the red icon or use this navigation to go to the specific errors that you want to change. All right, so now that we've identified the errors, how do we go about fixing them? So what we can do is we can choose to copy the changes from the left-hand window to the right-hand window. Generally, that's what you'd want to do, and that's because we've identified that the code on the left-hand side is the original code from the course, and that would generally be the code that is correct. So what we want to do here is we want to actually copy the code changes that are different from the original code back into our source code, which ultimately will go back into IntelliJ. And all we need to do there is, once we select the line, we come up over here, and there's an option there and it says Apply Change from Left. So I click on that. You can see what's happened automatically. We've got the changes now being applied over here, and we've got this black underline telling us that there's been a change that's been made in there, and it's also showing in bold as well. So we've now got player name showing as it was on the left-hand side. And the other thing there, if you look carefully at line 61 and 62, there's two stars there, or asterisks, which is telling you that there's been a change made to that line, because obviously that's a continuation line there. So you can see there at a glance that that has code that has been changed by the process we've been going through here. And we can apply the next change. In this case, what we want to do again is go from left to right. By coming up here, because we know that we're on that next line now because that happened after we fixed the first one, the change this time, you can see we've done that, and it actually removed the code that was incorrect on the right-hand side for us. And again, we've got the asterisks there indicating that the line has been modified, and we can see the code is now underlined and in bold. Once you've done that, at this point in time, the code changes haven't been saved. So what we need to do to save those changes is we need to come up here and click on the save icon, this little picture of a floppy disk. And at that point, the changes have now been made, and we should be able to go back into IntelliJ. And notice that when I went back, the player name was put back, and also down here on line 82, the semicolon's been removed. So I can actually run this code again now, and notice that we've now got the code working, the positions are now working correctly, and also the names have been returned again. So you can see that that's pretty cool. Diff merge will actually help you a lot in your code. In this case, in this course, checking to see what changes have been made, what's different between the two files. But as you become a more experienced programmer, you find you'll be able to use that in other situations. Like for example, it can give you a quick way to know what has been changed in this coding session. In other words, if you've been working on some code, perhaps for 30 minutes or 60 minutes, you can use a diff tool like this diff merge and see what has been changed from when you started coding. Very, very useful indeed. All right, so going back to diff merge again. I'm going to close down this file change now because we've established that that's okay. And notice now that, well actually if I go back through now and do a file, reload, notice what happened when I did that. Some other files have disappeared. So what's happened now is those other files have been removed from the display because they're effectively identical, because we've now confirmed that both sides, the left and right, that both versions of the files have now been updated to the same thing. But if you recall at the start of the video, we had those .class files showing, and they weren't a file type that we wanted to ever check on. So I'm going to show you how to go about changing that. Now, if you're on a Windows platform, you need to go to the Tools option menu to do this, Options. And I think that's the same for Linux. But on a Mac, I'm going to go up to the top left-hand corner, Diff Merge and Preferences. And what we want to do is come down here into Folder Filters. You can see it's under the Folder Windows menu. Now what we want to do is set this up to ignore some common file types that we won't be ever needing to compare. Now a class file is a compiled version of a Java source file, so that's not something we'd ever want to check. So what we can do is we can come out under here under Use File Name Filters, making sure the checkbox is on, which it is by default. I'm going to put a space and put star.class. So that actually tells Diff Merge not to try and ever check differences between files of type class. So star dot means all files that end in .class. But the other thing we can also do here is come down here to File Filters, and these are subfolders, and you may find that there's a number of subfolders that you don't want to ever check against, and you can add them here. And you can come back and do this at any time. So in our case, if you can see on the left-hand side there, we've got a .idea folder, and that's the IntelliJ's folder that it uses to track changes to code. So we wouldn't usually ever have a need to check whether those files are the same or different. So consequently, under folder filters, making sure the checkbox is on for use subfolder filters, I'm going to put a space and the name of the folder .idea. And if you had any other folders, you could do the similar thing to that as well. Then if you click OK to that, notice how the .idea folder disappeared. And if your Diff Merge was showing class files, you'd see that they would have been removed as well. Alright, so that's basically it. That's what I wanted to do to show you this Diff Merge tool. I think it's a really useful tool to use. So if you are getting stuck and finding that your code's not working compared to the code that I've written in a particular video, go through the steps that I've outlined in this video and to help you find where the actual error is. Diff Merge is a very useful tool, as you can hopefully see now, and it can be very helpful when you've got to compare folders, as I mentioned. And also you can actually use it to check individual files if you don't want to go through and check it at folder level. But I think it's a good habit to get into to check by folder, and that's so that when you start checking against larger projects, it's automatically set up for you to check all the Java code or any other type of file that you specify, and not just an individual file. So use it again if you're typing code from one of the videos in this course and you found that you can't get it to work or it's not working the same. Doing it that way, you can quickly spot what the differences in the code are. Then you can even get Diff Merge to make the changes for you if you want to do that as well. So it's a great comparison tool. All right, so at this point now, I'm going to finish the video. I hope you got a lot out of it, and I'll see you in the next one.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
So let's discuss a new feature of this course added in 2018, coding exercises. So coding exercises are a feature added by Udemy to allow instructors to add exercises that students can complete to help reinforce concepts that they've actually been taught. So the cool thing is that you can literally click a button and have your solution checked immediately. So in other words, I'll give you a coding exercise to complete, and you can type it in your solution to it interactively onto the screen and click a button and see if your solution is correct. So this is different to the challenges that you've seen so far in the course. Challenges were when I gave you a challenge and type some text on the screen and then allow you to go ahead and try and solve it, and then I'll show you the solution in a video. Coding exercises are different in that I give you the exercise and you do them without seeing a solution in a video, but you do have that button to click to check the answer. So there still are plenty of upcoming challenges in this course, as well as coding exercises that are meant to complement those challenges. So this is new material I've added to help reinforce the concepts being taught in the course. Now the thing about coding exercises is they can be a bit tricky to understand initially. So in this video, I'm going to go through a sample coding exercise just so that you can get a taste for it. And when you get to the next video, where you start your first coding exercise in the course, you'll be well equipped to go about it. So let's go over to Udemy's website now and open up a coding exercise and get started. All right, so as you can see in the browser, we've got the exercise text or the coding exercise text here or description showing. This is the problem that we need to solve. Now below that down here on the right part, bottom of the screen, we've got an area where we can type our source code in. So that's one way of doing it, just typing the code in there. Or alternatively, we can switch over to IntelliJ and copy and paste the code from IntelliJ into this text area. The bottom left-hand corner's got a Browse Q&A section, which we can click, and that enables you to leave any questions you may have about the coding exercise, but also check students' response to this particular coding exercise. So this will be a list of questions and answers relating to this specific coding exercise. You can see now, as this is all new, there's none at the moment. So I'm going to close it down. So as I mentioned, you can either type your results here, your solution here directly, or you can go back to IntelliJ and test your code in there, then paste it back in here. We're going to do a little bit of both as we go through this video. So you can see in terms of this solution, that's asking us to write a method called checkNumber with an int parameter number. And it talks about some more information there, but let's just start that. I'm going to come down here, I'll tab over, and I'm going to create the definition. I'm going to type public static void checkNumber parentheses, and within the parentheses I'm going to type int number, and I'm going to add a left curly brace and press enter. And when I do that, you can see the right curly brace is added automatically. I'm just going to go to the end of the line and press enter there just to give us a bit more space. And note that towards the bottom up here, checkNumber method needs to be defined as public static. So I've defined it that way as public static to make sure that this will work. There's also another note here about not adding a main method to your solution code, but more on that shortly. Now notice the file name here, positive-0.java. That's important because that's going to be the name that you'll need to make sure that you use. And as we progress through the course, you'll find that you may need more than one file to solve a particular coding exercise, but in this case, we've just got the one file. So we're going to deal with that. And notice that there is some smarts here. It's automatically highlighting Java keywords. And you saw when I added the left parentheses, it added the right one. It added the right curly brace. So it does recognize the Java language. So you can do your entire solution in here if you like, or if you prefer to do it in IntelliJ and test it, and then paste your final version in here, you can do that as well. So to do that, I'm going to go through and create an IntelliJ project. So I've selected Java, I selected a new project before I came back, and I'm going to click on Java, click on Next, and click on Next. And I'm going to call this one, sample coding exercise. Of course, you would name it whatever the name of this particular exercise, coding exercise you're trying to solve. Then what I'm going to do is I'm going to add a new class, and I'm going to call this class positive, negative, 0. And that's created positive, negative, 0.java. And if you recall, that was the file name. We need to have the same file name there. Now the other thing here is I'm going to copy this declaration to save a bit of time. I'm going to paste that back in IntelliJ. So I'm going to go ahead and do that. And we've now got a method called checkNumber. Now at the moment in IntelliJ, we haven't got a main method. Now there was a note on the coding exercise saying that we weren't to add a main method to there, but obviously if we want to test this code that we're creating in IntelliJ, we'll need a main method. So I'm going to go back up to the top here and type psvm, press tab to create our main method that we're going to use for testing. So again, we're only be using the main method here to test our checkNumber method when we're in IntelliJ. All right, so let's go back to the exercise again and see what we're meant to be doing. So it says here that the method shouldn't return any value, and we've met that criteria by specifying void here, so that's correct. It's just specifying void after static. But what we need to do is print out the word positive if the parameter number is greater than 0. So let's go back to IntelliJ and write the code for that. So this is within the checkNumber method. So to do that, we do if number is greater than 0. I'm going to open a code block and I'm going to type positive in double quotes. and obviously in curly braces. So basically we're outputting the word positive if the number that has been passed as an argument to check number is greater than 0. And by the way, notice that the results that they're looking at for there are in lowercase, so we should be printing out whatever they're asking for here. And the double quotes is just an example there. We don't include the double quotes when we're actually returning the value. All right, so back to IntelliJ. So just to test that this is working correctly, we're going to call the method check number from the main method. So let's go ahead and do that. So we're going to come down here and we're going to put check number. We're going to pass the value of 5. So we're going to meet the first condition if number is greater than 0, so we're passing 5. So let's actually run that and see whether this works. So we're going to run our application as you would normally run it. You can see we've got the value positive, and I'm just going to push this down to the bottom of the screen so we can see it a bit easier. So we can see we've got the value positive showing there. So far so good. All right, so the next part of the coding exercise, we need to print the word negative if the parameter number is less than 0. Let's go back to IntelliJ and do that. We can put else if number is less than 0. We're going to do an S out there, and in parentheses, double quotes, we're going to print out negative. All right, and to check that, we're going to put check number. Let's pass a value, say, of negative 10. So we're going to check that and run it. You can see we've got positive and negative working. So far our testing in IntelliJ is working well. So you can see we're getting positive and negative showing. So let's take the opportunity now to finish off this exercise and get it working back in the Udemy interface. I'm going to take a copy, and noticing that I'm only copying at the moment the code in between the check number method. So I'm not copying any other code. I'm going to take a copy of that. I'm going to go back to our coding exercise, making sure my cursor's in the right place. I'm going to tab over here. I'm going to paste it in to the check number method. So that's the code again that we worked on in IntelliJ. Now we know that we haven't finished the challenge yet because we haven't checked or tried to output 0. But any time that you want to check your solution, you can come over here and click on check solution. And the computer will actually check that and tell you if something's wrong. So you can see here that the method call check number with a value of 0 passed in parentheses was returned. It says returned this value and in double quotes, so in other words an empty value, but 0 was expected. So in other words, you can see that the test was automatically trying to check for a value of 0 and was expecting the word 0 to be returned, but it didn't get anything. And it didn't get anything because of course we haven't added that part of the test yet. So you can see how this solution is working for you in testing your code. The other thing to keep in mind is if we add something like we forget to put a last closing right brace, we check the solution, it is smart enough to determine that your code isn't valid Java, and we see we get a compilation error there. But I'll go back and add that again. So basic Java will actually be checked, so we know that the code is working. Give that a moment to check, and we should get the same problem of 0. So it's a matter really over here of reading what this says, because this will give you an indication of what you haven't completed of the challenge, or show you if you've actually got some errors in your code. In this case, it's telling us we now need to check for the value of 0. So I'm going to do something a little bit different though. I'm going to put else, with the arrows that go up there, put else if number is equal to 0, the two equal signs, add a left and right curly brace. Now when you're in here, we can't type S out and press tab. That doesn't work because that's an IntelliJ feature. So in here we have to type in our code in full. So that's one of the reasons why you might consider using IntelliJ to save you a bit of typing. But here, let's do something different. We're going to put the number was 0. We'll put a semicolon into the line to make it valid. So now if we check that again, check solution, you can see we've got a different result here. Method call check number 0 in parentheses returned this value, and the number was 0, but 0 was expected. So you need to get the output to be returned identically to what's being asked for in the coding exercise. So I'm going to change that. So I'm going to come up here and change this. And we'll try putting the value of 0, but with a capital Z. Check that solution again. Notice here that we've got the output of 0, but it's expecting 0, noting that it's basically telling you that the code's correct, but the capitalization is different. So you can see that it's smart enough to know that you've got the answer correct, but you've got, in this case, an uppercase 0, and you weren't asked to do an uppercase one. So I'm going to change that back to a lowercase z. So now that I've done that, our solution should be correct. Let's check the solution again. And you can see at this point in time now, we've now solved the coding exercise correctly. We've got, well done, your solution is correct, and the code that's been placed in there is correct. A couple of other last things to note. If we go ahead and we try and add another method, I'll try and add one here, public static void, we'll call it timTest, and check that solution. We get a problem here, we get an error returned, extra methods are detected. Please add only the required methods. Expected one method, but was two, so we got two methods back. So make sure that you only have methods in there that are needed, and that's one of the reasons why you don't include the main method. Now the other thing is it's important to get the definitions correct. If we remove the word static from here, so we've just got public void, and we check that solution, we've now got a compilation error here, and the error here is relating to the fact we're trying to access something from a non-static method. So the point of the exercise here is that the description is said to use static, so we need to use what they're suggesting and make sure we do exactly that to get this to work properly. I'm going to set this back to static again. I'll click on check solution and we should be correct again. Alright, so that's it. We've got our solution to the coding exercise correct. Now keep in mind with this that there's no universal solution for the coding exercise. The most important part is that it works as per the coding exercise text. In other words, it's giving the outputs that is being asked in the coding description. Now you can write every coding exercise in many different ways. So some exercises might require more testing in IntelliJ first, so it might be a good idea to test the code inside the main method, as I started doing earlier in this video, before transferring and pasting your code back here into the coding exercise itself. So in other words, testing it in IntelliJ. Alright, so that's coding exercises. Let's now move on to the next video. In this video, I want to show you how to approach and solve exercises and also show you some common errors when dealing with code exercises. And what I'll actually do is I'll go through and solve one exercise for you in this video and the next one. So what we need to do first is create a new empty project in IntelliJ, this time without a template. So with IntelliJ open, create a new project. And I'm going to select Java if it's not already selected. And I'm not going to use the project option. And we're going to call this one Speed Converter. Alright, and I'll finish that. And that'll give us basically an empty project to start with. Alright, so let's now have a look at the exercise. I'll just close this down. We'll swing over and check out the exercise. This is the Speed Converter exercise. And this is coming up in the next lesson after these two videos. So what I would suggest you do is you leave this open in another tab while watching this video so you can come back to it. So in terms of what we're trying to do here, we want to write a method called 2 miles per hour that has one parameter of type double. And that parameter should have the name kilometers per hour. Now the method needs to return the rounded value of the calculation of type long. Now if the parameter kilometers per hour is less than 0, the method 2 miles per hour needs to return -1, and that indicates that the value passed was an invalid value. Otherwise, if it is a positive, this is the parameter value passed to the method, then we need to calculate the value of miles per hour. We need to round that value and then return it. And for conversion and rounding, check the notes in the text below, which we'll talk about shortly. So that's one method that we have to write. And then below that, if we scroll down here, above the window where we put in our code, you've got some examples there of the input and output. Basically what happens when we call the method, the argument or the parameter that we're passing to that, and what the result should be. Now I'm not going to read all those examples, but you should actually read them carefully. Now as you can see, the class name is Speed Converter, and that's also the file name. So let's jump back to IntelliJ. We're going to create some files for this exercise. So we'll go back. So the first thing we need to do now is create a new class. And again, the name is going to be Speed Converter. And we do that by right-clicking on the SRC folder, New, Java class, and we're going to call this one Speed Converter. And we're also going to create another class called main, and in that class we can put our main method so that we can test our code in IntelliJ before submitting the solution back on the code exercises web browser screen. So I'm going to right click on the source folder again, new Java class again, and as I mentioned I'm going to call it main with a capital M. And you can see we've now got our two classes showing in the left hand corner. Alright, so let's start working on the speed converter class. We're going to add that first method. So I'm going to double click that to bring that back up on the screen. And if you recall, the first sentence in the exercise said, write a method called 2 miles per hour that has one parameter of type double with the name kilometers per hour and needs to return a rounded value of the calculation of type long. So to create the method signature, we're going to type public static long, and 2 miles per hour is the name of the method. And the parameter is of type double, and it's called kilometers per hour. Okay, and we'll add our left and right curly braces as normal for a method. Alright, so firstly, we need to check that invalid value. And if you recall, we said that if the parameter kilometers per hour is less than 0, then this method 2 miles per hour needs to return a -1 to indicate that that value that was passed to this method was an invalid value. Otherwise, if it is positive, we need to calculate the value of that miles per hour argument, round it and return it. Alright, so let's start by writing the code to test for invalid values. So I'm going to type if parentheses kilometers per hour, closing parentheses, and we'll add a code block there, left and right curly braces. So actually what I'll do is I'll finish that off first. We didn't finish the expression. There should be less than 0. So if it's less than 0, then what we want to do is return on the next line -1. Right, so that's handling the fact now that we've got an invalid value. Now looking back at the text, if we go back and check that out again, the text didn't specifically mention yet how to convert kilometers per hour into miles per hour. Now, you could use the Google converter to find out the conversion, but let's first move on to the next sentence. And we're going to scroll down a little bit. You can see that this second step here is to write another method called print conversion with one parameter of type double with the name kilometers per hour. Now, that method shouldn't return anything. In other words, void. It's void, and it needs to calculate the miles per hour from the kilometers per hour parameter. And you can see that it needs to print out a message in the format XX kilometers or km/h equals YY space MI/h. And XX represents the original value passed to the method, kilometers per hour. YY represents the rounded miles per hour from the kilometers per hour parameter. And we've got to test there as well. If the parameter kilometers per hour is less than 0, then we want to print the text invalid value. And scrolling down a bit further, we've got some examples of input and output for that second method. And I won't read these examples, but I certainly suggest you do that. And moving on down a little bit further after that, you can see there's text and an example of how to use the round method. This is the math.round method I'm talking about. And basically, that's math is an inbuilt class that comes with Java and enables us to perform various mathematical calculations. And in this scenario here, you can see how it rounds the number 1.5. If we go down and have a look at the usage there, that's the sample usage of it. And if we scroll down, we can see the output. So getting the input up here of 1.5, we can see we're defining that on line 1, and long rounded equals on line 2. And if we come down here and look at the output, rounded equals 2. So basically what I'm saying there is we pass 1.5, the round function will round it up to 2. 3.9 is another example there. You can see it's rounded up to 4. 4.5 is rounded up to 5, and so on. So we'll go back shortly to IntelliJ and we'll see that in operation. And just going down a little bit further to read these tips here. In the method print conversion, call the method to miles per hour instead of duplicating the code. And we'll see that working and what that means shortly. And as a note there, all the methods should be defined as public static. And you saw me define that first method like that. And that's because we've been using public static so far in the course. And a note here that 1 mile per hour is 1.609 kilometers per hour. And finally, note there, do not add a main method to the solution code. Right, so at this point, we now know how to convert kilometers per hour into miles per hour, and also how to round the result. All we have to do is divide the parameter kilometers per hour by 1.609. So let's jump back now into IntelliJ and finish the first method. All right, so I'm going to come down and add some code here on the next line. Add some code here. We're going to type long miles per hour is equal to, then I'm going to type math with a capital M. And notice you can see that's inbuilt to Java. It's a math class. If I type the period or the dot, you can see that IntelliJ has helpfully popped up or shown a pop-up with all the available methods. Now all these methods you can see are built-in methods that we can use. And we know now by looking at the notes that we want to use the round function. So I'm going to type in the first few letters of round, noting you can see that there's two versions of that, one that accepts a float and also one that accepts a double. So I'm going to select the second one, but it doesn't really matter which one you choose there. Then within the parameters, I'm going to type, within the parentheses, I'm going to type kilometers per hour, then divided by 1.609, which is the calculation to convert kilometers back to miles. I'm going to close off that line as I normally do with the right parentheses and the semicolon. Then I'm going to type return miles per hour. Right, so you can see there that we're using the round method. Math, again, is a class that contains many useful mathematical methods that you can use in your code. It's inbuilt and comes as part of Java. The round method that we're using here will round the double that we're passing to this method. And as a note, we're saying it's going to return a long. And we're obviously defined a long on line 9, and we're getting the value of the math.round function returned into the miles per hour variable. So as you can see here, to call a method from another class, we have to write the class name, in this case math, and then the dot method name, as we've done that on line 9. Now you'll learn more about classes and how you can create your own classes later in the course. But at this point, that completes our first method. Now, if you are eagle-eyed, you'd probably notice that IntelliJ is showing a warning on our variable miles per hour. You can see it's highlighted on line 9. If I hover over that, you can see there it's saying that the local variable, miles per hour, is redundant. Now that's because we're only using this local variable that we've defined on line 9 for returning the result of our calculation. Instead of using a variable, we can use the return statement right away with a calculation or an expression. Now that will also return the result, but the code is shorter and we also don't then need a local variable. So let's remove the variable and just use return on the same line as the calculation, and that will also, by definition, remove this warning. So I'm just going to delete that first part of the code and just change that so it says return, and the next line is no longer needed. I'm going to delete that, and you can see the warning has now disappeared. In this case, the code will work exactly the same as before. First, the calculation or expression is executed. So this is the part that basically is to the right of the return keyword. So that's still going to be calculated first. Once it's calculated, it will then automatically be returned whatever the value is of that calculation to the method that calls this 2 miles per hour method, and we'll see that in the next video. Alright, so that's the first method, so we'll end the video here. In the next video, we'll continue on and we'll write our second method. See you in the next video. Alright, so moving on with our speed converter code. We now have finished the first method. It's time to move on with the second. Now, if we go back and have a look at the text briefly, this is the text in the exercise. The second part talked about writing another method called print conversion with one parameter of type double, and the parameter should have the name kilometers per hour. So let's add that method to IntelliJ. So I'm going to type public static void print conversion parentheses double kilometers per hour. With our left and right curly braces to close off the method. All right, and going back quickly to read the sentence again. You can see there that it says this method shouldn't return anything. So in other words, it's of type void, and it needs to calculate miles per hour from the kilometers per hour argument or parameter that's sent to it. Then it needs to print a message in the format you can see there. I won't read that out, but you can see that XX in the output represents the original value, kilometers per hour, and that was passed to this method, and YY represents the rounded miles per hour from the kilometers per hour parameters, basically after calculating it. And there's a test there for an invalid value. If the parameter passed, the argument value kilometers per hour is less than 0, then we print out an error message invalid value. All right, so we have to print some text into the console, and the method shouldn't return anything. Our method is already void. You saw me type that, so we don't need to change anything. We'll go back and have a look at that. You can see that on line 12, I've defined that as type void. Keep in mind that returning a value when printing text in the console is not the same. I'm going to show you the difference between the two in a few moments. But first, let's finish the method. And we're going to check for an invalid value, checking to see whether it's less than 0 first. So I'm going to type on line 14 if parentheses kilometers per hour. If that's less than 0, left and right curly braces, then we're going to print out using sout. It's abbreviation in double quotes, invalid value. If I can type, like so. There we go, having some problems typing today. Alright, so we've done that. If the argument passed is less than 0, we know we've got an invalid value, so we're printing out a message to that effect. The next step then is to calculate the miles per hour, but instead of actually duplicating the code we've got on line 9, we can call that method that we wrote. Basically, we can call the 2 miles per hour method, and that would save duplication of code. So in this case, I will use a variable since we have to print the text in a specified format. And obviously we didn't use a variable in the 2 miles per hour method. So to add that code, we're going to put an else here now. So in other words, if the kilometers per hour is equal to 0 or basically greater than or equal to 0, we'll add our else, left and right curly braces, and then the code is going to be long miles per hour is equal to, and instead of typing in the method.rounding, we're going to type 2 miles per hour to call that method, and we're going to pass kilometers per hour, which was passed to this method. We're going to pass that value to that method. So what we're doing here effectively is we're putting or saving the returned value from that first method, this 2 miles per hour method on line 3. We're putting the value from that into our variable miles per hour on line 17. Now that I've done that, we can add the print line statement on the next line. Let's go ahead and do that. So I'm going to type system.out.println, and in double quotes, well actually before the double quotes, I'm going to start by specifying kilometers per hour plus, and what I'm going to do is to break this up into multiple lines so that you can read it easier. Now you could probably type this on one line on your monitor, but because I've got this zoomed up pretty high so you can see it, we're going to do it over multiple lines, and I'll just move this over anyway so we can see the code a bit more. So I'm going to do kilometers plus, and I've just pressed enter there to go to the next line. I'm going to type km /h equals, that's obviously an abbreviation for kilometers per hour, a space after the equals, double quotes, plus, then our miles per hour variable. I'm going to plus again, I'm going to go to the next line again, and I'm going to add mi for miles /h. And again, you could probably have typed that all in the one line, but I want to make it easy for you to see as I'm typing this. So at this point, effectively, that completes our exercise. You're probably wondering though, how do we test this now in IntelliJ? Well, first we need the main method. That's in the main class, but remember, the exercise text said the main method shouldn't be added to your solution code on Udemy. This is in the coding exercise. The main method, as mentioned in previous videos, is a method that will start your applications, and basically you can test it within IntelliJ. So one way is to add it to your solution code, but then if you did that all in the same file, in the speed converter file, when you paste your solution onto Udemy into our code exercise, you might get an error or forget to paste the closing curly braces and so on. So basically you're just opening up the opportunity of causing or making a mistake basically. And this is one of the reasons why we created a main class in the previous video, basically to be able to run and test our solution but not otherwise interfere with the code that we've written in the speed converter class. Now, what actually a class isn't important right now. Just imagine it as a file. So when I talk about the main class or the speed converter class, you can see that they basically equate to a file here, speedconverter.java and main.java. We are going to talk about classes later in the course. For now, just think of them as separate files, which effectively they are, so that we can get our testing up and going. So basically going back to our main.java now, and obviously that's pretty much empty now other than that first definition that has been added for us when we created the class. This is only going to contain the code to test our class and not the code to solve the solution. And you'll see what I mean as we go through. So the first thing we need to do then is on line 3, I'm going to type PSVM, which is an abbreviation in IntelliJ. Press tab there. You can see it expands it out to the public static void main line. You can alternatively, you can type that if you wanted to. and that gives us a standard entry point for Java to be able to run our code. Alright, so to call the methods from this other class, this speed converter class, the other file, we need to specify the class name and then the method name. Very similar to what we did for our math.round function in the previous video. And in case you're wondering about this static, well, that's not really important right now. We'll go into that in detail as we go through the course. It's important that you know how to use them though, and later in the course you'll learn more specifically about static methods and instance methods and their differences. So we'll get to that. For now, we're taking things one step at a time and actually execute the code that we've created. All right, so what we can do is type now on line 5, speed converter. Notice how that's been found for us. Now I type a period or a dot, whereas before with math it found the math.round function for us. Here now we've typed speed converter and a period or a dot. It's given us the available options or methods that we can use in our code. So I'm going to specify the 2 miles per hour one because this is the one we want. I'm just pressing the up and down arrow keys to select either. I can press enter there, and you can see it fills out the information for us. I'm going to put a value in there to test 10.5. All right, and close the line off. Now basically the syntax you saw was exactly the same as when we called the round method. First we type the name of the class and then the method name. Now the other thing I want to draw your attention to, you've got this highlight again. If we hover over it, IntelliJ is telling us that the result of the method is ignored. So what does that actually mean? Well, let's just run this now and see what happens. So I'm just going to right click in here. I'm going to select run main.main. Give it a moment to compile. Alright, so you can see down the bottom left hand corner of the screen, nothing's printed to the console. We've got our line here. The first line up here is basically the code that's executed when we run the program, but then it's just got process finished. So there's no output from the program. And you're probably wondering at this point, well, why not? After all, we've called the speed converter .2 miles per hour method, and we know that that does the calculation. So why isn't it being outputted on the screen? Well, the reason is we haven't told IntelliJ to print anything to the console. We've only told it to call that method to invoke the code. IntelliJ is pretty smart here and basically saying to us that, okay, you've called this method, but you're not doing anything with the return value. And it's just giving us a warning, not an error, just a warning to say, is this really what you want this to be? So basically, in our case, that's a hint, a heads up that we need to change something to get rid of that warning and to actually do something with the code. So what we're going to do first is we're going to save the value that's returned from the 2 miles per hour method into a variable. So at the start of that line, I'm going to type double miles is equal to, and notice that warning's now disappeared, and that's because we're now doing something with it. But we've now got another warning over here that variable miles is never used. So again, IntelliJ is being helpful there. But on the next line, what we'll do is we'll output it. So I'm going to type system.out.println again. And I'm going to type in double quotes miles equals plus then the variable miles that we've defined on line 5. That warning then goes away. And we're able at this point to run it again, and we should see the value. So let's run this. And you can see we've got the answer there, 7. Basically, miles equals 7.0. So that's the main difference between returning and printing. If we return the value, we can use it for some calculation. In order to print it out, we have to specifically select the option to print out, which I did on line 6. So with that in mind, let's call the other method. Remember, the method print conversion is void and doesn't return anything, but it itself prints text to the console, whereas the 2 miles per hour method was only calculating. We've actually got some output on that one. So what we can do on the next line is we can type speed converter, period, print conversion, and in parentheses, 10.5 again, semicolon, and we can run that again. And you can see there we've got 10.5 kilometers per hour equals 7 miles per hour. And obviously I haven't put spaces there. I should probably fix that up. So let's have a look at fixing that up. And we'll go back to the speed converter class. And I'll add a space at the start of kilometers per hour and a space ahead of miles per hour. The other thing I want to draw your attention to though is that I've really made a mistake here going back to this code. I called it a double, but if we go back and have a look at our 2 miles per hour again, of course what I did there was I defined it as a long. So I really should have changed that to a long, but noticing that the output down here, we've got 7.0, which is correct because it's a double, but Java was actually smart enough to convert it over, but we really want that to be a long, so that when we run it, we get what we should have got, which is miles equals 7, and 10.5 kilometers per hour equals 7 miles per hour. All right, so let's fix those things up. So what we'll do is we'll end the video here. In the next video, we'll go through quickly and we'll test that this is all working within the Udemy framework, within the Udemy coding exercise, and we should then be complete. So I'll see you in the next video. Alright, so in this video, now that we've created our solution, we want to actually start testing it in the coding exercises part of the Udemy interface. Now what I did at the end of the last video, and you recall that when we run this, this was originally of type double, and I changed it to type long. So when we run the output, we got the results. Now that was actually correct. It should be type long, but what I want to do is change that back to double, because I want to show you what happens when you do make a mistake and you don't follow the setup and the configuration of what the coding exercise is asking you. I want to show you what happens. So we're going to change that back to a double, which will still work. The code will still work within IntelliJ. And you see we got the same result other than the fact we've got a period and a 0 after the 7. And that's because it's now a floating point number instead of a whole number. Right, we'll see what I mean by that as we go through. So what we want to do now is go into our speed converter. And I'm going to close down the run window so we can see what we're doing here. Now you can just copy the entire thing. Like I'm just doing a Control A on a Windows machine and copy. Control C, or Command A, Command C on a Mac. Now be careful if you're using packages. So if you've got something on line 1 that says package, you'd want to miss that bit of code and make sure you're not using that. But if you've just got the code from public class right down to and including the last right curly brace, that should work fine. So we've taken a copy of that. We're going to swing back to Udemy. We're going to go back to the coding exercise that we looked at, and I asked you to 2 videos ago to have open. So if not, make sure you open the speed converter coding exercise on Udemy. And you can see the example there here that it starts with public class as well. So what I'm going to do is I'm going to paste that code. So I'm just going to select the entire code. I'm going to delete it and paste the code. So basically you want to just make sure the code that you've typed in is actually correct. And correctly pasted in, I should say, and ready to go. So now we want to click on the check solution box here. So I'm going to click on that. And we're now testing to see, or Udemy's code is testing to see whether the solution is correct against the solution we asked you to come up with. And notice here that we've got this error. Oops, your solution is incorrect. So what I'm going to do is just drag this over a little bit so we can read it a bit more, a bit easier. And we can see what's happening here. The error there was with spacing. So that part's okay. And if you look very carefully there, you can see we haven't really got exactly what was asked of us. And that's the output from our method, down here down the bottom, 0.0 space km/h, no space there, equals space 0 space mi/h. And it's repeated up here, and it's basically saying that's your output there, but this is what was expected in double quotes. And if you look really carefully, you can see that there's a space before the equal sign. So it's being a bit pedantic, but this is the way we've defined these coding exercises, and you really have to check the screen carefully to make sure you are giving the results exactly as it's asking for. So what we need to do is go back and put a space there before the equal sign after the km/h to make sure that it's working. So let's actually fix that. And what we'll do is, because we're now checking this within the code exercises solution, we don't really need to go back to IntelliJ. We can just come down to our print conversion. And there, as you can see, there's the equal sign there. We've got km/h. We haven't got a space there. I'm going to add a space there. And now I'm going to click on check solution again. So you can see now that our solution is actually correct. What I want to do now to finish off this video is just show you some common errors that may actually pop up. And we already showed you one there, where if you didn't type in the output exactly as it was asking for on the screen, we got an error. And if you read that code carefully, the error message rather carefully, you could see that I was missing a space there, and that actually fixed the problem. But we'll look at some other common errors. Now, one of them is if we don't name the method as described in the text, you'll get an error. Now, at the moment, we've got one here called print conversion, and that's actually what was asked. You can see up here, write another method called print conversion. If we called ours print conversion, let's say ABC or something like that, and we check our solution, we'll actually get an error. And that's because we're not following what's been asked. The method with the name print conversion and parameters of type double was not found, and it's telling us it's found these other methods, but the name doesn't match. So we have to be specific and put exactly what has been asked for us. So make sure you do check your solutions carefully there. I'll check it again, we should find the error disappears. Now, another common error you'll get is if you accidentally use, say, for example, instead of double here on line 12, if we use a capital D to do a double, to use a double class, and we'll talk more about those in a future video, but it's not exactly the same. Check the solution again. You find you'll get an error. And you can see again, it's telling us method with name print conversion of parameters and lowercase double there not found. Methods found. And you can see this print conversion, and you can see there that straight away it's telling you that there's a difference there. Capital D for double, a lowercase one there. So I'll put that back to a lowercase d again. Check the solution. All right, so that's 2 sample errors, and we've got the solution there back to be being correct again. Next, if we remove the public keyword from the start of the method, whoops, and then I'll leave everything else as it was before and check the solution, we'll again get an error because of that. And you can see it's telling us it should be declared as public static but found static. So you have to be, again, really checking the text carefully to make sure you're typing exactly what's been asked of you. Check the solution and that should fix that problem. All right, so you can see now the solution is correct again. And that's just some examples of errors that might pop up as you're going through any of your solution or with coding exercises in general. The bottom line is make sure you read this carefully and you are outputting exactly what's been asked of you from the coding exercise and using the exact data types, and really just take your time to analyze, and keep in mind that computers are pedantic, so you'll need to type your solution in exactly in terms of the output and also the data types, etc., as has been asked for in the coding exercise. Right, so the solution is correct again, and you should, if you're going through this yourself, have gone back to IntelliJ and fixed errors as well, but I won't do that now. Keep in mind also that there's many different ways to solve an exercise. You'll find many solutions shared by other students in the QA section of the course, so you will see many different solutions to the same problem. Now, as you've seen, everything needs to be exactly as has been asked, so make sure you follow the text carefully again, otherwise your solution won't be accepted. You have a warning as has come up on the screen as I've been showing you. Another important thing is don't rush to solve the exercise as soon as possible. It's much better to take some time and solve it properly. That way the knowledge will sink in. The process of actually figuring out how to solve it and going through those steps to fix any errors, reading the coding exercise text again and fixing it and reading the warnings, etc. That's how you become a programmer, immersing yourself in code and taking the time to really understand it and to fix it. So it's not a race. It's a matter of actually enjoying the journey. You sort of going through the process of learning is a journey. So it's not the end result we're looking for. It's learning and really immersing yourself with this code and letting this knowledge sink in. All right, so what I'm going to do is show you now also how to share your solution with myself and Goran and other students. What you can do is copy the solution. I'm going to click on and select that. Copy that. I'm copying that code now. I browse the Q&A. And you can see on the right hand side we've got some other options showing up on the screen here. Now if you wanted to do that, you click on ask a new question. So I suggest you type something useful here, and we'll put Tim's my shared solution, for example. Then I'm going to paste the code into the box down here. Now before posting a question, I want to show you a useful feature in the QA that allows you to format your code nicely so that it's easy for others to read and to help you. So basically you should select or highlight all the code that you just pasted, and I'm going to select that now just to show you what I mean. I'm going to select all the code right up to including the lines right at the top. I'm going to come down here and click on these this little left and right curly braces with the 3 dots or periods in the middle. Click on that. And notice how by doing that, the code is now in a little rectangle. So what that means is now that we've done that, we can scroll down to the bottom. Scroll down to the bottom and put, this is Tim's test solution for the video. Now obviously you'd put in something that you wanted to address. If you had a question, it wasn't working, that's where you'd put it. Then you click on post question, and that question would go into the Q&A section. I'm not going to post this question now, but you can share your solutions anytime you can, whether you've got it working. You might want to show us that you got it working, or if you haven't got it working and you've got a question, you can do that also. Now remember, if the code runs in IntelliJ, it still doesn't mean that it's correct per the exercise text. You have to be careful about logical errors, the naming, the spaces, and so on that we've talked about. These coding exercises are very strict and designed to be, and if one of the requirements from the text is not met, the solution, although it works in IntelliJ, won't work in the coding exercise. Alright, so that's that. We'll end the video here. I'll see you in the next video. So in the previous two videos, we tackled what methods were and how to actually put them to use in your program code. So it's now time to talk about method overloading. Now, method overloading is very commonly used in Java programming and actually in other programming languages. And it's the option where you use the same method name, but with different parameters. So as an example, we're going to type in some code to show you what this looks like and how you go about it. So let's start by creating a method. I'm going to call this method calculateScore, and we're going to type it as public static int calculateScore, and we're going to have two parameters here. The first one is going to be player name, that's a string, and the second parameter is going to be score, which is an integer. So I'm going to type SOUT and press tab to print the system out, and I'm going to type in player plus player name scored plus score plus points. And then what we're going to do is return score multiplied by 1000, which is an arbitrary number which we're not going to use anymore. We've just done that so that we can return something, and that's because we've defined the method to return an integer. So just to confirm that that runs, we can actually type the name of the method as you've seen before, calculateScore. I can pass a parameter of a string in double quotes for my name, and let's just put a number. We'll say 500 points, and if we run this, we should find that we get it to work. We see over here player Tim scored 500 points, and if we wanted to, we could take the value that's returned, because that's what return does. It actually returns whatever the amount is back to, in this case up here on line 6. We could change that if we wanted to put new score equals calculateScore, because you can see that on line 12 we've multiplied score by 1000, and we could print that out as well. But new score is plus new score. We run that just to confirm it works. New score is 500,000, which of course is 500, which we passed, times 1000 is 500,000. So that's how you use a value that you've calculated in a method and return it. And from the process that actually called the method, you can then use that value for some sort of calculations if you want to. So nothing particularly unique there. We've seen that similarly set up and used in the past. Okay, so let's go about overloading the method. Now I may have said overriding earlier in the video, but just to be clear, this is overloading methods. So overriding has got a completely different meaning, and we'll be talking about overriding later in the course, but this is overloading methods, which is basically using the same method name but with a variable number, different number of parameters. So we're going to start off by creating a second one, and actually what I'll do is I'll copy it, copy the method, and I'll paste it. Now notice when I do that, first of all we get an error, and it says calculate score, and note the string comma int on screen is already defined. So that's Java telling you, look, you can't use an identical method with an identical number of parameters. There's a problem there. So options to fix this, well, the first option would be to put an S there to make it a different method name, and of course that will work, but that's then a separate method. We're not actually overloading the method, we're creating a new method. So in this case we don't want to do that. So the way we do it is we change the number of parameters. So I can get rid of the first parameter and make it so that this method now has only got one parameter, which is the score. And notice that the overall error went away, that we've got an error here now on line 17 because we're trying to access a variable with a parameter that no longer exists in this particular method. So I'm going to put unnamed player, and what we'll do is we'll put scored 500 points. Now notice there's two methods there now, and the error, well, not an error, it's a warning on the screen now because it's grayed out, the method name compared to the one on line 11 is saying that that's never been used before. So that's just IntelliJ saying, look, by the way, you've created this overloaded method called calculateScore, but you're not using that particular one. You're only using this first one, which is in the brighter color, and you can see that we're using that on line 6. So we can still run that, and we still get the same results we got prior to overloading the method. But to actually use the second method, what we need to do is we need to type it. Now notice when I started typing, IntelliJ now shows us that we've got 2 methods here, and we can select which one we want. So if I select this top one with the single parameter, press enter there, noting that there's 2 options on the screen now. IntelliJ is sort of saying, well, there's 2 ways that you can access these methods. You can either use the first one, in which case I need a player name and a score, or I can use the second one, in which case I only need a score. So I'm going to use the second one and just say type in a value like 75. And you can see that that's valid. And that's now going to call that second method if we run it. So let's run it to make sure that does work. Unnamed player scored 75 points, which is clearly the code from the second method. Now Java is checking, so we can't actually do something like calculate score. I'm going to put 100, 100. We'll actually get an error there. And the error that's coming up saying is the first, it's the wrong first argument, found int required a string. So what IntelliJ is saying there is, well, okay, if you want to call this overloaded method with 2 parameters, I know that you've calculated and set up one on line 13, but that needs to be a string. So that's what it's complaining about. And if we added a third parameter, then it just sort of says altogether, well, hang on a minute, you haven't actually created an overloaded method with 3 parameters of int. Now notice that it's actually saying int, comma int, comma int. And the point to all that is that what makes it unique is the data type in the parameters. So it's not what you've typed in for the parameter name. That can be literally anything you want. That's no problems. The thing you need to keep to get the same to, or what Java uses to determine whether it's unique or not, is the data type. In this case, the string and the int. Okay, so let's do one more. Let's try and create a method now that's got no parameters. That's a third one, and at the moment that's going to come up and say can't resolve method. And that's just as in the case as if you made a typo creating a new method. This is now saying, well, hang on, you haven't got a method with that name. So let's now try and create another overloaded method with no parameters. The way we would do that is we get rid of the parameters and then we put a player name, no player score. And we can't return anything, so let's just return 0. Can't return anything because we can't calculate anything because we haven't got a score to work with. Now notice that that's now valid and we can actually run that. So we run that now. You can see we've got all 3 methods working on there and they've all got separate output, and you can see that output working quite nicely on the screen. So what we're trying to do here, when we're overloading a method, we need to create a unique method signature. So the signature is essentially here is the unique part is the actual method name. You can see that's the same in all 3 cases here, but it's also then the parameters. Now you might think that you could change something here. You could say, well, okay, let's create another method, calculate score. I'm going to copy that and paste that, but let's make it a different return type, or make it maybe a void instead of an int. So to return a void instead of actually, and I'll get rid of that, because there's no return now because it's a void. So you might think you can do that by changing the return type. Does that make it unique? But the error we're going to get here says calculate score is already defined. And what Java is telling you is that just changing the data type of the return type, the type of data that's going to be returned from the method, doesn't change the overall signature. So you do need to change the number of parameters there to make it unique. So I'll just delete that line again. Okay, so that's essentially how overloading of methods work. So what I'm going to do now is issue with a challenge to get you to do some overloading of your own. So I'm just going to paste in what the challenge is, and then I'm going to get you to go away and have a go at doing it, and then ultimately I'll actually do it on screen for you as well. So let's paste that in up here. So here's what needs to be done. So we need to create a method called calc feet and inches to centimeters, and that needs to accept 2 parameters. First parameter is feet, and the second one is inches as the second parameter. Both should be of type double, and I mentioned towards the bottom of this section in the hints area to use doubles for your data types. That's the best way to calculate here. But I also want to show you or get you to do some validation. So in other words, we want to confirm that the data we're working with is valid. So you need to first check that the first parameter feet is greater than and equal to 0. So long as the number is 0 or higher, we're going to say that that's a valid number that we can work with. So in other words, we're not going to accept numbers that are less than 0. And for inches, the second parameter, we want to make sure that it's greater than or equal to 0, and that it's also less than and equal to 12, which is the valid range of inches when you're looking at feet and inches together. Now, if you find that either of those conditions fail, so in other words, if feet is less than 0, or inches is less than 0, and inches is greater than 12, so if it's outside that range, in other words, you want to return -1 for both those scenarios. But if the parameters are valid, so in other words, we've got a valid feet parameter and valid inches, and we've validated that it's within the range that we want to work with, at that point, I want you to calculate how many centimetres comprise the feet and inches parts of this method. So you need to take the feet and inches, convert them to centimetres, and actually return that value back to the method that's calling it, and also print it out on the screen. Now for the second method, where we're going to overload this first method, so it's going to be obviously the same name, but we're only going to use one parameter, and the parameter is going to be inches. So we need to validate it again, and in this case you only want to validate that it's greater than or equal to 0. Unlike the first method, in this one we want to actually accept an inches parameter that can be literally any number. So we can accept 50 inches or 100 inches, and you still need to then convert it to centimetres. So you need to figure out how to convert that back to feet and inches so that you can call our first method, which has got the feet and inches parameter. So you'll need to figure out how to do that. So that's the tricky part, is working out how to do that, but then also calling that first method that we've created. So actually making sure that you're calling the right method. So you're calling one overloaded method from another overloaded method, if that makes sense. And in terms of hints, as I mentioned, use double for your numbers, data types, for your number data types. That's a good idea here. 1 inch equals 2.54 centimetres. You'll need to know that in terms of calculation. And if you don't know, 1 foot is 12 inches, and you'll need to know that also when you're doing conversions to and from inches to feet, etc. Now I'm going to show a link on the screen shortly, and this will show, this is just a website that you can go to verify your numbers are working. And from there you can confirm that your code is working. And just secondly, recalling another overloaded method, as you saw earlier in this video, just really requires you to use the right number of parameters, and then Java will do the rest. So keep that in mind when you're determining how to call one overloaded method from another. Let's go and have a look at this website before I pause and let you go away and create or your version of the code. So there's the website on screen there now, and there'll be a link to that in the resources section. So we could type something like 6 for 6 feet, and that's 182.8800 centimetres. So you'll just type in either the number of feet or the number of feet inches, or just the inches, and this will tell you what the centimetres are, and from there you can confirm that your code is correct and working properly. Okay, so that's it. So pause the video now, go away and complete the challenge, and when you're done and you want to come back and see what I've done, come back and I'll show you my solution. Pause the video now. Okay, so I hope you had some success and managed to get it working. So let's now go through and try and solve this. So what we're going to do first, well, actually, before I do anything, I'm going to make a bit of space here. And what we're going to do, I'll just make sure that this is still on screen so we can read it if we need to. Let's create our first method. So it's going to be public static double, and it was calc feet and inches to centimetres. And remembering that I asked for 2 parameters, the first one was double feet, double inches, like so. And we've got the double to return because we're going to ultimately return the number of centimetres. So what we need to do is some validation. So we need to make sure that feet is greater than or equal to 0. And we need to make sure that inches is in the range of being 0 or greater, but less than or equal to 12. So we're going to use some if logic, and also use the ampersand as well to chain together some and conditions to do all this checking on one line. So we're going to put if feet is less than 0, and actually what we'll do is we'll use an or instead. So if feet is less than 0, it means that's invalid. Or we'll put if inches is less than 0 and inches is greater than 12. If all that is the case, I'm going to open a code block and type return -1. So So that's our validation. So what we're doing is we're saying if feet is less than 0, and we determined up here if it's less than 0, it's invalid, so we don't want to do any more processing. Or, remembering the two pipe characters are or if the inches is less than 0 and the inches is greater than 12. So both of those have to succeed in that case. So inches has to be less than 0 and greater than 12. So if it's outside the range in both those scenarios, we're going to return -1. That means we're going to do no more processing. But if we continue on down here, we know that return -1. So if that's the case, it's not going to come down here and do any more processing for us. So at this point, we can get to line 44 knowing that we've got valid parameters. So let's now do some calculations. We're going to put double centimeters equals. So we need to start figuring this out. So let's convert the feet component to centimeters first. To do that, we're going to put feet times 12. So why 12? Well, 12 is the number of inches in a foot. So by multiplying by 12 and then multiplying by 2.54, which we determined up here on line 32 was the calculation to convert an inch to a centimetre, we've now converted the feet, total feet that was passed to this method to centimetres. Now that still leaves the second parameter, inches. We need to separately convert that and add that to our total. So to do that, we're going to type centimetres plus equals. So we're going to add to centimetres, add the value. So we're going to take the existing value that we've already calculated on line 44, and to that we're going to add inches times 2.54. So we've now got centimetres to be has been correctly calculated for both feet and inches. So from that point we can then go print out a message. We can put let's put feet plus inches equals centimetres, cm abbreviated for centimetres. And then lastly we'll do a return centimetres. So let's go ahead and run that, and then we'll have a bit of a discussion about -1 as well, because I haven't actually mentioned why you'd be returning -1. So let's run this first. Actually, before we run it, what we need to do is call it something, because this is telling us, by the way, that okay, you've defined a method but you've never used it. So let's put an example up here, and let's put calc, and we'll say let's start with the 6 feet 0 inches, because we did that before. And just as a refresher, we determined that it was 182.88. That should be the number that we're looking for. We'll run that. 6 feet 0 inches equals 182.88 centimetres. So that's good. We've got the calculations correct. And let's just try one more. Let's try, say, 7 foot and 5 inches. We'll run that. 226.06 centimetres. And we'll go back to our website and we'll make this 7 foot 5 inches. 226.06. 226.06. So clearly that's working. The other thing we can try and do here is let's try and make that a -1 and a 1. We should get an error there if we run that. It's just a bit confusing. I won't make it -1. Let's make it, say, -10. Run that. Now notice we haven't got a message at all. So in other words, what's happened is this code here has been fulfilled. So what we might do is we'll put a message here to say invalid feet or inches parameters. Let's do that just so we know that if it's errored and tried to return, we know that the parameters are invalid. Invalid feet or inches parameter, so that's good. And just to make a test there, we should be able to put up here, we will actually pass a parameter of 0 just to make sure that that does actually work. 0 feet 1 inches equals 2.54 centimetres. That's good, so it's still accepted 0, which we wanted it to do. So likewise for inches now, let's try, we'll go back to say 6 foot again, but let's try -10 for inches, which should give us an error. And we've got an error there, so why have we got the error there? So we should have actually had a test here to check whether our inches is out of range, and for some reason that's still working. So let's just go down and have a look at the code. So we've got if feet is less than 0 or inches is less than 0, and that and is actually wrong. So that and should actually be an or. So we've got two parts here. This is where it does get a bit confusing, which you need to look at the brackets. So I've got an and, but of course inches can't be less than 0 and greater than 12. It can only be one or the other. So therefore we want to test to see whether inches is less than 0 or it's greater than 12. So let's try running that again. Invalid feet or inches parameter, which is correct now. And let's try and put the value 13 in there. Run that. invalid, which is good, but let's now put a valid range in there, 6 foot 0 again. 6 feet is 0 inches. It's still giving us the correct value. So our validation was slightly wrong there, and this is why testing can be a good idea sometimes, just to make sure you've got your values correct. Now, the reason I'm returning -1 here, this is a good way to test for validation to check whether your calculations are correct. And what you could do here is ultimately you could have something like int centimeters. Sorry, it's not an int, it's a double. And we'll put if centimeters is less than 0.0 because it's a double. I'm going to print out a message here to say invalid parameters. Let's just run that. That hasn't come up, and that's because the data we got returned was centimeters, which was greater than 0. So that's correct. But if we change this to an invalid number again, 13, invalid parameters, as you can see there. So that's just a way of checking your parameters, and -1 is something that's commonly returned if there is a fault, if there is actually a problem with your code, and you could test for that like I've done here, if it's less than 0.0, or I could have done an equals test to see whether it equals 1 to print out an error message. So that's why I've used -1. Okay, this video is getting quite long, so let's see if we can finish off this second method and then end it. So what I'm going to do for that next method is I'm going to copy just the first line. And it can be a good idea to do this, to copy just the first line to make sure that you haven't made a typo, because obviously overloading a method relies on you typing the method name correctly. So if you're not typing it correctly, you're going to get what is a new method instead of overloading a method. So at the moment that's complaining because we've got another method of the same number of parameters. Let's change this now so it's just got inches, because if you recall, the second method only accepts inches. And a validation is that it's greater than or equal to 0. So this is much easier. So our validation should just be if inches is less than 0, return -1. So that's our only options here, is to check whether it's less than, if it's less than 0, then it's an error. So now what we need to do is we've got an inches parameter, but we need to call the overloaded method on line 43, and that needs us to pass the feet and the inches. So we need to convert the inches to feet and inches, if you know what I mean. So we need to extract firstly the number of feet that are in our inches, and then whatever the remainder is going to be the number of inches that forms part of the second parameter. So to do that, I'm going to type double feet equals, and I'm going to use int here, and that makes sure that it's converted to a whole number, inches divided by 12. So whereas we used multiplied by 12 on line 50, in this case we're dividing it by the inches by 12 to get the number of feet, and then that's the first parameter we're going to use, and the second one is going to be inches, so we're going to call that remaining inches, and we're going to use the remainder operator for that. So the way we can go about doing that is we can just put int, again we want a whole number, it's going to be inches remainder 12. So basically, again, as you saw in a previous video, using the remainder operator, it takes whatever you've typed as a number, divides that total number by that, and gives us the remainder. So in this case, what we're doing is we're basically dividing the inches parameter by 12, and whatever's left over from that is going to be put into our remaining inches. And we're doing that obviously to get just the remaining inches after the feet has been calculated. Once we've done that, we can actually output it. So let's do some output, and it's going to be, we'll type inches. Inches is equal to, we'll put feet, and remaining inches. And lastly, I can type return calc feet and inches to centimeters. So we're going to call the first one, and we're going to pass the two parameters, which are feet and inches. So you can see that I've killed two birds with the one stone there, so to speak, by returning and calling the method at the same time. So the return is going to get whatever the calculation is from calling that method up here. So we're actually passing the feet and inches to it so we can calculate, and that's going to return that value ultimately to up here where we're going to call it. So what we're going to do now is we're going to type calculate feet and inches, and we're going to pass 100 as our inches. And note that there's two options there because it's an overloaded method. We're going to go with the first one, which is passing 100. So let's run that and see that it works. And you can see what I've done here. So what I've actually done is I've passed the wrong parameter, haven't I? So you're wondering, why is this coming up saying invalid feet or inches parameters? What I've done is I've passed the second parameter as inches. Well, inches was 100. We called this second method, the second overload method, with a parameter of 100, and I've accidentally typed that in here as the parameter to call this first method. So what that should have been, of course, was remaining inches. Let's go ahead and try running that again. And now we've correctly got 8 feet 4 inches is 254 centimeters. So let's check that, 8 feet 4. So 8 feet 4, 254 centimeters. So that's correct. And just for kicks, let's do one more. Let's make this say 156. Run it again. 13 feet 0 inches is 300. That's a bit funny that I got that exact. Let's try and make it 157. I just want to see that it's working correctly. And we'll run that. There we go. 13 feet 1 inches. Let's try that. 13 feet 1 inch is 398.78 centimeters. 398.78, it's got 0.00003, but we're only looking at the first couple of decimal points up to there, and you can see that's clearly correct. So that's our code working, and the last thing to check would be our validation. We're going to put a -10 there, just to make sure that it works. If it doesn't work, if it's invalid, and we get no data back whatsoever, and that's because we've got this code in here saying if inches is less than 0, return -1. And we haven't got anything outputting here on line 15, which is why we haven't got a message. So I'll put that back to what it was and run it one last time. So that's it. That's my solution. Hopefully you enjoyed that and got a lot out of it. So method overloading is something that you will see a lot of in Java code. It's very commonly used. And although this particular example is a bit contrived, because it's probably going to be rare that you'd ever need to know that 100 inches converted to decimal is actually 157, which we established. Very rare that you'd need to know that 157 inches is equal to 13 feet and 1 inch, but this was just an example more of showing you how to use method overloading. In practice, when you're out there producing real sort of production Java code, you'll find overloaded methods are indeed very common. So that's it. I hope you've enjoyed that and got a lot out of it, and I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So let's have a bit of a recap on what we've learnt about method overloading and discuss the benefits of using method overloading. So confirming again as a recap that method overloading is a feature that allows us to have more than one method with the same name, so long as we use different arguments or parameters. So it's the ability to create multiple methods of the same name with different implementations. Calls to an overloaded method will run a specific implementation or version, if you will, of that method. Now in the example from the previous video, we had the calculate score method that had 0, 1 and 2 parameters. As an example, let's say that you have to create a method which can do the sum of 2 numbers, the sum of 3 numbers, and the sum of 4 numbers. Now each method would have parameters passed to it with the numbers to sum. So ending up with the following methods in this example is not good practice and actually is not method overloading. So you'd never want to write code like I'm showing you below, because it's considered bad practice. And you can see in this scenario we've got 3 methods with different names to remember. So the main problem here with these methods is that you have to remember 3 method names that do the sum. Now imagine that you wanted to have a method that adds up to 20 numbers. You'd effectively end up having to write 20 different methods with 20 different names. Remembering 20 names would be quite hard. So to overcome this problem, we can use the same name for the method. So let's see an example of that. So a solution to that problem with method overloading would still end up with 3 methods, but note that they're now all sharing the same method name. Much easier to remember. So we've got a method that sums, overloaded twice, with 2, 3 or 4 parameters. So that's an example of how the method should be written. In other words, we can use the method overloading feature and write methods with the same name. So that way, we just need to remember one name of the method, which in this case is sum. All right, so let's now see both examples at once. So at the top there, we've got the bad practice, and that's with the 3 different method names. And again, the reason we're not doing that is firstly, it's not method overloading, but secondly, it's hard to remember method names that are different there. In the example below, we've got 3 methods with the same name. We just have to remember one method name, and it gives us more flexibility. You can see how method overloading can be very helpful in scenarios like this. And keep in mind that method overloading is a very common thing. It's used everywhere and in many other languages as well. So as an example, the println method, which of course is part of Java, that's a great example of method overloading. There's actually 10 methods with the same name, println, in Java, and that's allowing us to print an integer, print a double, print a string, and so on. So you can see that's a good example of method overloading. So as a final recap on method overloading, it improves code readability and reusability. It's easier to remember one method name instead of remembering multiple names. It achieves consistency in naming. So one name for methods that are commonly used, and it's an example, println, from the Java language itself. And finally, overloaded methods give programmers the flexibility to call a similar method with different types of data based on the arguments or parameters that you define. So that's the method overloading recap. Let's now move on to the next video. Alright, it's time for a challenge. So this is the seconds and minutes challenge. So the challenge is to create a method called getDurationString with 2 parameters. So the first parameter should be minutes and the second parameter should be seconds. That's the names. Now they're both going to be ints, and you should validate that the first parameter, minutes, is greater than or equal to 0, and you need to validate that the second parameter, seconds, is greater than or equal to 0 and less than or equal to 59. Now the method should return the string invalid value if either of the above are not true. Now if the parameters are valid, then calculate how many hours, minutes and seconds equal the minutes and seconds passed to this method, and return that value as a string in the format XXHYYMZZS, where XX represents the number of hours, YY the number of minutes, and ZZ the number of seconds. So once you've done that, create a second method of the same name, but with only one parameter, seconds. So you validate that it's greater than or equal to 0 and return invalid value as a string if that isn't true. Now if it is valid, then calculate how many minutes are in the seconds value and then call the other overloaded method passing the correct minutes and seconds calculated so that that method, the first version of the overloaded method, can calculate it correctly. You then want to call both methods to print values to the console. Now, a few tips here. Firstly, use an int or long for your number data types is probably a good idea. You probably know this already, but 1 minute is 60 seconds and 1 hour equals 60 minutes or 3,600 seconds. Methods should both be static, as we've used previously. So in other words, create your methods as you normally have done so far in the course. And as a bonus, for the input 61 minutes, the output should be 01 hours, 01 minutes, 00 seconds, but it's okay if it's 1 hour, 1 minute, 0 seconds. In other words, if you haven't got those leading zeros. As a tip there, consider using if-else to achieve that. Alright, and then you want to create a new console program and call it Seconds and Minutes Challenge. Alright, so pause the video now and go ahead and complete the challenge, and when you've done that, come back and see what I've done and we'll go through it step by step. So pause the video now. Alright, so I hope you managed to have some success with the challenge. So let's now go through it step by step to get this working. Alright, so what we're going to do is start with the challenge. And I've got a challenge text file. I'm just going to show that on the screen now. And any time that we want to go back and check, you can actually refer to that. And that text file is in the resources section of the video, just to make it a bit easier for you to follow along step by step. Alright, so first things first, you can see that I've already created a seconds and minute challenge, and I've already created a class called main, and I've already created the method for main as well so that we can test our code. So the first step we need to do is go back and create a method, getDurationString. So let's go ahead and do that. So I'm going to call that private static string getDurationString. parentheses, and we're going to use longs here, so long minutes and long seconds. But if you used an int there, that's okay as well. Right, so that's our method, firstly. Now, by the way, if you haven't added public or private here, the code will still work. But later on, we're going to discuss the public keyword and other modifiers that you can use with methods. So I'm just going to put the word private back in there, but we'll talk about that a lot in detail as we progress through the course. All right, so we've got to make the string return something that represents the hours, minutes, and seconds, or an error if the validation fails. So what we want to do first is start out with some validation. So we need to make sure, if you recall from the challenge, the minutes has to be greater than or equal to 0. We need to make sure that the seconds is in the range of being 0 or greater, but less than or equal to 59. So I'm going to use some if logic and also use the or operator as well to chain together some conditions to do all the checking on one line. And you'll see that as I type that through now. Let's go ahead and do that. So I'm going to put if, two left parentheses, minutes is less than 0, and close the first parentheses. Then I'm going to use or, and another parentheses, seconds is less than 0, closing parentheses, then or again, parentheses, it's going to be seconds is greater than 59, and then two closing parentheses. And if that is the case, we need to return the error message, which in our case was return invalid value. So you can see what I've done there. The first part of the condition is checking minutes less than 0. So if either of those three conditions there are returned as true, then we're returning invalid value. So if minutes is less than 0, or seconds is less than 0, or seconds is greater than 59. Now, if you've done that over a couple of lines to do the same thing, that's fine. This is just a concise way of actually achieving the same validation. So at this point, if we get down here to line 14, we know that both the minutes and the seconds variables have got valid values in them, and we can start assuming that and work with it. So let's now start by converting the total minutes that were passed to this method to hours. So we can do that by typing long hours equals minutes divided by 60. So that's how many hours, if any, there are in the minutes that have been passed to this method. So now we have to calculate the remaining minutes. So minutes were converted to hours, but if we have, for example, 61 minutes, that's actually 1 hour and 1 minute. So therefore we need to calculate how many minutes cannot fit into 1 hour. So what we can do to do that is type in long remaining minutes is equal to minutes, use the remainder operator 60. That's how many minutes are now remaining. And from that point now, we can now return our data. So we can type return hours plus H space plus, and H was in double quotes, remaining minutes plus, and M after that in a space in double quotes, plus seconds plus, and an S on the end of the line. All right, so that should be our method correctly written. Now, before we write the next overloaded version of that method, let's actually test this out first. So what I'm going to do is come back up here to our main method and do a S out and tab. The output's going to be get duration string, and the two parameters we're going to pass 65 for the number of minutes and 45 for the number of seconds. So let's actually run that and make sure that it works. You can see we quickly got the results there, 1 hour, 5 minutes, 45 seconds. So let's just move this down to the bottom. Okay, so far so good. And by the way, don't be confused by this code here in parentheses. This is just calling the method getDurationString first, then the return value from that method will be the parameter for the println method. So it's just a shortcut way to get that happening all on one line. If you've done it over 2 lines, perhaps you've assigned the value of getDurationString to a string variable and then you're outputting the string variable with a print line on the next line, that's fine as well. The bottom line is you get the same results. In this example, we should have got 1 hour, 5 minutes and 45 seconds, and that's what we've got. So before we deal with the bonus part though, let's finish the other method first. So what we have to do is write another overloaded method, and obviously an overloaded method is one that's got the same name. We have only one parameter in this case, seconds. So let's do that. So I'm going to come down here and type private. Again, don't worry too much about private or public here. Just type it in for now, and if you haven't used private or public, that's fine as well, because we'll be explaining that in detail later in the course. So we need a string here, and it's going to be get duration string again. But this time the parameters are different. We've only got one parameter here, and it's going to be long seconds. I'll just close down the run window for now. So in this case, we've got to check that the parameter seconds is greater than 0. So that's a simple test there. And what we can just do is type if parentheses seconds is less than 0. If that's the case, we're going to return our error message, return in double quotes, invalid value. All right, so that's that done. So notice here that we're repeating the same string in both methods, which is invalid string. For the time being, that's okay. And I'm referring to the code on line 11 and also the code on line 21. But later in the course, I'll show you how to deal with situations like this and use something called constants. But we're early in the course, so we'll just continue as it is right now. We'll just get our functionality working, and once we've got it working, we can then optimize our solution. So here we've checked there to see whether the seconds are less than 0, and that means that it's going to be an invalid time that we can't calculate, because we can't calculate a time in negative. That's a negative number, so we've got that returning. So if it gets down to this line here, now line 24, we know that we've got a valid amount of seconds to deal with. So what we now need to do here is very similar to what we did in the first method. In this method though, we've just got seconds. So what we can do is still convert minutes to seconds. So let's go ahead and do that. We're going to type long minutes is equal to seconds divided by 60. So that's how many minutes we've got. Then long remaining seconds, well, that's equal to seconds, then the remainder operator 60. So we've now calculated the minutes from the seconds, and then calculated the remaining minutes again using the remainder operator, as you can see, and stored that in the remaining seconds variable. So now we've got minutes and remaining seconds. All we need to do is call the first method. Instead of repeating the same code from the first method, we can just call it. So what we can actually do there is we can type return get duration string, and in parentheses we can pass minutes and seconds. I'm just going to clean those lines up. So here what we've done is we've used the return keyword and the method call on the same line. And again, if you've done this over 2 lines, perhaps you've saved the value of the call to get duration string into a string on one line and then printed it out and returned that variable on another line, that's fine. I've just made it concise here and done 2 things on the one line. So again, what's happening is that the method call will be called first, and then the return statement will return the value that it got from that method call. So don't think that we're returning the method itself, because we're not doing that. What we're returning is the return value from that method. And again, even though I mentioned it, another way of doing this would have been just to put string x equals remaining get duration string and return x. That would have worked just as well. So we're consolidating that into one line by doing it this way with returning get duration string directly. All right, so that's almost it. There's only the bonus left, but before we work on the bonus part, which we'll do in the next video, let's test what we've done here and make sure that that's working. So what we're going to do is come back, and I'm going to, on the next line of output in the main method, we're going to put in get duration string, and we're going to pass a value of 3945. Now in general, it's a good idea, because we're using longs, to use longs, and I haven't really done that so far, but a good idea would be to actually use an L. If you recall, L was the indicator in Java for longs, to make sure that it was a long number that we're using. And to be consistent, we could also do that for these previous lines as well. But okay, we've got that in there now. Let's actually run the application and see what happens. Now that's interesting. You can see what's happened there. We've got the output, the first line of the output down here down the bottom has got our correct value. But the second line has got invalid value. Now can you actually spot what I've actually done wrong there? I'm just going to close the run window again. So you can see in that code, what have we done wrong there to cause that not to work? Well, if you look really closely, what we're doing here is we're passing minutes and seconds. So I'm incorrectly passing seconds instead of remaining seconds. And the problem is that's then passing seconds to our get duration string, and it's validating to make sure that seconds cannot be greater than 59, so it's returning invalid value. So that can be an interesting one to debug if you do something like that. The solution there was for me to take a copy of remaining seconds and return that and not seconds. So now if we run this again, we should find it gives us the right answer. And you can see in that case we've got the same result, 1 hour, 5 minutes and 45 seconds. So we've got the same result now for both of them, and that's great. Right, so that finishes the challenge. The bonus part is optional, but I want to show you the solution to the bonus part as well, and we'll do that in the next video. Alright, so this is the bonus solution, the optional part from the challenge that I introduced 2 videos ago. So this is the solution where I'm going to go through and show you that bonus part. So the bonus part was to display a leading 0 if we only have one number for minutes, seconds or hours. And we can use an if statement to check if we've only got the 1 digit. But when do we actually have 1 digit? Well, there's 1 digit when the number is less than 10. So the number 10 is the first number with 2 digits. Now, there are many ways to format, or in other words, to add leading zeros, but we're going to use only the knowledge presented so far in the course with this solution. So the easy way is to use an if statement. So what we're going to do is split the return string into 3 parts, namely the hours, the minutes, and the seconds. So let's go ahead and start that. We're going to come down here after the calculation. This is in the first method with minutes and seconds. And we're going to start after we've defined that. We're going to put string hours string is equal to hours plus then H in double quotes. Right, so that's the first step. So we've converted the number of hours to a string with the letter H on the end of it now, and add it to a variable called hours string. Now there's also some methods that we can call instead of appending the letter H, but we're going to be covering those methods later in the course. So what we now have to do is check if the hours are less than 10, and in that case we have to prepend the leading 0 to the existing hour string. So what we can do there is we can put if parentheses hours, if they're less than 10, add a code block, and then we're going to put hours string equals double quotes 0 plus hour string. So that's going to add a leading 0 to the hours if the hours, the total hours, is less than 10. Now for minutes and the seconds, we can do the same. So what I'm going to do is paste in the code, and we'll do the same for both. I'm going to take this down here, take a copy of those lines. We'll paste it once, and we'll do this for the minute string. So we'll call this one minute string. Minute string, and the test there is going to be remaining minutes. So if it's not hours anymore, it's going to be remaining minutes. If that's less than 10, then we're going to add 0. So then we're going to paste in minute string for both of these. So in other words, we're adding the 0 to the minute string if that's the case. Then we need to do the same to seconds. And what I'll need to do is just take a copy of this again. And the other thing I need to change there, of course, before I do that, is remaining minutes, because we're dealing with remaining minutes there. So I'm going to copy this next line, paste it down, and we're now at the stage of doing seconds. So seconds string, that's going to be equal to seconds plus S. The other thing I didn't do here was change the H to an M there for minutes. So let's do that. Then we're going to do if seconds is less than 10, then we're going to do second string equals 0 plus second string. So you can see what we've done there. We've got hours calculated here, then we've got minutes calculated, and then we've got seconds calculated. So the last thing we now need to do now that we've done those calculations is use those in our return. So we're going to come down here, instead of hours, we're going to be returning the hours string. So hours string. And now the other thing is, because we've already added the H, we no longer need to do that. So we just need to add a space here. So I'm going to delete the H and leave the space, so there's still a gap between them. I'm going to change minutes now to minutes string and get rid of the M there. And for seconds, that's going to be seconds string, and get rid of the S on the end there because it's already added by our code here on line 28. So that's joined the three strings now with spaces. Now there is a method called join in Java that we could use for this, but again what we're doing is we're using the knowledge and what has been taught so far in this course. I just want to make it clear that there are more optimal ways of doing this, but I'm trying to show you challenge solutions based on what you've learnt so far, so you're not getting introduced to things in my solutions that you haven't already learnt. Alright, So now that we've done that, let's run the application and see if it works. Alright, so you can see there in that case, we've got 0, 1 for the hours now because the hours is less than 10, 0, 5 for the minutes because the minutes were less than 10, and we've got 45 seconds working and showing correctly, and that hasn't got a leading 0, which we would expect because there's no leading 0 because we're using a number that's greater than 9. In other words, 10 or higher. Alright, so this code can be even more optimized. We've still got some repeating code. So notice how those if statements are almost the same. So what we could do is create a method to somehow deal with that so we didn't have that code that looked almost the same. But we won't do that for now. With the knowledge that we've learnt so far in the course, what we've got here is a pretty good solution. But before I end the video, I just want to show you how to use constants. Now keep in mind that this wasn't part of the challenge. I just want to show you another way of solving it. So firstly though, what is a constant? Well, think of a constant like a variable, but a variable that we cannot change the value of once we've assigned it. So it's got a constant value. Now constants can be very useful. We repeated the same string twice. This string, if we come up here and have a look, invalid value for this get duration string there, and also we reuse that again up here. So it's used in both methods. We're returning the same string when the parameters aren't validated. So instead of typing the same string twice, we can create a constant instead. Now to use this constant in both methods, it needs to be declared outside of the method. Now later in the course we're going to talk more about variables that are declared outside of methods, but for now though, let's just focus on constants. So as I've said previously, constants can't be changed once they're assigned. So to assign one, we come up here to the top, we're going to type in here after main, and I'm going to type private, remembering that we're going to be talking about what private means later in the course. So I'm going to do static, final. We're going to put in uppercase, noticing how I'm typing in uppercase, invalid underscore value underscore message equals, and it's going to be equal to invalid value. And what I didn't do there was put the type. So it's public static final string invalid underscore value underscore message equals, then the value that we want to assign it, in this case, is invalid underscore value. So that's our constant, and notice the keyword here, final. That keyword is used to make a variable final. So in other words, once we've assigned the value, which we've done on the same line here, we can't change its value. And then we've got after final, we've got string, which was the type that I missed originally when I typed it in. That's the type of the constant, which in this case is a string. And then our value is typed in after the name on the right-hand side. Now we've also got the keyword static here, and that's because we're using this variable in static methods. Now later we're going to talk more about the static keyword. But for the time being, just remember if we need to use this variable in a static method, remembering that a static method is a method that's using the static keyword, and by default that's all we've been using so far in the course. So if you want to use a variable that's been declared outside of a method, it needs to also be a static, which it is in this case. But again, more on that later in the course. And just to confirm that, if we come down here and we try and change the value, so let's try and say invalid value, invalid underscore value underscore message equals hello. Notice we've got a red underline by IntelliJ, and if we hover over it, cannot assign a value to the final variable invalid value message. So IntelliJ helpfully prevents you from doing that. And the other thing you might be wondering is, why is this typed in uppercase? Constants are usually typed in uppercase so that they're easily identified as constants in your program code. And that's because they're not going to be changed. Alright, so I've established that a constant cannot be changed. Let's go ahead and use this in our code. And to use it, we can just return and use that constant value. So invalid underscore value underscore message. You can use it there. Then we can come down to the second occurrence of it and also use it down here. Invalid underscore value underscore message. So now we're returning the value of the invalid underscore value underscore message, which we defined up here as invalid value. So when we run our code, we should get the same results that we got last time. You can see we've got the same results on the screen. Everything's working as it should. The other reason for using a constant here is it can be really useful in case you're making a typo. So when you're typing the same string multiple times into a program, it's easy to make a typo. For example, forgetting a letter or typing a letter in uppercase and so on. And that's where constants can really help us. We will talk more deeply about constants later in the course, but as you can see, they can be very useful. They help us with changing code. So for example, if we change the constant to some other string, both methods would be affected since they both have the same change. In other words, both methods use the same constants. So now that I've said that, let's actually test this out to make sure that it's still working. And we can do that by adding one more solution to our main, one more call to our get duration string, and I'm going to pass a value of -41 here for the long. So let's run that. And you can see that we've got invalid value there, so that's clearly working as well. And the other thing we didn't test, which we probably should have, is test to make sure that the seconds also work if the value is under 10. So let's add one more for that. I'm going to return get duration string again. I'm going to return 65, but 9 instead of 45. And we know that that's a number less than 10, so we should get a leading 0 for seconds. And you can see seconds is now correctly showing us 9 seconds, which is what we passed, so that too is correct. Alright, so as you can see, everything's working and our constant's printing out the word invalid value, which we expected to do, and the changes we've made have now meant that we've got a leading 0 for hours, minutes and seconds if the value of those are less than 10. And just a confirmation here that there's still space for improving this solution, but again, as I've indicated a number of times, the challenge solutions that I'm coming up with are based on what you've learnt so far in the course, so that I'm not putting something in the solution, in my solution of the code, that you haven't already seen or used so far in the course. So you'll find later in the course that once you've got some more knowledge, you would probably approach the solution to this in a different way than what we've done here so far. So that's it. I hope you've got a lot out of that, and let's move on now to the next video.
Welcome to section 6 of the course. Tim Pachalka here again, and in this section we're dealing with control flow statements. Something that you really need, essential for programming, is to be able to flow and to decide where the flow of the program is going to go and what code is going to be executed. You're going to be learning that in this section. We're going to be dealing with the switch statement, the for statement, the while statement, and the do while statement. These are the 4 key control flow statements that you need to understand to get the most out of Java. So let's make a start.
So we've talked about the if keyword before to perform certain statements based on an expression that you type in brackets. I want to talk to you now about the switch statement. So let's get started on that. Create a new project. We're going to call it switch. So I'm going to select the standard defaults here. I'm going to call it switch as I mentioned. Okay, so let's make a bit of space, as we always do. So, the switch statement. So, again, talking about this, we've seen the if statement used before. We can start off with an integer, value equals 1. You've seen something like this, if value equals, double equals 1, 1, else if value equals 2, else was not 1 or 2. So you've seen a simple example there, and if we run that, in this case we should get the value 1, and we can change that to a 2 and run it again. The value on the 2, you get the value of 2, so you can see there, and of course if we specify 3 we should get neither, well sorry, was not 1 or 2. So nothing unique about that. Now this can get a little bit messy if you've got 10 values to test, or like a large number of values that you want to test and perform different code for based on that value. There is an alternative, and that's using the switch statement. So let's do something equivalent, do the equivalent to what we've done above, but using a switch statement. So we're going to put int, we'll call it switch value, and we'll set that to 1 again. Now the switch statement is comprised of the switch keyword, so it's switch, then the value that we want to test, the actual variable name or expression, so we'll put switch value, and then we start a code block like so, and what we do then is we type the word case and what we want to test for. So in this case we want to test for the literal value 1, so I'm going to put 1 and put colon, so that's testing now for the value 1. So that's equivalent of doing if switch value equals 1. We then type in the code that we want to execute if the value is 1. So I can put
value was 1, like so. We then type in the break keyword, and what break does is it terminates the enclosing switch statement and control continues at the line after the switch block. So I type break, like so. Based on that, what's going to happen is when the code is executed for 1, it's going to print out system.out.println value was 1, break, which means it's then going to come down to here and start executing any other code that we had sort of after here from this point onwards. More code here. So in other words, it would break, it would come down to here and continue processing. Now we can use multiple cases. We can put another one. We can type case 2. Value was 2. And we'll type in break again. Under that circumstance, we also want to break to that, it will break out of the switch statement. And the final equivalent to the else statement, which is where we want to do a test for all other circumstances, we don't type else, we type another keyword, default. And default means any other case that's not been covered above, this is what I want you to do. So in that case, we would put was not 1 or 2. And then we do a final break as well. So that's the switch statement, and we can run that. And we can see here value was 1. And just to confirm it, we'll actually comment out this other code for now because we don't need that if code anymore. Just so we know that we're getting the values from the right place. Value was 1. Value was 2. We can do a test for. Value was 2. And of course, value was 3. That's good. So you can see that that's all working. So that's the switch statement. Now it's often a matter of style to choose the if statement or the switch statement because both can really achieve the same thing. You can see that we used if value equals 1. Effectively is equivalent to using a switch statement and putting case 1. The if statement is a little bit more flexible in that each time we do a test here, we don't have to use the same test criteria. So we could put if value equals 1, else if, cat equals 4. In other words, a different variable altogether. In the case of the switch statement, we're testing only the switch value here, and we're testing different values for that same value. So we can't actually then introduce a different variable type to test for argument's sake. We're just testing this one variable here in the switch statement. So switch is good to use if you're actually testing the same variable and you want to test different values for that variable. Now you can see that there would be situations where if you had 20 values to test for, this could get a little bit tedious. So there is actually a bit of a shortcut. What we can do is we can type case 3, case 4, case 5. And then we could put something like was a 3 or a 4 or a 5. Break. So we've assigned 3 to the value of switch value. Previously that was not 1 or 2, but now that shouldn't hit this default because we've added a case here for the number 3, so it should actually execute in there. So if we run that, was a 3 or a 4 or a 5. And of course, if you wanted to know what the value was, if you wanted to do some calculation in here, we could put something like, actually it was a switch value, because of course we know what the switch value is. So we could run that. So we could still actually process that. So you could have a case here for case 3, 4, 5, 6, 7, 8, 9, or 10. We could still do some calculation based on the actual value of switch value. The important thing is here, we're grouping multiple case tests together in the one line effectively, which makes it a lot easier. Now, one of the important things to note here is the use of the break keyword. If you don't have this break, to create a break statement, in other words, you'll get unpredictable results. And just to show you what will happen is I'm going to remove, or I'm going to comment out this break here. And if I run this, bearing in mind what happened before, we saw 2 lines of output. If we run this now, can you see what's happened there? So it was a 3 or a 4 or a 5. Actually, it was a 3, was not 1 or 2. So why has that happened? Well, the reason it's happened is we've taken out this break statement. So what's happened is processing got to here based on the fact that the switch value was set to 3 in this case. So it executed those 2 lines and printed those both out. But then there wasn't a break statement, so it continued on to this line here and then eventually did a break to get out of the code. Consequently, you can see that breaks are vital to close off your case comparison, your case test, if you will. If you don't do that, the output will fall through to the next case and continue on until it finds another break, if any, or until it finishes off the switch statement. So this is a common error that you'll find in code, that forgetting to put a break, you might have everything else correct and you'll find you'll get really weird, unpredictable results, because you might be assuming in this case it's only going to execute this code, but it's moved down and executed that other code. And in a worst case scenario, see that we'll get rid of it, we'll comment out that break and that one, and we'll set the switch value to 1, run that. You can see we've got all these values, so it's process 1, process 2, process case 3, 4 and 5, and the default. So it's processed everything because there were no breaks. So make sure that you do introduce to add those breaks, it's very important. So I'll just add those back. And we'll run it again to confirm it's working again. Oops, and I undid that, so I should make that a 1 again. Value was 1, so you can see that it's now working with the break statement. Technically speaking, this last break, because it's at the end, it's the last thing that we're testing for, we could take that out. And to be precise, we can put here was not 1, 2, 3 or 5, since we're testing for those above. Now, that will work. Oops, 3, 4 or 5. That will now work because it's the last line of the switch statement anyway, and then it will break out. So technically you don't need that one there, but it's always good to be precise in your code, so I recommend you leave that in that circumstance, because it's just very clear that what you're trying to achieve, and possibly a programmer who's perhaps new or doesn't know a lot about your system might look at that and go, I wonder why I didn't add a break there. So it's just introducing a question you don't need to be introduced. So I would suggest you always add breaks anyway. So with older versions of Java, we were able to use, here for this switch value, we're able to use the primitive types byte, short, char, and as you can see, I've used int here as well. Okay, so that's the switch statement. And what I'm going to do now is just set you a challenge. We'll go through that challenge, and I'm just going to finish off and just show you another little scenario with the switch. I just mentioned that the switch statement can be used with 4 primitive types: byte, short, char, and int. So let's do a challenge based on that. And here's the challenge. Okay, so your test is to create a new switch statement using char primitive type instead of an int. So you need to create a new char variable and set it to some value. Then you need to create the switch statement, but this time you'll be testing for the values A, B, C, D, or E in the cases. Display a message if any of these are found, and then break, and add a default also at the end, which displays a message saying, A, B, C, D, or E was not typed. All right, go ahead and do that, and pause the video now, and when you're finished, come back and you can check out my solution. Okay, how did you get on? Did you figure it out? Well, it's actually, the code is very similar to what we've got above, but we're just really changing data types. So it's really just a case of putting char, and we'll call it my char value. And let's set it to an initial value of A. So the switch statement, I mentioned that's compatible with char, so we can type char value. So that's exactly the same, but it's just specifying the char value instead of the switch value we used above, which was an int. Then the case will be case single quote A, because that's how we define a char, with single quotes, colon, and out A was found, add a break, and then we can do the same. We can put B, for example, and if we wanted to, we can also then put case C, D, E in single quotes. And we could put and we're just going to put whatever it actually was found and print it. We're going to break. And whoops, I need to use the case keyword again, which I forgot to add there. Case, like so. And we'll put a break there. Then our default will be something like could not find A, B, C, D, or E, and break. All right, so let's give that a go. We've got the value A that we've defined, so we should get a message saying A was found. A was found, so we can change the value to B. B was found, and let's just try D, knowing that that's part of the C, D, and E test. D was found, and we can put something like a G there. Could not find A, B, C, D, or E. So that's how to use char, the primitive type char, in a switch statement. Now lastly, before we finished, in JDK version 7, Java version 7, they added the capability of using a switch statement with strings. And that's why at the start of the video I wanted you to check to make sure that you'd selected the right type there, because if you haven't, you'll get an error at this point. So do refer back to the start of the video if you get an error at this point trying to get this switch statement to work. So we can also do something like switch month equals January. We can do switch month like so, and we can do a case break, and we'll just do one more. We won't go through all 12 months. We'll just say June, my birthday month. June abbreviated. Okay, then we'll just do a break. Default is not, we'll just put not sure. Okay, so if we run that, January report or being returned there, and we can do a search for June, or enter June I should say. We get June, and if we put something else, some random characters, not sure. Okay, so that's working, but there's a bit of a problem here. What happens if we type January? And you notice I've typed that all in lowercase. If we run that, not sure. This is because technically the string January in lowercase with a lowercase j as the first letter is different to the string January with an uppercase j. And we saw this a little bit earlier on with primitive types when we're looking at ints and doubles and so forth, how there are differences. So you need to be precise here. Computers are precise, so you really need to make sure you test this correctly. So how do we get around this problem of making sure, because obviously we wouldn't want to do a case statement to put something like, case January, case January, case, January and so on. We don't want to be doing that to test for every possible scenario, every possible combination of upper and lower case letters that would type. That would be like a crazy amount of work and would really blow out the code and wouldn't be a good solution. So the way we get around that is we use the method that's included with the string called toLower. So what we do is we change our test, we put to lowercase. So I'm typing .to lowercase. You can see there's a to lowercase. If I enter that there, that's actually a method that is part of the string class. Now I know I've talked a few times about class and said that it is coming, and it is certainly coming, but we really need to go through some of these basic points first before we start looking at classes, which is some of the more advanced features of Java. So for now, just think that to lowercase is a method that is part of Java attached to the string class, which enables us to perform some functionality. So what that to lowercase does, it just converts the entire string to lowercase. So if we enter something like January, so if we enter that and actually run this, and then we make sure that our tests, we're actually testing for the lowercase version now. And the reason we want to test for the lowercase is in this line here, we've converted it to a lowercase. So we actually said, from this point on, I want the switch statement to be whatever was typed into month, but all in lowercase. So therefore the cases are only going to work if everything's entered in lowercase. So first we'll confirm it works, and I'll just show you what would happen if we didn't do that. So you can see that January is now working, and I can put something like, really any combination of letters, it's going to convert everything to lowercase. So you can see that that's working. But if we didn't put a lowercase test here, if we run it, we'll find that that doesn't work. And that's because this has got an uppercase letter, but this test is all in lowercase. We've converted that all to lowercase. So obviously you need to make sure that you're actually testing the lowercase. So that's a method that's part of the string class as I mentioned, and we'll be talking more about that later. And it's got lots of actually different methods of string class. It's really very, very versatile. We could put two uppercase, in which case we'd have to do a test all in uppercase. So run that. You can see that it's working. So that's the switch statement. I suspect you'll use that reasonably often in your code. It's something that you'll see in a lot of Java code. It's very common to use, very versatile. So that's it for this video. In the next video, we're going to talk about the for statement and figure out how to provide looping capabilities for our Java code. All right, it's time now for a challenge. This one's called the Day of the Week Challenge. All right, so your challenge is to write a method with the name print day of the week that's got one parameter of type int. So name that parameter day. Now the method shouldn't return any value, and a hint there is the word void. Using a switch statement, print Sunday, Monday, then through to Tuesday, Wednesday, Thursday, Friday, Saturday, if the int parameter day has the value of 0, 1, 2, 3, 4, 5, or 6 respectively. So depending on the value that is passed, you'll print a different day. And if none of those are true, in other words, you've got a value outside of that range, you'd print invalid day instead. So using that, you do that using a switch statement, but it's a bonus, write a second other solution that instead of using a switch uses if then else. And call your project when you create it in IntelliJ Day of the Week Challenge. And just to note also that the challenge text is available in the resources section. If you're the type of person who likes having the challenge text to refer to while you're going through the challenge, download that from the resources section. All right, so now it's time to pause the video and attempt the challenge. When you're finished, come back and then you can check your solution with mine. So pause the video now. All right, so how did you get on? Hopefully you managed to figure out a solution to that challenge. Let's hop back into IntelliJ and go through it now, step by step. So you can see here that I've already created a project called Day of the Week Challenge, and I've already created the main method as well. So the first thing we're going to do is break this problem up into smaller parts. Now, if you recall, the first requirement was to write a method that has one int parameter with the name day, and it doesn't return anything. It's actually the first sentence in the challenge. So to do that, we're going to go into our code, our public class, outside of the main method, and before the closing right curly brace, and we're going to type private static void, and we're going to type print day of the week. I'm capitalizing each letter other than the first word print, parentheses, and an int day. So enter the type and then the name of the parameter, and open a left and right, or add a left curly brace, and the right one's added automatically by IntelliJ. So that's the method definition. And again, I'm using the word private there, but public and private will be explained later in the course. For now, if you've used private or public, or in fact haven't used either, that's acceptable, and the challenge will still work at this point in time. So that's our method definition so far on line 9. Now the next step is to write a switch statement using that parameter day. So let's write an empty switch statement. So to do that, we're just going to type switch, then parentheses, and the word day, which is our parameter, in parentheses, and then we're going to add a left curly brace, and the right one's added automatically by IntelliJ. So that's what we call an empty switch statement. Empty because it hasn't got any code within the left and right curly braces within the code block. So now that we've done that, the next step is to write our case statements. We're going to check each day. We're going to check the value, and depending on the value, print out an appropriate day. And if you recall, the requirement was to print Sunday, Monday through Saturday, depending on the value of the day parameter. So 0 was Sunday, 1 means Monday, and so on. And the last one was 6, and that's for Saturday. So let's add our first case statement. So within the switch statement in the code block, we're going to type firstly case space 0 colon. So that's our first case for 0. Then we're going to type S out and press tab. So we've got system out.println added, and case 0 was Sunday. And then after that, we're going to type break, semicolon. So we've now handled case 0, which is Sunday. So if the value is 0, we're going to print out Sunday. So then we want to just go through and add the other case statements for the other days of the week. So let's go ahead and do that. It doesn't matter where you are on the line if you type a case, when in IntelliJ you type it there and press the colon, and notice how IntelliJ moves it over to the left for you. Then we're going to print Monday, because it's case 1. Importantly, making sure we add the break. Case 2 colon, it's going to be Tuesday. Break again. Case 3 for Wednesday. Then again, print out for Wednesday using S out. Another break. Case 4, S out, and it's going to be Thursday, so we're getting there. A break, 2 more here. Case 5, print out Friday, and our break. And case 6, Saturday, break. Alright, so that's our 7 days of the week now identified, case 0 through 6, and we've got a different day printing out now for each one. Alright, so at this point now, we've done that. The next step is to decide how we're going to handle the fact, or how we're going to handle a value outside of the values of 0 through 6. In any other scenario, we're meant to print out the text invalid day. So how do we do that? Well, the easiest way to switch statement is just to use the default. So we can just type default, and that means basically any other values we're going to print out invalid day. So really that's just saying, I'm just going to move that over. We needed this out there. I'm just going to move that over. Selecting it and then holding down Shift and pressing Tab to go back so it's in line. Now we don't really need a break there because it's the last line anyway, but it won't hurt if we do add one. So to be consistent, we can actually add one there. So that's it for the method now. So that should work, but obviously we can't just assume it is, we have to test it out. So what I'm going to do is call the method, and we're going to try it with some different parameters to make sure it does work. And we're going to call those parameters from within the main method. So I'm going to start by typing print day of the week. We'll start with -1 first. So -1 is outside of the range 0 through 6, so that should return invalid day. So let's right click and run that. And we've got invalid day showing, and I'll just move this down to the bottom. It's a little bit easy to read. Invalid day showing. So that's working good so far. So let's try each day. And the best way to try each day would be to copy and paste 1, and then I'm going to change the value to 0. 0 is going to be Sunday. Then I'm going to copy and paste. I'm going to change the argument for each. 1, 2, 3, 4, 5, 6. So I've now tested, hopefully, Sunday through Saturday, and of course the first line was the one that tested a number that's outside that range. So let's actually run that. And we can see with the output there, we've got invalid day, then Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So that appears to be working nicely, and that's great. Then one other test would be to have a number that is larger than 6, because we've tested a number that's less than 0. Let's just paste in one more. I'm going to put in the value 7. So 7 should also give us invalid day. We'll run that. And we've got invalid day down the bottom, invalid day at the top. So that's looking good. Looks like we've solved the challenge. All right, so what we're going to do now is we're going to attempt the bonus part of the challenge. If you recall, the bonus was to create a solution that instead of using the switch statement, used if then else instead. So what I'm going to do is comment out this switch component of our print day of the week method. I'm just going to comment that out, right down to including the right curly brace that's lining up with the switch there. We don't want to comment out this last one down here because that's part of the method. So I'm going to comment it out. All commented out now. And what I'm going to do is start writing at the top instead. I'll leave that code commented out so you can refer to that if you happen to download the source code. So if then else, it is very similar, making sure that we're within our first left curly brace after the method name. We're going to start typing if parentheses day is equal to 0. So we're testing that in parentheses. And if that's the case, we'll open a code block and then we'll just print out Sunday. So that's a test there obviously for Sunday. And for the rest of the days, we can just use an else statement. So we can put an else if, in parentheses, day is equal to 1. Remember to use 2 equal signs there. Then we're going to print out the value for Monday. And what we can literally do there then is put these three lines here, and we'll put this, paste it in. Okay, so then what we'll do is we'll change the values. So we've got 0, 1, 2, 3, 4, 5, 6. Then we want to change the values. So 2 is going to be Tuesday, 3 is Wednesday, 4 is Thursday, 5 is Friday, and lastly 6 is Saturday. Then how do we handle any other value? Well, that's quite simple. We can just use an else. So else is basically a catch-all for everything else that hasn't been tested already. We can just print out, yes out again, invalid day. Okay, so now that we've entered that, we know already from calling the print day of the week method, when we had a switch in there, that we had all the values needed to test everything. So we can run that again and have a look at our output. We've got invalid day, and Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and invalid day. So that's an alternate or bonus version of our challenge, which uses if then else instead of using the switch statement. So basically the code's doing the same. We're getting the exact same output as we did using the if else that we did when using the switch statement. So as you can see, that's proof, if you will, that for every challenge there are many ways to solve them, and you've seen a couple of ways of solving the exact same solution here now. So that's it. I hope you enjoyed that and got a lot out of this challenge. Let's move on now to the next video. So in the previous video, we talked about using the switch statement. And in this video, we're going to move on now and talk about the for statement. And the for statement is used to loop some code. So it's, in other words, it's going to allow us to execute code a certain number of times. Now, we haven't really looked at that before. And looping code, in other words, executing code more than once, a number of times, is something that is very commonly needed in programming. And I'm going to show you an example of why we would want to do that. So I'm going to start off by creating a new method. I'm going to call it public static double calculate interest. And the two parameters are going to be double amount and double interest rate. So this is going to calculate the interest based on the amount of money that's passed as a parameter. Now, one way to do this is going to be just to do something along these lines. We're going to do return amount, whatever the amount is, multiplied by the interest rate, divided by 100. And what we'll do is we'll put another bracket in there just to make sure from an operator precedence point of view that we're processing it correctly. We're actually figuring out the amount and then multiplying it by the interest rate divided by 100, and things are being calculated in the right order. Now what we'll do is just to confirm that this is working, we're going to just create a sample bit of code and we're just going to call it. So we're going to put 10,000 at 2% interest equals, and we're going to call that method. So calculate interest, and we're going to pass 10,000.0 and 2.0, which is $10,000 for our test amount, and 2.0 is 2%. So let's just run this and make sure that it does work. And you can see we're getting 200.0 there. Then that 200.0 means it's $200 would be the 2% interest. Now, this doesn't take into account anything like compound interest or the amount of time to pay off the loan or anything like that. It's just a very simple contrived example of calculating some interest on an amount of money. Now, this is one way to do it, but let's just say we wanted to calculate 3% and then 4% and then 5%. Perhaps you're doing a comparison with different places and you want to calculate a number of them. So you could see that we could do it one way. We could copy this, we could paste this like so, and we could change the printout to say 3%, 4%, 5%, and we could change the parameter to be 3%, 4%, 5%. So we've now got, if we run this, 2%, 3%, 4%, and 5% calculated, which is $200, $300, $400, and $500 respectively. But you could probably see straight away that that would get really tedious. Now, if you had to do that every time you wanted to calculate a different interest rate, it would be, as I said, very tedious. And what about if we had 20 interest rates or 100 interest rate calculations we wanted to do? You can see there'd be lots of code, and it's very inflexible because you're continually having to go back and change things, and it's just going to be mountains of code. Well, the good thing here is that computers are made for automation. So this is there's a good solution to getting around this problem, and that's using a for statement to automate this process and ultimately to make it a lot easier. Now, the for statement is often referred to as the for loop. And the idea is that it repeatedly loops something until a condition is satisfied. When I say repeatedly loops, it's processing a certain amount of code, a code block in other words, a given number of times or until a particular condition is satisfied. So the basic structure is something along these lines. We type in for, and I'm just going to put these three things in and then we'll discuss them. That's the basic format of a for statement. So we've got the for, we've got brackets, and we've got init. Init means the code that is going to be initialized once at the start of the loop. Termination is telling us, or what we do is we tell the for loop how we want to exit. So at what point do we exit? And that has to evaluate to false. And once it evaluates to false, whatever that condition is we're going to put in there, the loop will then exit, and it will come down here and start processing on the next line. An increment, that's an expression that's invoked after each iteration of the loop, so each time the loop goes round. So a common thing to put in there would be a number that is incremented each time. So it's sort of like a count. So what we're going to do is just write a very simple example, and then ultimately later in this video we're going to call this calculate interest method. So this is how you would start. You type something like for, so we need an initialization. So a common thing to do there would be to initialize a variable. So let's put int I equals 0. So you've seen that before, a data type and then the variable. We probably haven't seen it in a loop like this, but what we're doing is we're initializing a special variable just for this loop. Once the loop is exited and finished with, this variable won't exist anymore. So it's really just for the for loop. Now the termination, so basically that has to be false before the loop will finish. So what we'll do there is a good way of doing it would be to put I less than 5. So you can see by putting I less than 5, the first time we run it, I is 0. So I is less than 5. Well, that's going to be true at the moment. So, and the loop is going to continue working until it's false. So in this case, it's going to be true for the first time. So it is going to work, and it's going to, whatever the code we're going to put in here is going to be actually executed. An increment, well, what we want to do there at the end of each loop, we want to increase the value of I, and we can do I++ to do that. So you can see now that we've got, we're setting our initial variable I to 0. Our test is to confirm that I is less than 5. So in other words, it's going to keep processing until I is 5 or greater. And I++, each time we go through the loop, we're adding 1 to the value of I. So just to confirm that, let's actually put something out. We'll print something out in here. So we'll put loop plus I plus, let's just put something like hello. So now we've created a loop, and the loop consists of a code block that's only got one statement, which is an output that's going to print the value of I and print a message, and it hopefully should go through each time through the loop and print out a message each time it goes through. So let's run that. So you can see what's happened here, loop 0, hello, loop 1, 2, 3, and 4. So you can see what's happened. We started on I equals 0, and we've moved on until we've got to 4. And then what's happened was the next one's come through, and I was the value of 5. Our condition to check was I less than 5, and that then turned false because I was 5, and then the loop exited, and then we come down to here, and of course there wasn't any other code, so the Java application finished. So you can see that the computer has executed the code 5 times, starting at 0. Now, 0 is just a value there. We don't have to run it. We don't have to start at 0. We could change it to anything. So we could change it, for example, to 1. And if we run that, you can see we've got 1, 2, 3, 4 this time because we started from 1, but this time there's only 4 loops because the first time was looped value was 1, second time it was 2, third time it was 3, fourth time it was 4, and of course the fifth time I was in fact 5, and it's not I is not less than 5 at that point, so the loop exited. And of course if we wanted to run it 5 times, we could change that to say 6. 1, 2, 3, 4, 5 again. We've got it to run again 5 times. But it is fairly typical in these scenarios with for loops to start with 0 because a lot of Java things, different parts of Java which you'll be finding later in the course. For example, arrays start at 0. So it's a good habit to get into with your coding to start things at 0, because you'll see that a lot in the course later on, that many computer languages, including Java, they start their counts at 0 and not at 1. Okay, so I've got a mini challenge for you at this point. I'm going to paste this in here. So using the for statement we've just learnt about above, I want you to call the calculate interest method with the amount of 10,000 with an interest rate of 2, 3, 4, 5, 6, 7 and 8% and print the result to the console window. So you should be able to figure that out based on lines 6 through 9 and how to call the calculate interest method, and also the loop that we've just learnt about. So type that code below this and pause the video now and come back once you've got a solution, and then I'll actually type in the code that I've come up with and you can compare your results to mine. So pause the video now. Okay, so how did you go? Hopefully you figured it out, and what I'm going to do now is show you how to do it. So what we need to do first is obviously a for loop. So we went to looking at what we want to calculate, 2, 3, 4, 5, 6, 7 and 8. So obviously then we want to create a for loop for, and we can start I equals 2 because that's our first one we want to start with. So when you're doing a for loop, you start with the first element number you want to start with. In this case it's 2. And then we can put I, and we want to go up until 8. So therefore our test should be 1 more than 8 because we want to process 8. I less than 9 would be our test. So once it hits 9 or it's greater than 9, it's going to exit the loop, and I'll set that up to int again. And we'll just use an I++. And incidentally, you notice how we can reuse the variable again. And that's what I mentioned earlier, that the variable that you create here in this for loop only exists for this code block, for the code block that's in the for loop. As soon as you exit that variable doesn't exist anymore, and you can reuse it. And it is also very common, just to let you know, in for loops and while loops, which you'll learn in the next video, to use variables like I and J and K and so forth, because they're just there as basically indexes to loop through a number of times. So if you see I, J and K and you're wondering, well, Tim, why aren't you creating better variable names? It is very common to use those in loops such as this. Okay, so next thing we need to do is we just need to print out a message. So what we can do is just take a copy of this line. I'm going to paste that in there. And what I'm going to do is change the 2.0 to I. Now you'll notice that if you're looking at this, you probably notice, well, this is an integer, but this is a double the interest rate. So that's correct. But what Java is doing, Java is smart enough to know that, okay, I can convert a whole number, an integer, to a double. So it's doing that for us automatically. Now what you could do if you wanted to be correct, you could cast it as a double there, but it isn't necessary to do that. It works quite nicely without it. And of course, the other thing would be if you in fact wanted to calculate interest rates with percentages, then you probably wouldn't be using an integer there, you'd be using a double, and you'd actually have a different way of incrementing. Like for example, you could increment by 0.5% or something along those lines. But in this case, we're keeping it pretty simple. We're using integers and we're going through the looping like that. So let's now run this code. And you can see there we've actually got our solution working. We've got 2, 3, 4, 5, 6, 7, 8. So in other words, 2 through 8 were actually calculated correctly. And what I didn't do was update the printout for that. So let me do that. We'll put plus I plus like so. Let's run that again. And there we go, 2, 3, 4, 5, 6, 7, 8, which is what we needed to do in the challenge. We needed to actually calculate the interest rate on 10,000 on all of those, which we've done. So that's the result of the challenge. And one thing you probably noticed here is that this has got a lot of decimal points. Well, sometimes in terms of the precision of a double, it will calculate things like this, and it's not something you need to worry about. We'll be talking about precision later in the course, but it can be nice to actually get rid of that so it actually outputs in a nice way. So one thing you can do there to fix it up if you do want to do that is we could actually come in here and we could type string.format %.2f, comma, and then I'll just add another bracket on the end. Now, this is not something you need to do, but what's happening here is we're passing the value that we got returned ultimately from our calculate interest method to the string.format command, and what that does, the %.2f in this case means output the number or convert the number and output it with just 2 decimal points. And that would then guarantee that we don't get all those zeros, and it means instead of seeing 200.0, 300.0, we should be getting 2 zeros. So let's just try running that. You can see we've now got it correctly formatted 2, 3, 4, 5, 6, 7, and 8. And you can see the examples at the top there only had the 1 decimal point. So that's one way to look at doing it as well. But it's not something you need to worry too much about, but I just thought I'd put it in there now in case you're wondering how to go about doing that. Okay, so next mini challenge. So how would you modify the for loop above to do the same thing as shown, but to start from 8% and to work back to 2%. So in other words, the first time it runs through the loop, it should be 8. The second time it should be 7. Third time it should be 6. So what I suggest you do is copy and paste the code above down here, and then try your results. So that way you keep the original code up at the top there. So pause the video now and see if you can figure that out, and come back and I'll show you how to do it. Okay, so hopefully you managed to figure it out. So what we'll do is we'll copy it, as I mentioned. Now instead of putting for I equals 2, well, we want to start at 8%. So clearly, just we talked about before, what we start on is always going to be the variable value initially. So it's going to put 8. Now we can't put I less than 9, can we? Because obviously in the first case, I equals 8, it's going to work, but it's going to be sort of literally going the wrong way. So what we really want to do here is change this around how it's going to end. So where it should end effectively should be its I is greater than or equal to 2. In other words, it's going to keep processing while up until I is greater than or equal to 2. And then the last one, well, we want to go backwards this time, so we want to do I minus minus. So you can see I equals 8, I greater than or equal to 2, I minus minus, that should go back in the backwards direction. So let's try running that. And what we might just do is just put a message here just to separate it, just so we don't get confused with the output from the previous for loop. We run that. And you can see now we started at 8%, 7, 6, 5, 4, 3, 2. So it's gone backwards. So again, you can have a loop to go either forward or backwards. It just depends on the conditions that you're typing in there. And you just need to make sure you get your ranges correct. And if you do get those numbers wrong, and I probably haven't got too much time to go into that in this video, you'll find that often the for loop may lock up. It may not, and it will continue looping, it won't exit, or you might find it doesn't execute at all. So make sure, if in those situations, just check your initialization variables, but also this condition here as to when it will exit. That's really the key in many ways to the entire loop, is what your condition is, what needs to be false to be able to allow the loop to exit. Okay, so what I'm going to do now is finish off with a challenge for you, one other final challenge. And in order to do that, what I need to do is give you a bit of code. So I'm going to give you a code, some code to generate a prime number. Then I'm going to go through that quickly, because it's not really important to know about that, but you need to do some coding. You need to come up with some code that calls this on a particular amount of time. So I'm going to paste that code in and just talk about it briefly. So this is a function that's going to determine whether a passed integer is a prime number. And I'm not sure whether you know or not, but a prime number can be divided evenly only by 1 or by itself. And the other thing is it has to be a whole number greater than 1. So this particular function, what it does, firstly it tests to see whether it's 1. And if it is the number 1, it's just going to return false, because a prime number can only be divided evenly only by 1 or itself. And it has to also be a whole number greater than 1. So if it is 1, we're returning false. We don't need to do any other processing. And in terms of the for loop, I wanted to also show you how this for loop is a little bit different. So we've got for int I equals 2, we're starting on 2 because I remember I said that a prime number has to be greater than 1. And then we did that test on line 35. Okay, so you can see there that we've got our loop there. We're just using n divided by 2 as a shortcut, because what we're attempting to do is find numbers that divide into n. So this for loop is only going to go through and really calculate what it needs to do. So no number that is greater than n divided by 2 is going to divide into n. That's really the point here, that by dividing it by 2, we're just really optimizing this to make sure that we're not actually processing numbers we don't need to process when we're checking. And this code on line 40 is then checking whether n, the remainder between n and I, dividing I into n, if that's 0, it means there's no remainder. So what that essentially means at this point is we've found another number that divides evenly into the number that was passed, and therefore this can't be a prime number. So we need to go through the whole loop once we've been through the whole loop, we can return true because at that point we've determined it is a prime number. So that's all the n divided by 2 is there. It's just really an optimization technique just to save a bit of time for the computer. And again, we're just checking for the remainder. And if we find that there's another number that evenly divides into the number that's passed, it means this can't be a prime number. So that's what that method does. So what I'm going to do is just give you a final challenge to do now. So I'm going to come up here now that we've written that. So you'll need that method obviously, and we'll paste the challenge in. And your challenge is to create a for statement using any range of numbers, doesn't matter what they are. Determine if the number is a prime number using the isPrime method that I've given you down below. Now if it is a prime number, print it out and increment a count of the number of prime numbers found. Now if you get to the stage where 3 or more are found, in other words, you've actually gone through the loop and you've found 3 prime numbers, I want you to exit the for loop. And as a hint, use the break statement to exit the loop. So you need to use an if statement to check, count, and then use break, and that will break out of the for loop for you automatically. So that's it. See if you can figure out that challenge. Pause the video now and do that. And once you're ready to see my version of the code, come back and we'll type it in. Pause the video now. Okay, so hopefully you managed to get it to work. So let's go through now. I know this video is getting long again. See if we can finish this off. So we're going to start off. I mentioned that we need to have a count. Determining we're going to exit if the count is 3. So we need int count. We're going to call it count equals 0. That's going to be our count, so the number of prime numbers that are found. So we now need to create a loop and go through and call this isPrime method a number of times. So I'm going to put for int I equals 10. And what I'm going to do is I'm going to go between I and 10 and 50. You can go through any range, it doesn't really matter, but I'm going to use 10, start on 10 and keep processing till we get to 50 basically. Once we hit 50, we're going to exit, and that's if we haven't found 3 prime numbers by then. So what we're going to do now in our loop, the first thing we're going to put is if isPrime I. So if we have found a prime number, it's returned true, which you talked about the isPrime method. So if we've found a prime number, what we want to do is do a count plus plus. Then we're going to put number plus I plus isPrime number. At the point we've established that I is a prime number. And then we're going to put a test in here. Remember I said to use the break statement. So we're going to put if count is equal to 3. And I'm going to type in exiting for loop. And I'm going to type in break. And that should be it. So we're going through the range of 10 through 49, basically, because once it hits 50, it'll exit. We're checking to see whether the prime number for the value I is a prime number. If it is, we're going to increment the count, and we're going to print out a message saying that that number is a prime number. And if we've got 3, if and only if we've got to 3, then we're going to exit. Otherwise, it's just going to continue. So we shouldn't see any other output unless we've found prime numbers. And the best way to do this now is to actually run it. So let's just run it and see whether it works. So number 11 is a prime number, 13, 17 is a prime number. You can see we're exiting the for loop. So we successfully finished after 3. So that seems to be working. So let's just go and make sure that they are prime numbers. So I'm just going to open a browser and a list of prime numbers. And there's some there. The first 1,000 primes, that will be all we need. So let's just open that page up, that link up. You can see the link is up the top there. Or actually, you'll see it once I get to it, the page. Seems to be taking a while to load for some reason. There we go. 2, 3, 5, 7, 11, 13, 17, 19. And I think if we go back and look at our code, 11, 13, and 17 is correct. So let's just change this just out of interest a little bit. Let's put the count to 10 instead of 3. And hopefully it will show us 10 prime numbers. And 11, 13, 17, 19, 23, 29, 31, 37, 41, and 43. They look good. They seem to be the right prime numbers there. So it seems to be working, which is good. So that's our challenge done. So the big thing there again was once we got to the count, whatever the count was that we decided we wanted to exit, we printed out the message and then we did a break. And the break actually exits out of the for loop completely, and processing will then continue on line 41 if there was any code there. But in this case, it was the end of the program. So that's what the break statement does. And that's it. So I'm going to finish the video here now. Just one really quick thing. There is a way also to optimize this, because we talked about optimizing I less than equal to n divided by 2. There is another, without going into too much detail, we could have actually changed that. So we could have actually used a square root, and the advantage of doing that would be that there's less processing still, and it would be slightly faster. So without spending too much time explaining why, because the video is already too long, we could have done something like this: long math.sqrt square root n. We're using long because the output that comes back from maths.square root can be large, so we can casting it as a long depending on the number. Now we wouldn't need to do that for the small numbers we're using here, but that would be a little bit more optimized. So if I run that, we should get the same results. Firstly, we still got the same results, but that would actually be better because you'll find that the number of things we need to check would be less. So be less times through the loop, so to speak. So you could test that if you wanted to. You could actually put some code in here to print out each time you're going through the loop, and to test your results as to how many times. Actually, we'll just do that really quickly now. Let's just do that. We'll do let's just do that. So let's just, for the last one, for the number 41, 1, 2, 3, 4, 5, 6, that's 6 loops. Remembering that for the number 41. So if we change that back to n divided by 2 again. Now look at number 41 this time. Look at how many times it's actually had to loop through, significantly more times to calculate that number. So that would be the reason that you'd use that square root function for optimization purposes. But again, you'll find out more about using those sorts of things later in the course. I just wanted to point out there is another way of doing that if you decided to. But that's it. So that's the for loop. I hope you've got a lot out of that. And just one last thing, there's also another variation of the for loop called the for each. But we're not discussing that here, and the reason for that is we really need to be talking about arrays and objects and the like before that makes sense. So you'll see the for each, which again is a variation of this for loop in future videos in the course. So that's it. I'm going to end this video now. In the next video, we're going to start talking about another type of loop that's available in Java, and that's the while and also the do while. So I'll see you in that video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
So let's recap what we've learned about the for statement. So here we have a for loop structure on screen. So we've got the initialization part where we initialize variables, or variable in this case, then the condition which determines when the loop ends. The last part is the increment, also known as the iterator or iterator step. So in other words, one execution of the loop step is known as one iteration. So in the increment part, we could increment by 1 or 5 or decrement by any number. It depends on the situation and specifically what you type in there. So we say that the loop iterates. In other words, it loops or executes a block of code when the condition is true in steps, and those steps are called iterations. And then the loop stops when the condition is false. The block of code is defined by curly braces. In the loop body, we can have multiple statements. Those statements will execute every step, or we can say that they'll execute every iteration. And notice there's semicolon after the init and the condition. Those semicolons are required. Alright, so in this scenario, in this case, we've got the for loop that just prints out the value of some number, of the number variable. The init part is int number equals 1, so we're starting at 1. Condition showing on the screen is number less than 7, and the increment is number plus equal 2. So in other words, we're incrementing the number variable by 2. So this for loop will print every second number. So as you can see, the output showing at the bottom of the screen is number equals 1, number equals 3, number equals 5. It just prints those three numbers, noting that it didn't print the number 7 because the condition was less than 7. But let's just go through step by step through the loop iterations so it's easy to understand. So on this screen, we've got different numbers showing what the different steps are. So I'm going to call those steps just to make it clear. So the first one, if the highlight the red circle with number 1, that's where we initialize the variable number to 1. Next, number 2 is we're checking the condition. And the condition we're checking for is if number is less than 7. Now if the condition is true, and in this case we've got number less than 7, our number is 1 because we've initialized that in step 1, so therefore that's true since 1 is less than 7. So the loop executes a block of code in this case, and the code we've got in there is the system.out.println, and it prints the number 1 to console, or prints number equals 1 to the console. So the current output is number equals 1, then it increments the number by 2. In other words, the iteration step executes. And that was step 4. And just to be clear, step 3 there on the screen was where it was actually executing the line in the code block to print out the number. So at the end of the 4th step, where we've added 2 to the number, our number was 1, we've added 2 to that, so it's now 3. So now the value of number is 3, and we start the next iteration by going back to step 2 to check for that condition. Alright, so here we are with the number now set to 3. This is the second iteration. And again, it's 3 because it was incremented in the previous step. So again, the condition's checked, and we're checking in step 1 there on the screen, and we've got now number less than 7, which is 3 less than 7, so that condition's also true. So it prints number equals 3 to the console. And again, in step 3 on the screen, we're executing the iteration, or we're adding 2 to 3, the current value of number, so number now becomes 5. So 3 plus 2 is obviously 5. So the number variable is set to 5, and then we actually go through the next iteration of the for loop. Okay, so here we are with the number now being 5. So we've had 2 iterations. And again, the condition's checked, and 5 is less than 7. That condition's true. So it prints number equals 5 to the console, and you can see the output at the bottom of the screen there. And obviously step 2 is executing that code to print the output. And again, in step 3 of the increment side of things, we're adding 2 to the number variable again. Currently it's 5, so 5 plus 2 is 7. So the value of the number variable after the increment is now 7. Then we move on to the next iteration. Okay, so here we've got the 3 lines of output, number equals 1, number equals 3, number equals 5. So now the number is 7 since it was incremented in the previous step. So since it was incremented, it's now 7. So again, the condition is checked in step 1 on the screen, and we've got 7 less than 7. But now that condition is false. So the loop exits at this point, and the code in the code block is not executed. The code will continue after the closing curly brace, and you can see the arrow pointing to that in step 2. It jumps to that part of the code. And in this scenario, we don't have any other code after the last curly brace. Right, so that's one scenario. Here's another for loop. In this case, this for loop will never execute. Can you figure out why it won't execute? You can pause the video here and try to figure it out. So pause the video now and then come back when you're done, and I'll show you the reason why, and I'll also show you the output. So how did you go? Did you manage to figure out why this code will never execute? Well, this was a tricky one. There's really no output at all. So let's move on to the next slide and see why there isn't any output. So the loop will never execute. In other words, it will never print out anything. And that's because the condition is false. So firstly, in step 1, we're initializing the number variable to 1. The condition is then tested in step 2, and the condition is number less than 0. But since 1, which is the value of number, is not less than 0, the code block will never execute. So in other words, that's false, and the code jumps out and bypasses the code in the code block and jumps, as you can see, to the next line after the closing brace. So you really have to be careful with conditions in a for loop. As you can see, if the condition is wrong, it will never execute at all. So to fix this loop to execute the code block, we have to change the condition. For example, number less than 5. So in that case, it will then print out the numbers 1 and 3 before closing down and exiting. So here's another for loop. Can you guess what this will print? If you like, pause the video and try to figure out what will be printed from this. Pause the video now and come back when you're done, and I'll show you the output and explain what will happen. So how did you go? Did you manage to figure that out? Well, this was again a tricky one. So let's see what is happening with this one. So in this case, the loop will basically loop forever. So here we've got condition greater than 0, but we're also incrementing the number. So every number greater than 100 is always greater than 0. So in other words, this kind of loop is called an endless loop, but the program will actually stop once it gets to a maximum value of an integer. In many cases with endless loops, programs might block forever or crash when it runs out of memory. So how would we fix this to avoid the program effectively hanging and not actually exiting. Well, what we could do there is, for example, change the condition to number 130. So that way we print the 100, 110 and the 120 on the console, as you can see in the output on the screen. And that's because we've changed the condition, which was number greater than 0, to now number less than 130. Alright, so I hope you got a lot out of this video. And just one last thing, there's also another variation of the for loop called the for each, but we're not discussing that here. The reason for that is we really need to be talking about arrays and objects before going into for each. And that'll make sense later, and you'll see the for each, which again is a variation of the for loop in future videos in this course. So that's it. I'm going to end this video now, and I'll see you in the next one. Alright, it's time for another challenge. This is the sum 3 and 5 challenge. So the challenge is to create a for statement using a range of numbers from 1 to 1000 inclusive. You want to sum all the numbers when you're looping through that can be divided with both the numbers 3 and also with 5. Now for those numbers that meet the above conditions, in other words that are found to be divisible by both 3 and also divisible with 5, you want to print out that number. And also you want to break out of the loop once you find 5 numbers that meet those above conditions. And then also after breaking out of the loop, print the sum of the numbers, the total numbers that you found that have met those above conditions. And for this one, just type all your code into the main method. Now the text for this challenge is in the resources section of the video, so you can go ahead and download that if you need to. At this point, pause the video and see how you go with that challenge. Once you've finished, come back and you can check out my solution. So pause the video now. Alright, so how did you get on? Hopefully you managed to solve that challenge. Let's see if we can actually solve it now on screen. Alright, so what we're going to do first is we're going to start by declaring a count variable that represents the count of found numbers. So we need one for that because we know we need to break out of the loop once we find 5 numbers that meet the conditions. But we also need a variable for the sum because we're going to be recording the sum of those numbers. So let's create a variable for both, remembering that we're just using the main method for this one, for this exercise. So I'm going to start with int count for our count equals 0, initializing that to 0, and for our sum, we're going to call it sum. Its sum equals 0. And I'll just put a space there to make it a bit more readable. Alright, so next we need a loop. We're going to range, or loop rather, through a range of numbers between 1 and 1000 with a for loop. So for that we're going to put for, and in parentheses, int I equals 1, semicolon, and I, we need to use the range 1000, so it's going to be less than or equal to 1000, since we want to do both there, semicolon, I++. So there's our loop. We're going to open a code block with the left curly brace, the right one's added automatically. So now what we have to do is sum all numbers that are divisible by both 3 and divisible by 5. But then we also need to increment the count and print the number that we found. So firstly though, let's start by checking if the number is divisible by 3 and 5 at the same time. So we can do that by typing if. Now I'm going to type 2 left parentheses. Now I'm going to put I, we use the remainder operator. So remainder operator 3 is equal to 0 with 2 equal signs, closing parentheses, space, then the and, which is 2 ampersands, the left parentheses, I, remainder operator 5 equals 0. And 2 closing parentheses, right parentheses, and I'm going to open a code block. So I'm using extra parentheses there for each condition so it's easy to read and to make sure we don't have any issues with operator precedence. So the first condition that I've got here is checking if the number is divisible by 3. In other words, if the number divided by 3 doesn't have any remainder. Then we've got the AND operator, and then we've got the second part of the test is doing the same but for the number 5, checking to see if this number divisible by 5 has a remainder of 0, so it divides evenly. And remember that the AND operator here is only true when both of these conditions are true, so both 3 and 5 have to be true before we get to execute the code in our code block, which is going to be here. So if we have found that to be true, then we want to increase our count. So count ++, semicolon, and then we want to sum what we've found so far because ultimately we need to print that sum out. So I'm going to do sum plus equals I. So we're adding I to that. And then finally what we want to do is print out the number I. So I'm going to type sout tab, and we're going to put found number equals plus I. So we're going to print out the value of I as well. So again, we're using count there, so that when we get to 5 matches, we can do a break, and we're summing the value as we go through, so that we can print that out once we've actually exited the for loop. So the next thing to do then, after this if statement, is to do a test to see whether we've actually found 5 numbers. We can do that with if parentheses count is equal to 2 equal signs 5, open a code block, and then we're just going to type break. So if we found 5 matches, we're going to break out of the for loop entirely, and that would mean that the execution will come down to here outside of the for loop, the next line after the for loop. At this point now, the final step is to print out the sum. So outside of the for loop, after that last right curly brace, we're just going to print out the sum. We can do that with sum equals double quotes around that plus sum. So once the loop breaks or stops processing, the code will jump after the closing. Basically, the code will jump down to the outside of this right curly brace here, and the next line of code, which will be our line of code here, that's printing out the sum, and that should be that. So let's actually run this to make sure it works. I'm going to right click in here, select run, and I'm just going to move this down to the bottom so we can see it a bit better. We can see there we've got found number equals 15, 30, 45, 60, and 75, and sum equals 225. So that's it. That's all the numbers there, or I shouldn't say all the numbers, the first 5 numbers that can be divided by both 3 and divided by 5 without any remainder. And then the sum of those 5 numbers that are outputted is 225, which is correct. 75 plus 60 is 135, plus 45 is 180, plus 30 is 210, plus 15 is 225. So the sum equals 225 is correct. So that's the challenge. I'm going to end this video for now, and let's move on now to the next one. In the previous video, we talked about the for statement, which was a way to come up with a for loop to be able to process a statement or set of statements a given number of times. And in this video, we're going to look at the while and also the do while statements. The thing is, with looping, sometimes you might want to loop instead of a specific number of times, you might want to loop until a certain expression evaluates to false. For example, you may not know how many times you want to loop ahead of time. So what you need to do in those scenarios where you don't know how many times you want to loop, but you want to continue looping until that expression is true or until something happens, in other words, is you want to use the while statement. So let's go through the syntax of a while statement. So in this example, I'm going to create a simple variable called count, set that equal to 0. I'm going to type while, and in brackets count, not equal to 5. And then I'm going to type to print out what it is, the count value, count, and I'm going to do count plus plus, and there we have it. So if we run this code, so you can see it's counted 1, 2, 3, 4. And just to be clear, we can change the count to 1 if we want. So we're starting on 1 instead of 0. Run that again. So this is similar to the for statement that we've used previously. To do something equivalent, it's the for statement, of course, you would have done something along the lines of for int I equals 1, I less than 7, I plus plus, and then we would have done. So that would be equivalent statement in the for loop with the for loop. So you can see in the case of the while, there's no variable that's set up within the while loop like there is within the for loop. So we need to create our loop if we're going to do a counting mechanism before we start the while statement. Then we also need to increment our variable manually, if that's the way we want to do it, within the loop itself. So that's the difference between the two. Hello, this is Future Tim, editing this video and creating a new component due to a bug that I just showed you on the screen. Now what I've done is I've changed the color of this background just to make it really clear what I'm doing here. To the right hand side, you can see we've still got our count value, 1, 2, 3, 4, 5. That's for our while loop. And what I attempted to tell you was that the for loop, and I've actually duplicated that for loop on lines 13 through 15, was identical to the while loop. And that is not the case. So let me just show you what this for loop does if I uncomment it again. We run this code, bearing in mind that's the output we can see at the moment. you can see we get a number, 6 numbers or 5 numbers, 6, 6, 6, 6, 6. You can see it outputs not only 5 times but 6 times, but it prints the value 6 each time. Now the reason for that is I've introduced a new variable name here, I, but I'm printing out the value count. So to be more correct, if we wanted to do exactly the same as the while loop in a for loop, we would do something like this. So I'm going to comment out that wrong loop, the wrong code, and we would do for parentheses count equals 1, count not equal to 6, count plus plus. And then we would print out some output and we would say count value is plus count. So if we run that now, you can see we correctly now get 1, 2, 3, 4, 5 showing for the while loop. Then we also get 1, 2, 3, 4, 5 showing for the for loop. So that's the identical for loop to what I just showed you in the while loop. Alright, so let's go back now and continue the lesson after I've actually deleted out the for loop. I'll just delete the for loop now, we don't need that anymore. We can also write this in slightly different fashion as well. Instead of the above example of the while, we could have written it like while true if count equals 5, break. And otherwise, we're going to print the message and increment the count. Like so. And then just to make sure that this works, I'm going to set count back to 1 here. Because of course, after executing this loop, count will be set to 6. So if we run this example, and to be precise, I should have changed it to a 6, the same comparison as the other test. So I've written it in a slightly different fashion. With the previous example, we're checking to see whether it's not equal to 6. In this case, what we're doing is we're specifically saying if we get to the number, like in other words, we get to the stage where we want to break out of the code, in this case where the expression count equals 6, then we issue a break, which breaks out of the loop. But in both scenarios, you need to make sure that you do actually have the variable incremented. Because if you don't, what will happen is something along these lines. I'm going to comment that out just to show you what will happen. If we're not incrementing the count, we'll get into an endless loop. And then you can see what's happening there on the right-hand side. And IntelliJ is having a bit of a fit. The reason that it's coming up with that is we're getting to this loop here. While count is not equal to 6, it's printing out the count. Then we haven't reset the count, we haven't incremented the count, so it goes back and does another test to start doing the test again. So it's continually printing, checking whether the value is 6. So we're not incrementing the count. So make sure if you're using a while like this, the while statement, you are incrementing the count. So you'll see a code like this fairly often in Java code, while true. And what that actually means is it's going to be an infinite loop. So the loop will continue going, processing forever. But the way to get out of the loop is you do a test, some sort of test to check whether a given expression is true. In this case, we're waiting to count equals 6 and then we break out of the loop, much like you've seen before when we've used break elsewhere. So that's an alternative way to do things. Now there is another gotcha in this scenario. So what can actually happen here is that the code may not get executed at all. So to show you an example of that, we'll just comment this code out for now. So if we change count to 6 and then run this, the code never gets into the while loop at all. And that's because this initial expression was evaluated to false, so it never actually got into the code block to execute any of the code in there. So that's an important thing to remember with a while loop, and likewise with a for loop. If we did something like this, we'll run that, we won't get any output either. And that's because the initial value was set to 6 and we're doing a comparison test there to say I is not equal to 6. So of course the first time it does this evaluation, that's false because I in fact is equal to 6. So the code doesn't get executed within the code block itself, and likewise for the while statement as well. So that can be a gotcha sometimes. If you're wondering why your code isn't being executed, make sure you check the first expression and make sure going in for the very first time that expression doesn't evaluate to false, which means it won't execute any of the code.
Now there's also a third type of looping statement called the do while, and it's got the other advantage that it will always execute at least once, and if not more times, depending on the way you've defined your test expression. So what we'll do is we'll do an equivalent thing. We'll type do, which is the keyword we're using for the do while statement. Then we can type count value was plus count. Then we'll do count plus plus. Then our expression to test to see whether we should exit the do while or not is at the end. We type while after the closing brace, then we put our expression, which would be exactly the same expression, would be something like count not equal to 6. Then we put a semicolon to close it off. So if we change our count here to 1 again, and just to be sure, we'll comment these other ones out. And we'll run the code. Count 1, 2, 3, 4, 5. So you can see that it's operated very, very similar to the while that we've done in there. The only real difference was we had the word do at the top, then the while component appeared at the bottom of the statement there. But the other thing it'll do is if we set that to 6 initially and run it, you'll get a very weird error, as you can see there. So what's happening is the do while is guaranteed to execute at least once. So in this scenario, what's happened is we had the initial printout, so count would have been, the count value was 6. Then we then incremented the count, so it went to 7. But then the while expression at the end, count not equal to 6, that is going to be true from now on. And the reason was count was equal to 7 there. So therefore we got into virtually an infinite loop where it continually went through incrementing the number and running the loop. As you can see there, 990,000 times until I stopped it. So that's another thing to keep in mind with the do while. It's always going to be executed at least once. So of course, if we set that back to 1, that'll work quite nicely and that'll show 1 to 5. 1, 2, 3, 4, 5, as you can see, because we initialized and set it once. And the do while can also use a break statement. For argument's sake, we could set it up so that we could put if count greater than 100 break. So that's going to break out of the loop again. So we could test that, and you should find that it'll display up until the number 100, and then it will execute, because that will execute that command there, the break. So if we run that, you can see it's executed to the value of 100. But let's look at a better example than what I've come up with so far. So I'm going to comment this code out. I'm actually going to comment the code out at the top as well. Just comment out that variable. So it's challenge time. Okay, so the challenge is to create a method called isEvenNumber, and it takes a parameter of type int. So the purpose of the method is to determine whether or not the argument that's been passed to the method, the int in other words, is an even number or not. If it is an even number, return true, otherwise return false. I'll give you a bit of a hint here to look at using the remainder operator. All right, go ahead and try that out and see if you can figure it out. Pause the video now and come back once you've tried it out and to check what I've come up with. Okay, how did you get on? Let's go ahead and write that method. So we start up with a public static boolean, because we want to return true or false, is even number. And we're going to take a parameter of int and we'll just call it number. That's going to be our number that we're going to use to determine whether it's true or false. So a simple way to determine whether a number is even or odd is just to use the remainder operator like so. So we just do if number, or if the remainder of number and 2, using the remainder operator, I need 2 brackets here actually. So if the answer to that equals 0, in other words, there are no remainders, what that means is that is actually that is an even number. Otherwise, if we do get a remainder, we know that it's an odd number. So that's the way to determine whether a number is even or not. Okay, so what I'm going to do now is we're going to create some code that is going to execute that method. Okay, so this is Tim speaking from the future, where I've come back and recreated part of this video and re-recorded it to go through and make this next step a little bit easy to understand based on the student feedback. All right, so let's continue.
So my code here is going to start with an int number with the value of 4. So it's going to be int number equals 4. And the number we're going to finish on in our loop, which we'll call finish number, will assign a value of 22. So int finish number is equal to 20. Alright, so now we need to create our while loop. And what we're going to do is type while parentheses number less than or equal to finish number. And then we want to open a code block with left and right curly braces. Alright, so now within this code block, we're going to increment the number so that it actually starts with 5 and not 4. So with while loop incrementing, that would usually be the first thing you do because it's easy to end up with an endless loop. So in other words, a loop that never ends. So we're going to do that as the first statement inside the code block. So number plus plus semicolon. And now we want to do a test to make sure that that number, or test to see if that number is not even. So in other words, if it's an odd number. So we're going to type if parentheses, so the not is even number, parentheses number. Then we're going to open a code block there. And what we're going to do is add the word continue, the keyword continue, semicolon. And we haven't talked about that keyword yet, but we'll come back to that. Then after that, outside of the code block, on the next line, we're going to print out some output. We're going to put even number, space, and another double quote plus number. And closing off the parentheses there. Right, so what is this code doing? Well, it's going to start at the number 5, well, actually number 4, but then that number will be immediately incremented. And that's because we've got this code on line 31. And so that it then gets incremented as the first statement. And it's going to go through and finish up to and including the number 20 because we've got a less than or equal if test here on line 30. And what we're doing is we're testing to see whether the number is an even number. Now, if it's not an even number, and we're testing for that here on line 32, then we're going to do our continue, which is something that's different to break. Now, both break and continue have the effect of interrupting the code. So then in the case of continuing, what happens is that it'll effectively bypass the print statement, and in case there are any more statements, all code would be bypassed that's around that area as well. So in other words, continue won't do any code any further down and goes back to the start of the loop instead. So the loop gets finished and goes back and starts on the next number again. But obviously the code is not going to be executed. So that's what continue does. It allows the loop to continue, but it doesn't actually process any more code any further down in the while loop. It just goes right straight to the end of the loop and then back on and starts on the next number if appropriate, if that while condition is actually still valid. In other words, if it's our case, if the value is 20 or less. And then when it starts the loop again, the number gets incremented again. So the first time it goes through, it'll be 5. 4 plus 1 is 5. And if it's not an even number, it'll go through and gets incremented. It keeps getting incremented. And in the case where it is an even number, so if this clause here isn't executed, so in other words, if the number was 6 for argument's sake, you'll see that the value will be printed out here on line 36, but then it too will go back to the start of the while loop and the number will be incremented basically until this if comparison here, this test here, returns false. So if when number is not less than or equal to finish number, we know at that point. So if the number is 21 or higher, that the while loop is going to be exited and processing will complete. Right, so let's actually test this and see if it works. I'm going to run it. So you can see what's happened there. I'm just going to put this run window down to the bottom for now by clicking on this little gear icon and move to select bottom so I can see it a bit better. And you can ignore this red error here. Well, it's actually a warning. That's not affecting the running of the program, and that's been output by IntelliJ and not from our code, which is output in blue, in black as you can see there. But what you can see there, hopefully, and I'll move the code up so we can see it a bit more clearer. Actually, I'll move this up again. Is that we've managed to get this to work. So you can see the output there is 6, 8, 10, 12, 14, 16, 18, and 20. So that's what the continue keyword is. So it basically says stop where you are, continue on to the next sort of test, if you will, so the next condition, the next iteration of the while loop. And eventually down there, So in this case, it was an even number. So if it gets to 6, 8, 10, 12, and you can see at that point, it's actually not exiting, it's actually printing out that code and then going back to the start of the while loop again. So remember here that the do while is effectively identical to the while. The only difference with the do while is that we're testing the value at the bottom, but here, of course, we're testing at the top here within the while condition here. Now, a while loop is probably the statement you'll use more often than a do while loop, but they've all got their place. And as you'll see as you progress through the course, where we start and when we're using these in more details, you'll start getting more of an understanding of where to use each. You know, which one to use and which one's best for a particular purpose. All right, so hopefully now that makes sense with what continue does. I'm going to close down the run window now. So it's now time for a challenge. I'm just going to paste the challenge in here. All right, so the challenge is to modify the while code above. So you want to leave the existing functionality as it is, but make it so it also records the total number of even numbers that it's found, and once 5 even numbers have been found, to break out of the code and display the total number outside of the while loop. So you don't want to break any existing functionality. We still want the output working as it did previously, but we want to add that extra bit of functionality to the code. All right, so pause the video and go away and give that a try. And once you're ready, come back and we can check out the solution that I've come up with against yours. So pause the video now. Okay, so how did you get on? Did you manage to figure it out? Well, let's go through my solution, bearing in mind there's always multiple solutions to a problem. So what I'm going to do here first is I'm going to take a copy of our existing code, including the int on the line above, right down to the closing, the right curly brace of the while loop. I'm going to copy that, and then I'm going to comment that out. And then I'm going to paste the code down here. So we're just starting off with a new version of the code. And we've got the old code in there in case you want to refer to that from the previous code before the challenge. I'm just going to move it up on the screen a little bit. All right, so what we need to do first, we need to record the total number of even numbers that have been found through our loop. So we need some sort of count variable. So what I'm going to do is add a variable and add it here after the int finish number equals 20 line. I'm going to make that int, and we'll call it even numbers found. And I'm going to set that equal to 0, because obviously when we first start, we haven't found any even numbers. Okay, so we've declared the variable. So next we need to record every time there is an even number. So the way to do that is to add this outside of this if test for not being for an even number, or for an odd number rather, because we're doing a not is even number. And we know that continue bypasses this code and goes back and restarts or goes to the next element in the while loop. So therefore we're pretty safe to put the code down here to record the number of even numbers found, because that code only gets executed if in fact we've found an even number. So I'm going to type even numbers found ++ semicolon. So now we've got a count. Our even numbers found int variable is being incremented by 1 every time we find an even number. And we know that this point of the code is correct because when we ran it last time, it correctly printed out all the even numbers. So that's working fine. But to confirm, in fact, that it is working fine, what we need to do is have some sort of output. And we want to do that outside of the while loop. So let's do it out here. So I'm going to print out and type total even numbers found equals, and plus, and obviously that was in double quotes, even numbers found. All right, so let's try running this code and see what happens. Now you can see that it's correctly identified that there's a total of 8 even numbers found. And you can see that matches up with the total here. But of course that wasn't what we wanted to do, so why didn't it exit after 5 even numbers were found? Well, the reason for that was we haven't implemented that break yet, have we? So what we need to do is put in an additional test after the even number is found. So in other words, I'll close down this so I can make it see it more clearly. So basically after the even numbers found ++ line, after this line here, we want to put a test there on the next line that if even numbers found is greater than or equal to 5, and then break. We'll do that like so. So if even numbers found is greater than or equal to 5, then we'll open a code block after closing the parentheses, Then we're going to do a break. The break statement, which we've talked about before, and I'll just make a bit of space there. So now if we run the code, we can see that we've got the print of 4 numbers showing on the screen, text down the bottom there to say total even numbers equals 5. And of course the 5 numbers are 6, 8, 10, 12 and 14. However, we didn't get the last printout, the number 14. And the reason for that is if we look at the code up here, is we're actually putting this test in. This test here is being executed before we're printing out the even number. So what we should have done to make that clearer is change the order. So we can just move this printout here. We're going to cut that, and we can actually put that before the even numbers found plus plus. So we can paste it up here so that the even number is printed under all circumstances. Right, so now we'll run this to test. And you can see now we've got the 5 even numbers, 6, 8, 10, 12, 14 printing. And the text down the bottom shows correctly that at that point in time when we executed the break code, that we had a total even numbers, or the total even numbers that we found were equal to 5. Alright, so that's the while and the do while loops. So hopefully now you've got a good understanding of the various looping statements that exist within Java. And it's time for us to now move on to the next video.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.